one of utter barrenness and desolation. Silence. As there is no air, the only sounds we hear come through our radios. Silence, one of utter barrenness and desolation.
It's more beautiful than I ever dreamed.
The sky is black, velvet black, and pierced by the most intensely brilliant stars anyone ever dreamed of. Utter barrenness and desolation. And the silence.
We gotta have a hype music intro. We're live?
We're live.
We're live.
Welcome.
Welcome.
Everyone. Welcome.
We're
to
here
the
again.
Telehash number 4.
Number 4, Telehash. 256 Foundation, Telehash.
live in Austin, Texas at a Bitcoin park. Ready to sit here on stream for 8 hours until we mine a block.
It's
No
not going to
bathroom
take
breaks?
8 hours, is it?
How long was it into the Telehash 1 when the block was hit? It was quite late.
I think it was 8 hours. We started a little bit early in the day. I think we started at like 10 a.m. or something like that. Yeah, it took a second.
So the energy was waning.
The energy was definitely waning. But that's not going to happen today.
So for any first-time listeners, what the heck are we doing here?
Well, this is the fundraiser for the 256 Foundation. It's a semi-annual. That's what you call it, right? When it happens multiple times a year.
I think so.
Yes, semi-annual fundraiser for the 256 Foundation.
Or is it biannual?
That's a great question. I don't know. It happens twice a year. So whatever you call
That's
that.
right.
Happens twice a year. Fundraiser. And it was memed into reality by our glorious founders, Rod Rudy and Econo Alchemist, out of Bitcoin Park fame and glory. They kind of started talking about this on the podcast, Pod 256. It's like, let's have people point us hash rate and to support the show, right? Instead of like sending donations or whatever, like let's have people point their hash rate to the show and to a pool controlled by the show, and see what happens. And
Right, because for a long time, that was the hashers were just the pleb miners out there supporting Pod 256.
Yeah, exactly. I think they were pooled mining back then, so it was collecting sats from shared mining pools. But anyone who had a miner that wanted to point it in could do it, and then of course they would call out all the people that were donating hash rate on the podcast. And this kind of got going. It became a thing, right? It's like calling out all the people on all the show who were donating hash rate, and they started rolling with it. And it's like, let's do an event. Let's do an event, like a day focused on this, and really try and get people riled up. Like everyone, instead of weekly, let's get everyone pointing their hash rate on one day towards fundraising for the newly created 256 Foundation at that time. And that was January 2024?
Jan 25 was Telehash 1.
Yes, that's right. Okay, so, and I remember talking with Rod and Eco about this, and it was like, well, are you gonna pool mine? Or are you gonna go for broke and like have everyone solo mine? And it was, my recollection of it at least was, it was sort of undecided up until the morning of the event, whether, we're gonna just take the sats or like, go for broke and all or nothing, like go for a solo mine block.
The infrastructure for this too was a future bit Apollo.
Yes. Yeah, future bit Apollo. So
Shout out to John.
John Stephanopoulos from FutureBit had donated an Apollo. It was at the park, that runs a node, and everyone was going to point their hash rate to that node, just connected to the Wi-Fi on the Bitcoin Park network. And I think the call was made like basically right before starting, that like, let's just do this, solo mine, like let's go. And so what we talked about. The show went on, and a bunch of people pointed hash rate. It was a good discussion. Everything was cool. There was lots of talk about, what the 256 Foundation wanted to accomplish, what they wanted to do, like what were some projects, sort of ideas, things that could be done if there was only some money to support developers doing it. And then, lo and behold, 8+ hours in, there's a video of it, which you should definitely go check out. It's pretty fantastic. Eco's like sitting there at his computer, and he's like,
Legendary video.
You guys, oh my gosh, you guys, we solved a block. And it was pretty.
We have it saved on the website. If you haven't seen this, block number 1 is on 256foundation.org. I don't have to play it now, but
yeah, it's a rad video. And I mean, this was the first the first of its kind, right? I feel like this is the first time this ever happened. It was very exciting, solo mining a block, live on stage. I mean, obviously thanks to the miners all around the world, who knows where, that did it. It actually turned out it was good friends of ours, big supporters of the 256 Foundation. Megawatt, it was one of their machines, one of their miners that actually solo mined the block. And then, of course, all the rewards went to the 256 Foundation wallet. And it was like, all right, let's go. All the projects we had been dreaming about, we could basically get them all started. And so this is the summary of the famous first Telehash. But the Telehash was cemented as a important part of the 256 Foundation's fundraising activities to support open source Bitcoin mining development right there on that day. And it's become an exciting show ever since. I guess this is the fourth one, so we've done it 3 other times. And it's really cool. We get to talk about everything that we've been working on, everything that we're doing, the way we think that Bitcoin mining should work, praising the benefits of open source in Bitcoin mining, decentralization, talking about what we're all about, talking about what we want to do, what we're going to do, and of course, getting people stoked to point us hash rate in hopes of solo mining another block, which is exactly what we're doing today. And, because we have had some money to grow the organization and get some rad developers and get these projects going, we've got 2 of them on stage with us here. Schnitzel is deep in concentration right now, so I won't get him involved. He is making sure that everything works flawlessly behind the scenes.
We got word that 2,000 machines are being pointed to us right now, so the server is...
2,000 machines, is that all?
Yeah, the server's getting ready. Or it's... Schnitzel's actively working on it.
All right, so I had an interesting conversation on Twitter with someone today, and they were talking about like stress testing, how much hash rate they could point at there. I think it was an Umbral node. And... they're like, I'm going to get it up to, a petahash. Like, let's see if we can handle it. There's kind of an interesting point here in that it's not the hash rate that overwhelms the node, right? The server resources, as far as the compute on the server machine that's running the node, it's the same if it's a little nerd miner with kilohash or an exahash. It's the workers that cause the strain on the server, the number of network connections from every single worker that causes the strain. So when we have someone saying they're going to point 2,000 workers at the node that we're running behind the scenes here to orchestrate this whole fundraiser, this is a good problem to have. Obviously, we want lots of people to point their hash rate to our show, but keep things working.
We troubleshooted this back at Telehash number 3. Ryan, as the developer of Mujina, the open source firmware, you were playing around with CPU miners, is that correct? How is this tested, the number of connections?
So we added a feature to Mujina to mine with CPUs, which is, of course, not useful on the real Bitcoin network because of the low power of a CPU compared to a modern ASIC. But it is useful for development and testing. So we use it as Mujina developers just as a way to, kind of end-to-end test certain parts of Mujina. But it also turns out to be useful for like a system-level test together with Hydropool. So we haven't mentioned all of our 256 parts yet. But
that's true.
Mujina is firmware for running on miners, and Hydropool is our easy to use, easy to hack on, easy to deploy pool software, one of our 4 major projects. And the Telehash is being run with our own instance of Hydropool. Hydropool is meant for you to run, for many people to run distributed around the world, wherever they're doing mining. We just happen to run a central one for the purpose of our Telehash. It's not that 256 is a pool operator, but we're running a central one for the Telehash.
And this pool persists so that we can have...
This is our donation. This is our donation pool.
Yep, for the podcast and whatnot.
And also a good way to to develop on, right? Real world use case.
We need some stress. Yeah,
but
We're
not in
stress
the
testing
business
it
of
right
running.
now.
we're dog fooding.
Yeah.
Yeah. It gets its best workout during the telehash, but we try to prepare ahead of time by running swarms of Mujina instances that are using CPUs. Because of course there's not an AWS type for I need an instance with 8 Bitmain ASICs.
Yeah, deploy the Bitmain
Yeah,
ASICs.
deploy me to
Please,
the
Amazon.
No, not TPUs. Yes, Bitcoin ASICs. So that's why, for the purpose of testing, it's convenient to run actual proof of work on CPUs, because what puts the load on Hydropool is dealing with a real connection. You know, if you short circuit it to sort of cheat for development, that causes it to skip over the expensive verification of the shares, doing the actual proof of work math that is actually puts the load on Hydropool. So to make it realistic, we can do development at a very low difficulty so that CPU mining makes sense, and we can spin up, I think last time we spun up maybe 4,000 instances of Mujina, first just from a few of our developer machines, and then with Schnitzel's help, we spread them all out in Amazon, like all over the world. So we were
To AWS, do they look at you as a customer and go, what the heck are you doing when you spin up 4,000 little CPU miners? Like,
I don't know, people
would they
probably-
boot you out for that? I mean, they obviously didn't for the sake of the test, but
Schnitzel would know better. I probably for something so short-lived as we were doing, it wouldn't matter. However, one of the features in our CPU miner is you can say how much of the CPU do I want to devote to mining. It doesn't just go all out, you know, because this calculation of proof of work, I mean, it could take as much CPU as you have. Like, there's no limit to this calculation. You want to do it as much and as fast as possible. So we rate limit it in Mujina to say, oh, there's a setting you can say, I just want to use 1% of my CPU. I want to use 50%. And that's for a couple of reasons. One is, like, if you're on your developer machine and you're doing this, you don't want to, like, load down your machine such that it
it's
becomes unresponsive
Yeah.
to you. But also I was thinking, well, in AWS, like, this is a way to, like, tread lightly on clouds, because, you know, if you're just sitting there almost idling, they probably don't care as much. But if you're sitting there, if you're a virtual machine in some hosted thing and you're taking down a whole CPU there, they didn't budget for that, you know. When they thought, oh, we can use this instance for 100 customers, like, that's at a lower CPU utilization. So Mujina can handle that.
what was it like baking in CPU mining support into Mujina? Is this something that was easy to do, well documented, because that used to be the status quo, the name of the game before the ASIC chip, or did it require a lot of work?
It's pretty straightforward, because it's just well-known math on the header. So that the CPU mining portion of it itself is not difficult. It was interesting. It was actually not the first thing we did in Mujina. So Mujina is meant to be, I'm sure we'll talk more about this later, meant to be very universal mining firmware. We want it to be able to run on any kind of system, on any kind of control board, plugged into any kind of mining hash boards, plugged into many kinds of hash boards at once. Hot pluggability is important. You know, you can plug a new board in while it's running. You can take them out. So everything about Mujina is meant to be very modular. So there's, you know, sort of modules, drivers that are devoted to just driving particular hash boards. So this was not the first hash board that the CPU miner just kind of plugs into that scheme as if it's another hash board.
I see.
So it was not the first thing we did, although maybe development-wise it might have made sense, like, start out with no hardware and then add small hardware and then add big hardware, but sort of went backwards. But and added the CPU miner later. So it was more of just a validation of the modular concept, because all we did was make like kind of a virtual hash board that used the CPU for the mining calculation. And it just sort of happily plugged into the rest of Mugina that was already there and already running and kept running. So it was actually pretty easy.
It's coming together now. 1.2 exahash.
Whoa.
Your troubleshooting's working. Schnitzel.
Confetti. What's the confetti mean?
Yeah.
So D++, immediate shout out to her. She made this amazing #Telehash dashboard that we feature every week on Pod 256. And it looks like now, if you donate via Lightning to this Lightning address, donate@256f.org, with a comment, that shows up as a notification embedded in the page, and the confetti indicates that. I saw Dylan already asked, where's my Telehash hat? I forgot it. In my early flight this morning, it was the one thing I left on the table, unfortunately. So I got my pin, 256 Foundation pin.
All right, we'll let that.
I'm
We'll
sure
let
we
that
can
pass.
see that very well
Yeah.
on the stream.
Shout out to D++ again.
Huge.
100%.
So we've had the Telehash, I guess the hash dash running for a while now. People have been getting their miners ramped up, for the last couple weeks. Dylan mostly.
He's loving this.
He's loving this. Shout out to Dylan. He's been pointing us quite a bit of hash rate. His never-ending desire to be on top.
Already dethroned, though.
Oh well, that's all right.
Yeah, I mean, we'll have to get into the dashboard and all the features.
Yeah,
of
we
Hash.
should get into the
Should we do
dashboard
that?
and all the features. Yeah, we should explain all of this. I assume we'll be featuring what's
Referencing
going
it,
on
yeah.
here throughout the course of the event. But there's a lot of cool stuff going on here. This is really amazing to see.
So this is our HydroPool instance, our open source mining pool that we are running and hosting throughout the course of the year for the Pod 256 podcast, as well as the Telehash events. You can see the total hash rate, average hash rate, active users and active workers, as well as a miner share and the history chart here. But what's cool, where you have the instructions to point your hash rate, if I hover over this, because this is a self-hosted open source pool, we can modify it. Jungly, the developer of HydroPool, has modified it to really unlock a lot of features, whereas you don't need a Bitcoin address to be your username. Why don't you talk about that?
Yeah, normally when you're when you're solo mining or using sort of decentralized pools, they want you to put the payout address, the Bitcoin address, as your worker name, right? And so that's where the funds will go when you get paid out. Of course, here with the #, all the payouts go to the 256 Foundation wallet. So that's hard coded in. And so we kind of have this room to use the worker name how we want. And we're chatting about this and had the ideas like, well, I don't know, let's give the ability to put in Nostr npubs, Twitter username profiles, and websites, right? And we can kind of add the social aspect to it. Jungly and D++ set out to work on it, and it's really cool, right? So now instead of showing some long wallet address in the list of worker names, we can show people's social details.
It's totally gamified.
Yeah,
it's
cool.
dash.256f.org.
Yes, correct. So not our main website. The #, is dash.256f.org. If you hover over the instructions here for the Stratum user and worker name, you'll see some examples of how to specifically reference a Nostr npub, your X handle, your website, thanks to D++. And you can see as we go down here, it totally gamifies the whole dashboard. Look who's in #1 place already, Electron. Shout out to Electron with 1 exahash connected to the pool right now.
Coming in swinging.
2,067 workers. I'm not going to click expand on that. Amazing.
Shout out to Electron.
The cool part is their username is their Nostr npub, which if I click this, it would open the Primal app on my Mac, so I won't do that. But if you are viewing this on your dashboard or your mobile browser on your phone or computer, you can click that and it'll take you directly to their Nostr profile where you can give them a follow. Second place, shout out to Nice Hash. I know some of them are coming in for the later parts of the Telehash here today, as well as the Texas Energy and Mining Summit hosted by Bitcoin Park over the next 2 days with 125 petahash. And the list goes on. We're going to continue to give shout outs to all these organizations and individuals over time. Megawatt, longtime supporter, actually the ones that mined the block
Yes.
in Telehash number 1 and had the highest difficulty a year ago here at
Yes,
at
that's
Telehash
right.
2 for the first Texas Energy and Mining Summit.
Yes, those are some lucky guys. They do mining hosting. They build out mining data centers. I think they're in the Indiana area.
Correct.
Yeah, give a shout out to them. Those are some solid dudes over there at Megawatt. Really appreciate their support.
Definitely. And Dylan renting a lot of hash rate. This was popular, actually, launched at Telehash 3 back in January of this year. The Brains Hash Power hash rate rentals, where you can just send some sats and bid on a bidding market for various amounts of hash rate for various amounts of time. It's a really quick and fun way to point a lot of hash rate to the pool. There's a couple other tools. NiceHash as well offers that, as well as Wrigley, who's been a supporter for Telehash number 4, which we'll see on here as well. So definitely go and point some extra hash rate. Even if you don't have more hash rate at home, you can buy hash rate for the duration of the event.
Nothing wrong with that.
Yeah, and I know we do this because we're going to hit multiple blocks today.
Multiple.
But one of the things I've had fun with, even at the last 2 Telehashes where we unfortunately didn't hit a block, was just seeing. It feels like kind of a touch point throughout the year on our community and on mining in general. Like you were saying, like these hash rate markets didn't exist, or they weren't very well known during the first Telehash. That wasn't really a thing. Not even Telehash 2. And then in Telehash 3, like, you sort of saw it trickle in and people were playing with it. I don't know. So it's kind of like a state of the industry kind of recap. I mean, as much as we get to see. And just exciting to see. I mean, it feels like all the supporters out there, like, this is a way to, like, indicate, like, hey, I'm out there. I think this is cool. I care about mining, decentralization. It's just kind of a way to signal, signal that the communities signal to each other, like, hey, we're all out here.
And it's so
With these
awesome to
numbers.
see sort of repeat supporters
Yeah.
and new people showing up. And, what do they say on the telethon is, pledging their support, right?
That's right.
Getting folks pledging their support to this movement, which, we're all very passionate about. And it's cool to see other people jumping in and sending us their hash rate or sending us sats. You can do that too.
Yeah, I mean, Wrigley here as well. They also are supporting us for Telehash number 4. If you go to wrigley.io, there'll be links to the Telehash information directly on their landing page. But this type of event has even caught on. Wrigley hosts block parties, which are effectively recurring Telehash events, not in direct organization with the 256 Foundation, but they offer the opportunity to effectively rent hash rate or point your own miner to what they call a block party that happens every so often, once or twice, a couple times a month, where you team up with a bunch of other miners and say, listen, I'd like 500 terahash for the day, and if we do solo mine this block together, maybe we have a couple petahash, we're going to split the rewards. So they split them in pool payouts in that instance, but it's kind of like hash rate gambling, Point a little bit of electricity, send a couple of sats, buy some hash rate, and you might get paid out big. So it's cool to see this type of event catch on in that regard.
Yeah, it is. It's fun. I remember back in the day, there was a guy on Bitcoin Talk. I forget his name, but he would like regularly organize essentially block parties. But it was just all through these posts on Bitcoin Talk, and he would just try and get people to like commit early to sending their hash rate, pooling it together, and then splitting the rewards, kind of like these ad hoc shared mining pools. It's a pretty interesting idea.
People are winning blocks. Solo miners are hitting blocks at a increasing pace. Let's see. Let's go through a couple more here. N21, Proof of Work, link their Twitter profile. Let's go. Daryl Zero, I don't know who you are, but you're a big supporter. I saw you came online early this morning, maybe even last night, with a petahash here using Brains rental, Brains hash power, and a bunch of Bitforges and Bitaxes. What's the Bitforge?
The Bitforge is a cool project. So it's an open source home miner. It's a small one, and it was instigated by WantClue, who is the lead developer for the Bitax firmware ESP miner. He's a leader of the Open Source Miners United community. So him and Duncan, IMGPO, and Kila, a developer in Europe, they got together and just said, like, let's make a Bitax fork. I know Duncan was, very driven to make it beautiful. Maybe we can pull up a picture of it on the screen. It's really cool. It's very nicely designed. It's got a great enclosure. They made a custom heatsink for it.
Can I Google it?
Yeah, Bitforge. I think it's like bitforge.io or something like that. But you can. There.
Oh yeah, this one.
Which link should I go to?
Go to the DTV Electronics one.
Let's see. Load.
So yeah, I mean it's got the BM1370 chips in it, the same ones in the Bitax Gamma and the NerdQX series.
Oh boy.
But as you can see, it's got a very beautiful enclosure. They did a lot. It has got some cool LEDs inside, and they actually redid the dashboard that goes with ESP Miner.
We'll let that load for
It's
a
got
minute.
a simplified dashboard. It's really cool. It's this is exactly what we want to see in open source mining. Is people are like, I want to create a miner that does XYZ, and you can just do it, right? Obviously, it's not super trivial, but you can just do it, and that's exactly what this group of guys did with the Bitforge Nano, and they're getting them produced now. We saw the link; you can get them on Amazon, and it is an open source project. So
Fantastic.
you can know exactly how it's working. You can take it and fork that if you want, right? Create your own miner. And I think they have the Bitforge Nano Ghost Edition. It's got like this window in the front of it and this little statue of Satoshi inside. So it looks really cool.
I'll let that load for a minute. We got a lot of stuff going on here on screen. Let's see who else. We got Compass Mining with their Twitter profile and their website linked as the worker name. Shout out to Compass, another hosting provider.
Nice.
They've got a big presence in Denver, Colorado, my hometown. And it's awesome to see them supporting, so appreciate you guys, Compass Mining. A lot of new people here that I don't recognize. Fantastic. Crank it up.
Crank it up.
We know the Guardrail guys. Zarka, longtime supporter of Pod 256. Bitmain sucks. Nice worker name. I'm sure we'll get into that. Saz Mining as well, another hosting company. It's really cool to see the hosting providers show love for the 256 Foundation and the projects we're building. I mean, we're going to talk extensively about this, but our vision is not just home miners, but miners that solve challenges and overcome problems for operations of all size.
Yeah, that's right.
Oh,
that's right. I think
looks like it disappeared. I'll have to refresh the page. There's a lot of hash rate coming online. We're ramping up.
this is the good kind of problems to have.
Michael said he found an issue.
We found an issue.
That's good. It means there's
Pizandy says, ba ba booey.
too many people with the dashboard open.
Oh yeah. We probably didn't load test that.
We're fixing that. Yeah, I don't think we load tested the dashboard. Well, the good news is, as we fix that and hop around between different sites, another thing courtesy of D++ is the Telehash Chrome extension.
Yes, browser extension.
The browser extension, that's right, for Chromium browsers.
For those inferior websites that don't already show
And
the
it looks
Telehash stats, now you can add them.
Amazing. I even saw a live comment come in here. I guess that is baked into the browser extension, not just the dashboard itself.
I've seen Lightning notices come through with just the header.
We'll make sure to reference those every now and then. 1.2 exahash, 2,202 workers. Top hasher, you can see here, Electron, best share, Electron, 426G, and highest loyalty. Man, they came in with the full sweep.
They did.
We
They
are
just
tracking best share.
coming and swinging.
Loyalty, we should talk about
We should
loyalty.
talk about loyalty. That's
a new
cool.
feature of the hash dash at dash.256f.org. And then obviously the top hasher in hash rate as well. Okay, so how does loyalty work?
Loyalty is essentially a leaderboard for the highest number of hashes, right? So this isn't hash rate like hashes over time. This is like total number of hashes that you have sent, right? So you think about a miner that sends in 1 terahash per second. That's 1 trillion hashes every second. So if you ran it for 1 second, you would get 1 trillion hashes, right? But this is basically multiplying by time to get the total number of hashes that you've sent. The idea being is that this is, I guess, the distance that you've traveled, not necessarily how fast you're driving. And it tracks, over time how many hashes you've sent. And we know that the more hashes, the more likely you are to solve a block.
So we need some large units for this,
Yes.
particularly a supporter with 1 exahash per second.
Yes. What is exa is quadrillion?
Or tera is trillion.
Tera is trillion.
Peta,
Peta is
quadrillion.
quadrillion. So exa is quintillion.
Quintillion.
Yeah, we start getting out of the realm of like units that anyone.
Are we ready for that?
even
We ready for that
recognized.
load test? Do we have high
10 to
enough
the
units
15th?
What's
to
that?
to
10 to the
track
15th?
loyalty?
Is that exa?
Okay.
Well,
What
an
you-
exahash is a million trillion.
So we might see a loyalty in the zeta range.
Yeah. Yeah, definitely.
Sorry, Dylan. He tried to turn on his miners a few days in advance to bootstrap his way to the top of the loyalty leaderboard, but I don't think it's going to hold, unfortunately. Well, this is exciting to see how that plays out. And then also I see we're tracking here blocks found, so that's good. Regardless of which web page we're on, we'll be able to see that.
The loyalty is like the pure proof of work, right? You can't fake that. Like those higher numbers come from just, consuming more energy to create those hashes. But you can still win on best share, right? Best share is a single hash. It's just extremely lucky. So that's the lottery side of things. And obviously your chances of getting the best share are higher the more hash rate you have, but it only comes from 1 hash, so anyone could do it. As evidenced by the fact that at the first Telehash, the block was solved by Megawatt, which did not have the highest hash rate pointed to us. So it's anyone's game.
Anyone's game. 1 singular ASIC chip will solve the block.
1 hash from one singular
hash.
ASIC chip in 1 machine. It's pretty crazy to think about. Like, every single block is solved by a ridiculously lucky hash.
Yeah. Like 1/1000th of the circuit within 1 chip
Yes, that's right. Yes.
during 1 or a few clock cycles. Like, yeah, it is insane.
It is insane. It's insane to think about.
Absolutely incredible. Well, it looks like we're back online here. Let's scroll down, see a few more supporters right here at the start of Telehash number 4. Okay, we talked about SAS mining. I see Josh here. Awesome. Josh is doing some cool stuff. It was great to see him at the Heat Punk Summit back in February. He's got that pink S19 that's water cooled,
Whoa, really?
120 volt, but it's an open loop. So he uses it as his water heater on his RV. So the water that flows through it becomes his domestic hot water. It's like a direct, a tankless hot water heater hash rate.
So his
heater.
like shower water has gone through his miner.
Or
water
I
block.
think he had it connected to the hose, yeah. So it wasn't icicle water from the well at a RV park.
That's amazing.
Amazing. He's doing some cool stuff here with his Nostr
His
profile.
worker names look pretty rad. So
Hydronic 2, Hydronic 1. Yeah, he's hacking on water heater, camper van water heater, filament dryer. That's a heat punk at heart for sure. Fact 777, also a longtime supporter, and he was at the Heat Punk Summit. We appreciate having your hash rate online. DJW with a couple Avalon Qs and bit axes. Oh, look at that. The hash rate heat punks. The Snorkel hot tub. Shout out to Snorkel.
All right, you better tell us what this is.
Snorkel is a wood-fired hot tub manufacturer dating back to the 1970s. That's where they get the name Snorkel. So if you think about a hot tub heater, usually there's a little pump box, or in a modern plastic hot tub, it's hidden underneath the seats, really. An electric source. Sometimes you can get propane or natural gas heated hot tubs as well. But they reference back to wood-fired, where you actually had this little cavity in the circular wood tub, and you would feed firewood into the side of it. And then the smokestack, kind of like a camping stove, right? Or you'd see them in a cabin home. It's in the hot tub. So the smokestack comes out of the water, and it looks like a snorkel.
Okay.
So that's where they get the name
This makes
Snorkel.
sense now.
Oh, okay.
So they still offer these wood-fired hot tubs, as well as propane, electric resistive, natural gas, etc. But now they offer a Bitcoin heated hot tub. So if you go to snorkel.com/Bitcoin, there is a hot tub that we have at our Bitcoin hub in Denver, Colorado, the space. We got one for the Heat Punk Summit. It's beautiful natural cedar hot tub, and it's heated by a single S21 miner in collaboration with my friend Dane from Hashrate House, who built the single miner immersion tank, and it's all married into the pump controller. So that miner turns on when it needs to keep the hot tub warm, and it turns off when it doesn't need to. So it's on right now. I told my buddy Joel back at the space to go pop the lid off and let it cool off. Luckily, it's cold in Colorado today, so we get more hash rate from it. But you'll see it come on and off. It's wicked cool.
That's amazing. And so you get a nice toasty warm hot tub, which I've been in. It's amazing. And it generates waste Bitcoin.
That's right. Waste Bitcoin. Let's see. Save to downloads. Download. Yeah, we're going to take a look at it. It's not me sitting in there nude. I haven't been in there nude. There's a school across the street.
That could be problematic.
It's a beautiful hot tub, though.
It is.
It's in its break-in phase right now, where the water turns blood red from all the tannins. The natural cedar, it doesn't have any sealants on it, so it turns into basically hot tub tea.
It's good for the skin.
It's great for the skin. It smells amazing. There it is.
Oh, look at that.
And
Glorious.
then shout out to Woodminer, who made this fantastic Heat Punk logo when you pop the pump box hood. He carved that out of wood from his sawmill, and the wood he dries uses hash rate. I think he uses the future bit that he won at one of the either NEMS or TEMS.
I think at that first NEMS.
He's just got it in his small little storage for the wood, and that dries it all out pretty quick.
Yeah. He cuts down the trees, he mills them into boards, and then he kiln dries the wood with a kiln that's heated by Bitcoin miners.
Correct.
And then he has a whole CNC milling setup to like carve cool stuff, of which he made that rad plaque, and I believe he made the trophy for the Heat Punk of the Year.
We had a Heat Punk Innovation Award trophy that we handed out at the summit this year, awarded to this hot tub, to Snorkel and Hashrate House, and Woodminer made that as well. One other fun fact about Snorkel is they are the same company that makes the hot tub from the movie Hot Tub Time Machine. So it's that same hot tub. It's a hot tub. It's a hot tub time chain machine. I got it.
Yes, all right.
Took me a couple tries.
I can't say that.
Yeah, say it 5 times fast. So awesome
So
to
it's
see
a
that
famous hot
online.
tub.
Rehash heating, another heat punk, making some cool stuff like the Stealth Miner into some heating appliances, powered by hash rate. Let's see here. Bobby Pin with an Avalon Q. There's me. Backwater Mining Collective. A Q and a couple bit axes. Drop Fiat. Avalon Q, those are pretty popular. Quite a few of them on stream. Shout out to Public Pool. Top Secret Project. What's he hacking on?
Ooh, top secret project. What's the hash rate on that?
5.7.
5.7 terahash. Very cool. Very cool. Public Pool. Shout out to Ben behind Public Pool. He is involved in all sorts of amazing open source Bitcoin mining projects, all facets of it. He makes a rad solo mining pool called Public Pool. Publicpool.io. Public-pool.io, I believe.
A lot of solo blocks found on Public Pool, yeah?
Yeah. Yeah, both the hosted version, and the cool thing about Public Pool is that Ben hosts a version at public-pool.io that you can connect to and just point your bitaxes or whatever miners that you want to it.
And it's still solo mining.
And it's solo mining and no fees. I think that's probably one of the only solo mining pools out there that has no fees.
So this is great if you buy a bitax, you don't have your own node, you don't have a Start9 or an Umbrel.
Yeah, and that, I mean, Ben has been involved in the bitax project for a very long time, and he actually created this pool so that we could test the Stratum implementation that goes into ESP Miner, the firmware on the bitax, because I'm sure we'll talk about this, but Stratum is famously undocumented. Stratum v1 is famously undocumented, so it's making a client is kind of just a brute force sort of project. And so he created Public Pool so that we could test that. He's also very involved in the development of ESP Miner. But yeah, he runs it. He self-hosts it, and no fees. And for that reason, it's the default pool on bitax on ESP Miner firmware. So if you get one and you don't have any idea how this works, and you just want to plug it in and get going, it'll be pointed to Public Pool. I think it's really cool. It's an open source project, no fees. In my mind, that is ideally everyone would mine to their own node, but that requires some extra setup. So we want to have a default in there, and I think there's no better way to have a default setup than
That's pretty
Public Pool.
slick. So you just connect your bitax to Wi-Fi and give it a Bitcoin address.
Yeah, that's all it takes.
Fantastic. Yeah, shout out to Ben.
And then he's got Little Bobby Tables, which I assume is some sort of SQL injection attack on our server. So thanks for that.
Yes, with 4.5 terahash. Mentioned rehash heating. Econo Alchemist, shout out, who couldn't be here with us today, one of the co-founders of the 256 Foundation, along with Rod Rudy of Bitcoin Park.
A legendary,
Legends.
a legendary person in the Bitcoin mining space, right? He's been doing Bitcoin mining education, writing articles on how to do this, since the very beginning.
Before the bitax, home mining was...
Yeah.
There was a brief stint where it was very hacky, very discouraged. People seemed to be saying, you shouldn't do this, no, no, no. And Eco was one of those proud and strong voices saying, you should and you can do this, here's how to do it.
Yeah. When I was trying to figure out how to do it for myself, his articles were at a fantastic reference, because he was one of the few people that was saying, no, look, you can do this, here's how you do it. An incredible resource that was an important part of I think where we are today in getting this, getting mining into the hands of, all Bitcoiners.
I'm sure we'll do a breakdown of the organization and all the projects that we're funding and your roles as lead developers. But Eco is the project manager across all 4 core pillar projects. So huge asset for the organization, making sure we're committed to our deliverables, the projects are making progress,
And one of the nicest guys you'll ever
one of
meet.
the nicest guys you'll ever meet,
Fact.
that's for sure. Who's this guy? Scott
I don't know,
9000.
some anonymous miner.
Okay, what's this referencing? You guys, we just...
That is a quote from Eco Alchemist, from the first Telehash, where he was just sort of staring at his laptop on stage while we were just
And he's,
talking about something.
squinting and looking closer
You
and
can see he's
closer.
just getting closer to his screen. You can tell as he's loading mempool.space and double checking it. And then the first thing he says is, "You guys, we just..."
hit a block. Hopefully we can say that again today. Hash Chaser UK, shout out to Hash Chaser. Handful of machines online. Blockchain G33K. There's Woodminer. Love you, Woodminer. Canadian Hash and Coin and D++, 2 more long-term supporters of the Hash Dash.
Too hot, see you in the autumn.
Must be hot
up there in Canada.
Up there in Canada, yeah. There's the Bitforge Nano that Dee's got. Looks like she's got one. An Anon named Hydra. Gyre. You want to talk about Gyre? Shout out to Gyre. And we just got to chat with him yesterday on the Mujina Dev Call number 2.
Yeah,
Should we talk about that for a little bit?
sure, we can. We held our second dev call, just online chat, video chat, every other Monday. We advertise it on forum.256foundation.org. It's on the calendar there. It's all public. And yeah, we just started, so we're still getting our legs under us and trying to make the best use of that time. But the idea is that the people who are interested in working on Mujina, who can show up in the middle of a Monday, which is a surprisingly large number of people to me. I was blown away by the interest. We had at least 12 people on the first call, and almost as many yesterday. And we just get together and, you know, since it's early days, just sort of talk about the vision for the project, the architecture, debate, you know, what direction we should take some certain things, because we're still at that point where there are some high-level decisions to be made. Yesterday
Which is a great time to get involved. It's a great opportunity.
This is a very high-leverage time to be involved, yes. We could use all the help we can get, and there's plenty to work on. And yeah, this is that point where you steer it 1 degree, and then, you know, 100 miles down the road, you've made a multiple mile change because of that little tweak you made at the beginning. So we're trying to get, so to that end, there's some decisions that we recognize are important that we're trying to get right at the start. Yesterday we had an extensive discussion about configuration files and persisting changes made through the API and how those things interact, how those things get distributed throughout the code in Mujina. You know, those can be tricky interface challenges to solve because this is like kind of a global thing, but you don't want to infect every piece of the code with this, how do I have this connection to this central thing? You don't want to make a mess out of it. So, and then just how should it work, you know? Does a setting from this part of the API overwrite something the user configured in a file, and how would those things interact? So those are the kind of things we discuss on the call. And yeah, Gyre actually, credit to him for sort of bugging me, reminding me several times, like, hey, it'd be a good idea to do a call. It'd be a good idea to have a call. We should do a call. And I'm like, yeah, that's a great idea, but it's so easy to be busy with other things and not actually put it together. So he actually pushed until we got it put together. So I appreciate that.
Oh, look who picked up the mic.
Oh, that must mean something good.
Just a little stressful first 50 minutes, but we're back.
We're back.
Yeah, so
You just
I
fixed
think
it
you
live
mentioned
on
it.
stage.
We didn't load test the dashboard.
I forgot. Yeah, oops.
Yeah, so we spent all this time load testing the pool, and the pool worked the whole time.
Okay.
So
Pool was cool.
everybody that saw like errors, whatever, this is just technically it's a Prometheus cluster behind that feeds the data. But yeah, it turns out we hit the limit on the cache.
Oh, really?
Yeah, so technically it's an Nginx server that sits in front of the Prometheus to caches it. And for the longest time, the errors we thought are coming from Prometheus, but it was actually Nginx that had a limit of the amount of connections
Oh, okay.
and the amount of file opens. And we increased it already, but it wasn't enough. So
Wow.
it's
For
all
like the
running.
static content of
Yes.
the. Oh, wow.
Yes. Because so we have, it seems like we have around 500 to 600 people that have the dashboard open.
Wow.
And
We got
each
to
of-
pump those numbers up.
Yeah, and
Pretty
He
cool.
says, yeah, nervously.
and everybody refreshes like the stats, and this hits like one endpoint. And we knew that the Prometheus that does this couldn't handle it, so we added a cache, but we didn't actually ever load test the cache. So it was a good test. Thanks everybody for DDoSing our servers.
Well,
this works a lot better now. So
We'll have to add that to the checklist for next time.
yes, yeah. The good thing is, right, all of this actually is becoming open source. So it's all built by Ansible. For anybody that ever used this, is like a system to manage servers. So everything that we're learning here will become open source, so that anybody that can run their Telehash with multiple thousands of miners.
Well, it's a great point because I think there's the Bitcoin veterans, they do their version of the Telehash, and they have a fork of the Hashdash that D++ made. So, yeah, to your point earlier, Ryan, these events really do put us through our paces, and it forces us to improve everything, the whole stack.
Yeah, what is really cool, like everybody is trying to help out. So like immediately while all of this is going on, Electron, like they created a Telegram group with their ops people because they wanted to know if they should shut down the miners so that the servers can recover.
Oh, wow.
So it's really cool.
Thankfully,
like
we didn't
seeing-
have to do that.
We didn't have to do that, yes. But
So-
it's just really nice to see how the community
So
comes
remind us,
together and helps
what's
each
the
other.
architecture here? So Hydropool itself has an API, and it is pushing stats to a separate Prometheus server.
Yes. So how it technically works is, so Hydropool basically just exposes a metric endpoint. So it's an HTTP
Prometheus
server.
pulls.
Correct. And Prometheus goes and loads the data because Hydropool doesn't have a lot of historical data, right? It knows how much hash rate there is right now and all these things. And then Prometheus basically queries that data from Hydropool and stores it in its own database. And then the dashboard that you load in your browser is querying Prometheus directly. Now, Prometheus is not made for this like high traffic. So we actually have an Nginx server in between that caches these. And so only every 30 seconds a request actually goes through to Prometheus. And all the other requests, so like we have around 100 requests a second right now, they're all cached on the Nginx level. And this way, yeah, we can have hundreds of people having the dashboard open and real-time updates. But the good thing even, right, and that's what we just saw, even if Prometheus fails, Hydropool is unaffected by this because all that Hydropool is just it opens up its metrics and like people on the dashboard cannot take Hydropool down. That's not possible. And so that's why in the background the hashing was still going on. It's just the stats that didn't perfectly update. And that's how you want to build.
Hashes are safe.
The hashes are safe. Correct, yes.
Well,
And yeah,
that's
that's how we have built it last. Like the last Telehash, this was the same, but we actually started with more users in our one now than we ever had in the last Telehash. So it's definitely
we ramped up fast.
yes, correct. And as usual with server management stuff, you worry about one thing mostly, and like you test
And then the
everything
other thing
there,
happens?
and then another thing that you never thought about. Because right, like we don't build the web servers and the Prometheus. That's a solved problem, quote unquote.
Yeah.
And we focus a lot on the pieces that we built, not realizing that maybe other stuff could also fail.
Hydropool is working as expected.
Yeah, this is only the second Telehash we've done with a with a Teledash. Is right? Is that right? This is only the second time we've had
Yeah.
the dashboard.
Yeah.
Yeah, so the very first time we had nothing at all. What was the node called?
The future bit.
The future bit. Yeah,
bit.
so it has
Just
a
the
dashboard,
future bits
but we
dashboard.
didn't expose the data to anybody.
Right.
And then the second Telehash, we actually used a combination of our own toolings, but we didn't have the dashboard yet. And then for the number 3, she figured out how to load the data out of the Prometheus directly and show it on the server, or show it in a nice dashboard that we're looking at now.
Yeah, let's walk through the history of previous telehashes and the milestones at each before we get into all the updates we have today on progress of the project. So Telehash 1, we were using FutureBit Apollo as the node in the mining pool, and then that's when we hit a block. That ultimately led to the initial funding for a lot of these 4 core pillar projects and the lead developers here on stage with me today. And then at Telehash 2, that was in this room about a year ago at the Texas Energy and Mining Summit. Remind me, guys, I think we had an initial version of Hydropool and Ember 1 a year ago. Is that right?
Yep, that's right. We had a initial version of HydroPool,
Which was a fork of CK Pool.
which was a fork of CK Pool.
Yes.
So it
At
was
the
sort
time.
of a first
Yeah.
pass at the time. It's not anymore, but that was what we were running at the time.
And actually, that Telehash showed us that this is probably not the best approach. Because for anybody that knows, CK Pool is not very well documented. It's built by one person. And so, yeah, during the Telehash, we actually ran into segmentation faults, like the worst things that can happen in programming, like just the kernel or like having some weird memory issues. And we actually had to roll back our fork of it, and we just deployed the regular CK Pool on that day. And me and Zhongli, like, we spent time in the background for like 2 or 3 hours trying to fix it.
I remember your last year. You were head down in the
Yeah.
back
Yeah,
with a
sitting over
laptop.
there.
Correct. And so that was one of the things that Zhongli then decided, hey, like if we really run into these weirdest issues, the fact that the code is just, like there's basically one person in the world knows how all of this works, it's probably not a good base. And then he decided to re-implement it all in Rust. And now that's the version that we have running since number 3 and 4, and it's running rock solid. Like the CPU usage on the server is extremely low, it's super highly efficient. So yeah, if anybody has some more workers, bring them.
Point us your workers. Let's stress test this thing. And we know, at least with HydroPool, we know if there's problems, we know who to blame.
Correct. It depends.
That's true.
You, John,
We can call it.
If it's the dashboard, then it's me.
So after that, we then had.
well,
the
we also in the back had an Ember 1.
That's
I
right.
think it was version 3.
Aviv? Oh, I was going to guess it was a 4, but yeah, maybe a 3.
Maybe it was 3 or 4. We had one Ember 1. It was just kind of sitting on the table with like a jury-rigged heatsink on top of it, and I think I had strapped 2 fans to it because the voltage regulator was overheating, and I had it connected to a Raspberry Pi. It was sitting back here. I feel like the live demos of miners are not quite as flashy as a dashboard. But yeah, anyways, that was running.
And then the rest of that year, the rest of 2025, you guys were head down focused on these 4 core pillar projects, the Ember 1 hashboard, Libra control board, HydroPool that Zhongli's working on, and Mojina firmware. And then come January of 2026, this year, it was the first time that all 4 projects were running together in a cohesive system. And Ryan demonstrated that, which with a system that he actually brought here today as well, so maybe we can show that off in a little bit. But that was huge to see it. I remember it was a late night the evening before up in one of the offices at Bitcoin Park. There was some good hacking going on, a couple pizza boxes, a couple of beers, and a power supply.
Many soldering irons,
Many soldering irons.
microscopes, hot air gun.
We were just talking about that. That was really
that was
fun.
fun.
We actually need to do that more often. But
Yeah.
it was the first time that, like, in person, all the parts had come together.
Yeah, so an open source hashboard was mining controlled from an open source control board running an open source firmware to an open source pool that it was pointed at all in one go. And it was a great demo system because it was actually doing something with the heat that it was off-putting. It was heating a bath of water that had a couple steaks in there acting as a sous vide. And if anyone recalls, we got it up to, 110 degrees? I mean, it sous vide those steaks. We ate them later.
Oh, we got to 120.
120.
Enough to eat it.
Perfect. Yeah, that was an excellent demo. We'll make sure to show that later. Let me get through a couple more shout-outs here as we work our way down, then we can scroll back up to the top. Shout out to Dread with 3-bit axes on the hash dash here. That's fantastic.
Dredd is a badass. Shout out to him. Appreciate the support.
The Operation Bitcoin crew, as I mentioned, they do their own version of the Telehash. Make sure to stay tuned for that, where they have now a fork of this dashboard, so they'll be using the hash dash as well for their Telehash moving forward. Satoki, poo poo pee pee. Someone just wanted me to read
Gotta
that.
say it.
And pee pee poo poo. Is that you, Mike? And P Buttweiler.
There's a hold on. Go up at the top there. There's a very interesting worker name.
Oh yeah,
Intel
Bitaxed.
I
You
don't
think you know what that is?
I think I might know what that is. I don't know for sure. hard to tell, but well, we've
It's
been
the right hash rate?
yeah, that's about right. That may very well be Johnny and his work on the BitAxe Bonanza, which is a project that's underway. The initial source for both the hardware and the firmware are published on the BitAxe or GitHub repo, but it's a BitAxe that runs the Intel chips. Proto donated 256,000 of these Intel chips to the 256 Foundation. I don't know, like a year and a half ago, I guess it was. And the Intel chips are kind of an interesting story that goes way back, several years back. Intel, the Intel, had a Bitcoin mining ASIC project, sort of a skunkworks project, but they built real ASICs, which is a huge task. They built real ASICs, and they manufactured a zillion of them, and then they canceled the project. So there was no further development on it, but there was like, I think I've heard rumors that there's millions of these chips
Is
sitting
the fact
around.
that they had millions of them made mean that they killed this very late in the project cycle?
I don't know. I don't know how these things work. They're like, oh, let's give this thing a shot. Let's make a couple
think.
million.
Seems pretty late.
Yeah.
No, I mean they had a full, they had a team of amazing engineers working on this because it's extremely difficult and extremely expensive to design, much less build a mining ASIC. And so they did it. Obviously, they have some experience with making chips. But yeah, they made this thing, and then I don't know exactly what happened, but they just decided, yeah, let's just cancel the project. And so, from what I understand, the team was laid off or transferred to other projects, and they kind of wound it down. But the fact of the matter is that these chips still exist. They are a little bit outdated by today's standards, the latest chips from other manufacturers, but they're still very capable Bitcoin mining ASICs, and they're available. Documentation is a little iffy right now. There's some people working on getting that documentation out there, but yeah, we have a handful of these chips, and we've made a miner, a BitAxe miner with it. It's the hardware is in its third major revision, and it seems to be working pretty good. The firmware is kind of in its prototype stage right now, but it is mining. I'm pretty sure that's what it is. Maybe I can confirm later, but yeah, it's mining 1.2 terahash. That comes from 4 of these chips, so you can do the math. They're not particularly high hash rate chips. They're sort of like S19J Pro era efficiency and hash rate per chip. But yeah, they totally work. They're out there. They're extremely low cost. This first batch was free. I think that's probably going to be the case for most of them, considering they're not useful for any sort of commercial mining application because of their outdated efficiency.
Yeah, and so Proto donated a large batch of these chips to the 256 Foundation.
Yeah.
And then the 256 Foundation went about issuing these to people that requested access to them, requested however many they wanted, really.
Yeah.
And projects that come to mind is like the Proof of Print, the Bitcoin miner that heats the print bed with hash rate ASIC hashboard elements. Pazandi, who's running that project alongside Adi, who's helping him with a lot of the hashboard design. I think that they got some. What other projects got some of the Intel chips?
It was, oh my gosh, the Beekeeper. Oh, Ronald. So Ronald got some of the chips. Ronald is working on a project called Satoshi Starter. It's an education-focused
That's right.
Bitcoin miner. That project is underway. They're working on it. Ronald has some association with the team that initially designed these chips. So that's cool to see. He's got access to the chips again, and he's working on it, and that will be an open source design.
Be Evolved?
Yes, Be Evolved. Be Evolved is another community member that got a hold of a chunk of these chips, and they're doing some very interesting heat reuse stuff. I think if I recall correctly, there was a project just posted the other day about like incubation or keeping like birds warm. I'll look up the.
I think it was an incubator.
It was an incubator for birds. I think there's been some beekeeping related projects proposed. Also, just a small open source miner that's approachable for anyone, just to easily assemble a small miner. And then the public pool, Ben got a hold of some, and that's where the ones that are powering the BitAxe Bonanza, as we're calling the BitAxe miner that uses it, are coming from.
Fantastic. There's Pizandy with the proof of print BitAxe, and yeah, he's working on a 3D printer itself. I know he came back out to Colorado. He was at the Heat Punk Summit, but he came back out to Colorado for a 3D printing conference, and he brought his 3D printing hashboard printer, as well as he's got a filament dryer that keeps the humidity low for that filament. After you open it, they kind of go bad if you let them sit in a humid environment. And he was featured twice in Tom's Hardware, which is pretty cool with both of those systems.
It's awesome.
That's really cool. That's really cool. There's so many like amazing, interesting heat reuse cases, right? Stuff I just could have never imagined, right? And it's so cool to have people have access to this stuff so they can just give it a try, you know? Hobby stuff, commercial stuff.
Yeah, here it is. There's the filament dryer.
So, all right.
The first prototype was based off of Avalon Nano 3S that he hacked apart. What were you going to say?
Well, I believe Pizandy and Audi are working on a solution with the Intel chips.
Yes.
But I just like wrap my head around what a filament dryer is. So 3D printers use plastic filament. It's what's on that roll, right?
Yeah.
The filament feeds into the 3D printer, but you need to dry it out for some reason.
It gets wet. It's, what's the word?
They absorb moisture.
Hydrophobic?
Hydrophilic.
There we go.
Yeah, so if you open a pack of a reel of one, a spool, I guess, and then you don't use it for a couple months, and then you try to use it again, it will just kind of gunk up the 3D printer, the filament, the nozzle head. It'll snap. It gets brittle.
So it
it
just
loses its
absorbs
properties.
moisture from the atmosphere
Yeah.
into the plastic.
into the plastic.
And then when it gets reheated, it can be bubbly or oozy, or
Okay.
it doesn't flow the same way anymore.
Yep. Steam
And
bubbles.
and it can happen within a day.
A day. Okay,
or
so
two in humid conditions.
if you want to do high quality 3D printing, you need to put your spools into a filament dryer and
Yes.
drive off that moisture.
Yeah, he
Yes.
says for filament like nylon and TPU, I mean, it's critical. So these products exist. I mean, here's a link to a non-Bitcoin mining version of one, 150 watt resistive heater that's just constantly on.
Yeah.
That could be a substantial
Generates
amount
no
of hash rate.
sats.
I think there are ideal temperatures for each filament type, but
Okay.
I've got one that I normally run at like 60 C,
Okay.
so it's just about
That's no big deal for a miner.
right for a miner, like kind of low grade
There's Pizandy looking
heat.
pretty proud of his awesome
Proof
creations.
of print. Shout out to Proof of Print. And Audie's helping him too, I think, with this.
He's not in a hockey jersey.
I know. He usually has a hockey jersey. That's how you know it's Andy if you see Pizandy if you see him at a conference.
And one of the things is, so I talked to some like print farms. One of their biggest expense every month is electrical cost,
really?
because each of them is producing a lot of heat, because during the print you continuously heat the print bed, because these filaments, they stick to the bed when it's warm.
Okay.
So you continuously heat them.
Yep.
So there's people that spend thousands of dollars for electrical heat to run these Bitcoin these printers. So if we could somehow have a drop-in replacement that just mines some Bitcoin instead, because these mining ASICs, they can totally get to the temperature, right? You need to run them at like 60 degrees Celsius.
And it's interesting too, because the print bed doesn't necessarily have any forced cooling on it, you know. So you'd have to find the sweet spot where the chips don't get too hot. I mean, there's some real engineering that has to go into this, but definitely a viable solution.
Like I could totally see a service where you go to a print farm and you tell them just replace these print beds, and that's it.
Or your filament heater.
Or your filament
dryers.
heaters, yes.
your bill
But,
stays the same, and
your
you'll
bill
get,
yeah,
and you'll get a
the
bunch
Bitcoin
of Bitcoin.
goes to the person that built the whole system.
Yeah.
Like why would, and maybe you give them, I don't know, a rebate, as we learned, on like 20% or 10% of their electrical cost. you cover. Like the person doesn't even, or the company that runs the print farm doesn't even need to know what Bitcoin is. All they get is 10% off their electrical rate. It would be a complete no-brainer. And all they maybe lose is, let's say, maybe an inch of 2 or of height.
Right.
But most 3D printers, they have, the problem is X and Y,
Not the Z
so much the
axis,
C
yeah.
height. So it would be a completely no-brainer to do this. And obviously then think about the actual printer producers could just integrate it by themselves. The printer has Wi-Fi access anyway, because you want to remotely control them.
That's right.
So, yeah, it's the perfect use case for using like older chips. Totally, yes. Brand new chips would not make sense at all, because the cost of the chip, you would never mine as much Bitcoin, because you cannot, as Tyler mentioned, there's not enough cooling. But if you have these older chips, these Intel chips that lay around and you can use them for free, that's the perfect use case for these.
Yeah, it doesn't like come off as a super sexy miner to use these older generation chips, but once you realize that how much cheaper these older generation chips are, then these applications where you need the heat anyways start to make a lot of sense. A lot of sense.
Do you have a picture of the first version of the 3D printer? It's literally an S9 hash board laid on the side and with a printer on top.
Really?
Like that was
That's
the
so
ultra first, which is crazy. Like this is like the things.
This?
No, it's
'Cause this,
way
I think,
earlier.
Yeah, this I think uses the coffee drying or the coffee warmer
coffee mug
hashboard
warmer,
from
yes.
Gecko Science. Yeah, as this first prototype. I mean,
But I remember attending your first Heat Punk Summit. What year was that?
2025. Yeah, so it was just a
2025.
month after Telehash 1.
Yeah. So
The
before
block
we
had
had
been
kicked off
hit.
these projects.
Yeah, but the projects were in everybody's minds, not in
Yeah.
reality.
And I remember touring the amazing display of all the different heat punk devices like this, and they were all very cleverly engineered, but sort of hacked together from, like you say, like the print bed of this thing was a coffee warmer Bitcoin design from another project, and like, an early version was a S19 hashboard on its side with a thing on it, like all these projects that were like that, and thinking, boy, I'm so excited to start to build the pieces and the designs in 256 that are destined for people who make products like this, so that they don't have to turn an S19 hashboard on its side and sort of MacGyver something together out of. It's amazing what people have built with these off-the-shelf parts. But part of our mission is to give them the ability to custom design circuit boards, software, anything they need to optimize it for exactly making products that aren't designed to be Bitcoin miners first. They're designed for their end use case.
Oh,
I think
But it's work. My point was, projects like Andy's are sort of the inspiration for like, oh man, we got to give these people some good tools.
I got some photos Andy just sent me that I'm going to airdrop to my computer of this S9 version. Let's see here. Oh yeah, look at that.
Oh wow.
Yeah, that's real heat punk.
So this is just aluminum plate without fins.
Yeah, so do you see the fins on the other side?
Yes.
So he removed, because the hashboards have fins on both sides, so he removed them on one side, replaced them with an aluminium flat.
I've not seen this
Like,
before.
and
Andy,
and
this
then,
is awesome.
And then some Kapton tape, and that's it. That's your
Couple
first
big
prototype.
the fans on the bottom.
That's amazing. Let's
Yeah.
see what other ones.
I
he's
mean,
got
guys
here.
like this have really led the way,
This
right?
is so cool.
To this heat
Oh, there it is.
reuse idea. When did you first start seeing heat applications of this? Like, what inspired you?
I went to a Denver BitDevs meetup, I want to say in 2020, late 23 or early 24, and some guys had hacked together S19s, or no, they were S9s at the time. Very similar to the project I'm showing on screen here, which is, Josh with his Hydro single-phase S19 camper water heater. They were mostly space heaters at the time, so there had been a couple guides out at that point with the 3D printed enclosures and the quieter Noctua fans, and yeah, then I fell down that rabbit hole. And tying this all back into the 256 Foundation, I think a lot of the smaller miners, we'll talk later at length about the larger miners as well and the benefits they get from an open source stack, but a lot of the smaller miners felt the immediate pain, which is, hey, I want to do some certain thing with my Bitcoin miner, some certain useful application, or I want to control it in a certain way, and it was totally locked down. It required a lot of extensive reverse engineering, hacking, retrofitting to make that work. And that largely has been in the home miner space, specifically hash rate heating, because these things are designed to be data center infrastructure that run 24/7, not for these utility-based applications, be it solar monetization, or I know even like the gridless guys have had some pain points with the control of certain machines because their load is not as consistent as we have. They're off-grid in micro energy applications in rural Africa. So. Yeah, I mean, this is the future, I think, of a large amount of hash rate, but it's amazing to see all of the retrofitting, the hacking, and the new applications that people come up with to solve a specific problem for them. All this is on the Heatpunks forum, heatpunks.org, if you're curious to check it out. It's awesome to see the photos from Andy. Let's see what else he sent. Oh, yeah. This one's cool, Michael, where it's got the nozzle. This is one of those cool 3-axis, I don't know what you call this.
Wow.
It's like a tri-axis printer.
Delta?
Delta. Printing something. So amazing to see.
Some cool like inverse kinematics to figure out Delta printer.
Yeah, they better have a good slicer.
Yeah.
There's Schnitzel's fish tank axe in a fish tank of immersion oil.
Uh-huh.
Have you ever had to maintain that thing or no?
No, it's running since probably 2 years now.
Okay.
The oil has a lifetime of 10 years, so that's what the spec says.
Is the screen at least visible through the oil so you don't have to pull it out to change the pool?
Yes. It's completely immersed in it, so
Yeah.
sometimes I have to take it out. But funny enough, the Wi-Fi goes through it. Like everybody was worried that like it's limiting for the Wi-Fi.
Oh.
But the router is maybe like 3 feet away, so
Gotcha.
I don't think it's a big problem. Yeah, and it's just sitting there. There's also a nerd miner in it. And funny enough, I had 2 bit axes in it, but it got too hot.
Are the fans on the BitAxe?
Yeah.
Okay.
Yes. So the fans are on. They're turning very slow. There's a lot more resistance than the air, but it nicely. And the whole axe, the whole fish tank is now.
It's probably nice and
Like-
quiet. BitAxes are.
It's super quiet.
I wouldn't say they're loud, but the dynamic fan speed sometimes your ear catches the change in frequency of the fan. You know what
Yeah,
I'm talking about?
But
Yeah,
in the
oh, I
fish tank, I
definitely know what
cannot.
you're
There's
talking
like, yeah.
They do that all the time.
You can turn off automatic fan control and set it to whatever you want.
I did do that. We have one BitAxe that's in our lobby in Denver, and when the sun sets, it comes through the window, and it just shines right on the BitAxe, and it overheats every day at 5 p.m. Yeah, I had to move that one.
It's so cool though. Like people have these really complicated immersion or hydro setups, and Schnitzel's like YOLO and just like throws the whole thing into a
Yeah.
fish tank full of oil. That's badass.
I mean, that's the constant thing about that oil, right? Like, you can just literally put whatever you want in it, and the fans still work. I actually did some tests with some FS19 fans. They really don't like the resistance, so they measure their, I guess, their current draw, and so they turn on and off all the time. But some fans are really stupid, and they just turn very slowly, and you can use them to actually push more oil through the miners.
Oh, nice.
It can't hurt the cooling, that's for sure.
Correct. Yes, because one of the interesting things, at least in my tests, a lot of this immersion stuff is really made that the oil that comes back into the tank is nicely cooled down, right? Because these are these massive immersion systems that go outside in dry coolers, and then like the temperature that comes back is maybe like 40 degrees Celsius.
Yeah.
But in our case, where I'm using it for the heat, like if I heat up a water tank in my house, the oil that comes back from the heat exchanger from the water is maybe a couple of degrees colder than the miner itself. And so you really run into a problem that inside the miner where the oil goes through, it heats up way too much. So what I'm actually doing is I'm putting fans at the bottom to push the oil faster through the miner.
I see.
In this way, I can extract a lot more, or the miners just overheat a lot less. And so that's one of the things that, like, yeah, that you just realize that nobody thought about building this immersion systems or this oil for a way to really extract as much heat as possible. And so, yeah, you just have a tank, and I literally tested. I have like 15, 20 S19s at home, and I saw, oh, there's different fans. So I put the little test rig, and I just put each one of them in it.
Because your home is heated with an immersion system?
Yeah. Well, now it's hydro.
Now it's
so
hydro.
I switched to M64 hydros. But
And-
it used to be
And where do you
full-
land on that scale? Pro hydro, pro immersion?
full pro hydro.
Plus one.
The first time that you shower in immersion oil, I think the scale goes full hydro, yes. Or like I had leaks, and like because this oil, it never goes away. Like wherever it is, it's gonna be forever.
That's good to know. There's just not that many
I
hydro
tried to
miners
show
out
you
there.
a picture. That's me. I don't know how this works.
Get
I
airdrop
guess we're
code?
not friends. Oh, okay. All right. I got it.
773459.
Well, that's a one-time code.
What is this?
All right, so this was just posted on the 256 Telegram. It says, Bidax immersion in a bucket full of dielectric and a beer wort chiller hooked up to an aquarium chiller.
Oh my gosh.
So this is taking the fish tank X to the next level. They're actually cooling the fluid.
That's awesome.
That's
It looks
pretty cool.
kind of overkill.
But you know, you can just do things.
Probably a
But it
really,
looks-
really nice and happy Bidax. It's probably nice and cool.
That's a cool heat sink on it.
That is a cool heat
That
sink.
is a cool heat sink. The crossflow, yeah, with the vapor chamber.
Yeah.
So
That's
there you go.
wicked.
You can just do things.
You can just do things.
That's the point.
All
Like
right,
with the-
Western Mass Bitcoin Meetup. Shout out to them, another longtime supporter, Pod 256, and then Plunger here. I think that's everyone. We went through the first list. We'll come back to this in a little
By the way,
bit of
look
time.
at the difficulty leaderboard. There's just
Oh yeah, so we got to make our way down. That's right. Okay, so now this is the difficulty leaderboard, where we're tracking the top 10 highest difficulties submitted.
Yeah, I knew that was going to happen.
yes, it's all Alex.
Shout out to Electron,
Shout out.
to miner 172x220x5x117.
That one's a champ.
Nice hash on the leaderboard, and Daryl still holding out strong. Good job, Daryl, with your brains rental. So what's the highest difficulty? 426.25 G billion giga. What do we need to win? 100,
like 100 something T.
150 T.
150 T. Well, we're going to be tracking
No
who
big
gets
deal.
the highest difficulty. Let's see. Thinking of you, Megawatt. And then the loyalty leaderboard, counting the total number of hashes. Electron already at 4,292 exa hashes.
Yes. It's not exahashes per second. It's just
Nice.
million trillion total hashes.
Right, so if they've got 1 exahash per second, then that's roughly 4,323 seconds they've been contributing.
Yep. That's a lot of hashes.
You guys got to see over the next several months until Telehash number 5 in Nashville in January of 2027 if you can dethrone whoever has the highest loyalty leaderboard from this event today. You just have to keep your hash rate pointed at the pool for every day.
No big deal.
No big deal.
With 1 exahash, yes.
Nice, followed by Nice Hash, Megawatt, Dylan, Dylan
Hey, he's still on
dethroned,
there.
Wrigley, Block Party, Telehash, Exergy, Daryl, N21, Proof of Work, Tesserae, and Compass Mining. Yeah, so that's the hash to hash made with love by D++ for the 256 Foundation and powered by Hydropool. Look at this. We're live and strong. 1.3 exahash, guys.
Oh, that's a lot.
That's awesome.
1.3 million trillion hashes per second. Every second.
2,213 workers online. Let's keep it coming. Yeah, look at that. Okay, so we should talk about each of the 4 projects, give a refresher before we talk about them working together as a cohesive system with the box that's in front of me on the table here, as well as the demo system that Ryan brought. The 256 Foundation was founded to open source the Bitcoin mining stack. We've said it other ways before, like dismantling the proprietary mining empire. We don't mean that in the sense of dismantling large miners. I know we're talking about small heating systems here on stage, just geeking out for a little bit, but what we mean is that the mining industry, the current status quo, is largely proprietary. There is a monopolistic company, Bitmain, that has 80+% of the market share, followed by some others that make up roughly 99.9% of all ASICs manufactured today. The firmware is closed source. They don't sell chips or components at an individual level, so the actual chips, you can't just buy them and then make whatever system you want. There's no documentation for these chips. So it's a package deal, right? I think you said it well on a podcast you did recently with 2Sats, the home mining pod. It's like saying, I want a wheel for a car, and you have to go buy a Lamborghini just to get the wheel and tear the wheels off.
Exactly, yeah.
And maybe you want to put them on a dump truck, but yeah, you have to buy the Lamborghini.
And there's no information about how to attach this wheel to your car.
Yeah, and you have to build the dump truck. Yes, yeah, correct.
Easy.
So the mining industry is not really fitting along with Bitcoin's ethos of don't trust, verify, open source, inspectable, easy for other people to spin up their own instances, make their own systems, open source software and hardware. And the 256 Foundation was founded with that challenge in mind to solve. That's why there are 4 core pillar projects that were defined by the organization, by Eco and Rod and team, to go fund and tackle. And that's what these developers, as well as Jungli, who is not here today, are working on. So let's start with Scott, what you're working on and how it plays into the system, and then we'll move down.
Yeah, so the project I've been working on is called Ember One, and it is a hash board. So for those who don't know, hash boards are circuit boards that are a component of miners that have all the chips on it. So the mining ASICs that actually do the hashing, they're all attached to a hash board. The BitAxe, it kind of has all these components all in one, right? It's the control board, the hash board, the power supply, everything is all in one. But if you look at bigger miners, basically all of them, they'll have the chips on these separate hash boards. And usually there's like 3 hash boards in a miner, and it'll contain anywhere from like a dozen to 100 chips per hash board. The Ember One project was just sitting down and talking with Eco, and it's like, we should see if we can make an open source hash board, right? Because those don't exist. There are none before. This is a sort of a modular. It's a modular hash board, one that you can take and make up an entire mining system, however you see please. But it's much higher hash rate than the BitAxe. It uses more power. But yeah, the initial goal was like, let's just make a hash board, a higher, that would be a component of a higher hash rate system, and of course do it all open source and totally documented.
So is the thought here, if the ASIC manufacturers aren't going to release the documentation, the data sheets for how to communicate with these chips, we're going to have to go do that work for the community?
Yeah, that was definitely part of it. I mean, a lot of that came from the BitAxe project, a lot of that reverse engineering, like how to talk to a chip or a couple chips. And then what Ember One is adding into that is like how to connect a bunch of these together. Because the chips themselves are actually designed to be connected together in a large array of them with lots of chips together. And that isn't really very well expressed in the way that the BitAxe and the NerdQAxe and those projects are laid out, because they're just a handful of chips. So the idea is like, yeah, let's show how you deal with the higher power that comes from a higher hash rate hash board, like how you deal with that electrically, how you connect the chips together, and try and come up with this board that could be used to build your own systems, but then also a design that could be used to make your own hash boards, right? You can take these concepts, clearly showing how all the chips are connected together, and you could scale it up even further, right? If you want to make a even higher hash rate or even higher power hash board, you can use the concepts that are in Ember 1 to do that. And of course, it's, again, totally open source, open design systems. So, you can see how that's done. I mean, there's a little bit more work than this, but you could take and like copy paste these circuit board elements, the schematic and the board layout and stuff, and replicate it bigger. The Ember 1 hash board is nominally 100 watts. If you got a hash board out of S19, that's going to be like 1,000 watts. So, it's a little bit smaller. There's a little bit more manageable, I think, for people to work with. Definitely when you get into higher power, you get higher current and just more problems all around. So we're starting, it's a smaller example of a higher hash rate miner. And, there's definitely lots of challenges to overcome there, but the goal is to show how it's all done, make a hash board that you can take and make cool, miners out of, miner systems out of, or just hack on it. And we had, there's been some ideas about how hash boards could be done better. A lot of them typically connect over these ribbon cables. They have lots of circuit elements on them that I think are a little bit difficult to deal with. They require a lot of legwork on the firmware side. They're a little bit tough to interface with. They're cost reduced. Like the hash boards in commercial miners now are like cost reduced to the absolute bare minimum, and they kind of put that difficulty off to some of the other components in the system in interfacing it with. So one of the big ones was like, let's make this USB connected. So that's the data, not the power, but the data that comes to the hash board. That's how all the chips get the work that they need to mine and how they send back the results. On the Ember 1, it's like we were actually, initially we were just going to have it connect over a ribbon cable just like all the rest of the hash boards did. And then Ika and I were chatting. We're like, oh man, let's do this over USB. Should we do this? Can we do? Yeah, let's just do it. Let's just YOLO, give it a try. Turned out to be not all that hard. I wouldn't claim that it's totally working perfectly yet, but now we have a hash board that connects over USB, and so you can plug it into a Raspberry Pi. You can plug it into your laptop. It's USB-C. I could plug it right into my MacBook, and assuming I can get power to the hash board, I could just mine, directly from any computer. That's cool. I think that's helpful for developers who want to just have something on their desk. They're working on firmware. They're working on mining pools, or whatever. But then also it kind of gives you this ability to make a full mining system that's more modular, that's more expandable, customizable, because your control board just needs to have USB ports. Like you could even have, I guess we need to work on this, but in theory you could have a USB hub in your miner and connect as many of these hash boards as you feel like you can power. I think that's pretty cool. That makes it a lot easier to play around with it, to develop on it, to see how it works and improve on it. We've done a lot of the work on the voltage regulator to make it so that we can have a wide input to it. So the power input to the hash board, on the Ember 1, it accepts 11 to 18 volts. So you can plug anywhere in that range, you can plug that into your Ember 1 and power it that way. And as long as you're in that range, it doesn't really affect mining at all. So if you had some system power supply that's coming from solar panels or hydro or whatever you want to come up with, it gives you a little bit more versatility on how to power the board. And then we have a voltage regulator on there that steps that voltage down from 11 to 18 to the voltage that the actual chips need. But we've got a lot more controllability in there. With that voltage regulator, you can adjust the voltage, you can monitor the voltage, and I think really cool, and this is not something that any other hash boards have, you can actually monitor the current of the hash board, which is really important when you are trying to determine what is the efficiency of this miner. If you're trying to tune your miner and get the best efficiency out of it, you really want to know the actual power. Some other third-party firmware for S19s will show you the power, like the watts that it's using, but it's just a guess. because they don't actually measure the current. So they're giving you an estimate based on some previous characterization they've done on those chips. So yeah, measuring the current is an important part of the number one, just kind of one of these cool features that we thought we could add and that would be useful to people building with these systems.
So let's think quick before we go to the next project. How does a platform like Ember One help everyone from the smaller guys tinkering with mining systems that might be heating a 3D printer all the way to the large miners? Things that come to mind for me is for someone like Pizzandi building his 3D print bed, who maybe doesn't know how to make a hash board, right? That reference design exists so that he can modify it. He might not have to do that much modification, or maybe make it a little bit larger up to that 150 watts like that other competitive product exists for the filament dryer. But then for the larger scale guys, what comes to mind for me is, a lot of these hyperscalers, these massive miners. I'm not speaking for them. I'm not one of them, but I imagine it must be annoying if a miner changes form factor. What if they wanted to converge on a standardized form factor for the hash board so that all of their rack space could be treated as infrastructure, kind of like what Proto has done with the rig, right? But now they could make their own standard, and they don't have to start at ground zero with the hash board itself. There's already an open source hardware reference design that they can use and modify to their liking, and then converge on that eventual standard. Does that sound right?
Yeah, I think that's a really important point. We were looking at these pictures before. People have come up with amazing heat reuse mining applications, like amazing things. They have hacked existing miner hash boards into all sorts of cool projects, right? We've seen this, and those are fantastic proof of concept for what can be done with hash rate heating or adapting miners and hash boards to different applications. But one of the things that has struck me is that we need to make products. And I think a lot of these people are pushing towards making like real products, like commercial products, industrial products that you can just go out and buy. And you cannot go to market with hacked Antminer hash boards in your product. Like, that's just not going to work. Like, you cannot go to your contract manufacturer with this like truckload of old S19 hash boards and be like, cool, make some water heaters. Like, that's not sustainable. That's just not going to work. It's going to be a support nightmare. Like, you do not want to go down that road. What you actually need is a real hash rate heating device that is built for your project, for your product, for what you want to get done, and has all the necessary components in there to reliably do what you're trying to do. And that, I am convinced that means making your own hash board. Whether it's going to have different electrical requirements, it's going to have different safety requirements, different control requirements, and different form factor requirements, right? Like, hash rate water heaters is a fantastic example. There are several products where they're doing that. They're going down that route. Space heaters too, but you can't do it with these repurposed data center miners. It's just not going to scale. We've seen a couple people try to do that, and they quickly realize that's not the right path to be on.
I don't even think you can get UL certification, because to get that certification to keep your homeowner's insurance and the licensed plumber doesn't get snipped, all of this stuff, like, you have to, when you're building the product, submit the data sheets and documentation for all the components that make your product, right? And so if one of the suppliers is Bitmain's hash boards and there's no reference material on it, you can't get it certified for safety reasons.
Never going to happen. Never going to happen. It's going to be just this crazy engineering process, because you're just relying on this black box that you don't control and trying to force it into this other mode of operation that it was not designed for. So it's going to be a whole world of headaches. And one of the main things that the Ember One seeks to be is this reference design, right? Like, it is probably not going to be suitable for your water heater as is, but that's fine. Like, this is how it works for lots of other electronic components, is there are reference designs, and the manufacturers say, here's this reference design that shows you how to use these chips, but you wouldn't just buy the reference designs and put them in your water heater or whatever your end product is. You would use those designs, which are, all the documentation, all the sources provided. You would use that to build your own product, to inform that, to sort of show you an example of how it's done, so that you can go forward and make your own product. And that's what the Embra One serves to be for what I think is easily the future of Bitcoin mining.
Yeah, this is how end product electrical engineers design a circuit board.
Yeah.
They start with a reference design,
They start with a reference design. They start with documented components.
documentation, reference design.
Reference
from
design.
the manufacturer typically.
Yeah. They build it. They build it into whatever form factor they want with all the specs they need. They test it. They revise it. This is how like all electrical products are made.
And if the manufacturer of these chips are not going to provide reference designs and documentation, then we've raised our hand and said, well, we'll do that.
How does a reference design hash board help larger institutional miners that are buying humongous order quantities of these machines, having to repair them, ship them off, buy massive pallets of more ones when they come out? My interpretation is a standardized form factor would probably be hugely beneficial to the large players that are buying that many boards. Do any other ideas come to mind?
I mean, the more that you can understand about how your main revenue generators, that is the miners, work for your company, the better that's going to be, right? If you're running 200,000 of these machines, they're going to be breaking all the time. Even the best designs, they're going to be breaking all the time. They're going to need repair. And the more that you can understand about how they work, the faster you can get them fixed and get them back into service and making you money.
And not only that, I mean, an open source platform, a hardware platform, a reference design, a standard that might emerge, it also opens up the potential for way more repair shops to sprout up that know what the heck they're doing, right? It streamlines everything when you're not reliant on one monopolistic provider for the industry.
Yeah, the way that repairing Bitcoin miners works today it's actually insane. It's insane. You know, a lot of these come with warranties from the manufacturer, but those are kind of bullshit. A lot of times the miner will break, you'll send it back to the manufacturer. They're like, oh, it's totaled. Like, sorry, like here's some coupons for the next one.
So much so that all the big dogs have said, screw it, we'll do it ourselves. We'll figure out how to reverse engineer these things. We'll have our own inherent knowledge that they learn over time and they keep it in-house. And they're just saying, we're not going to go ship it back to you. We learned how to fix them ourselves.
Yeah. I mean, I think a lot of the times they'll ship these miners back to the original manufacturer for warranty repair, and they're just like, nope, it's broken. Like, and you're like, what? And they're like, oh, you can pay us to ship the broken one back to you. And it's like, I'm just getting screwed here. So, yeah, this whole third-party repair industry has sprung up, but there's such limited documentation about these that those people that are doing those repairs, like, they're guessing about this stuff. They have built up tips and tricks over the years of doing this, but they're really trying to operate at a disadvantage because they don't fundamentally, it's not documented how they work. And so they do a lot of reverse engineering, and it just like trial and error, like, oh yeah, like I've seen this error before, and the last time I replaced this and it started working, so I try that. It leads to much more expensive repairs that take longer, work, they don't work quite as well. So I think, that's just ridiculous the way it currently operates. And I think a better way of doing things will emerge through what we're trying to do here through open source, well-documented stuff. And this old way of doing things will just be forgotten.
Yeah, it's ridiculous the way it works today. And I'm sitting here thinking, well, we are not single-handedly going to document and reference design the world. But we know that that's what it should look like. And so we're going to start building in that direction. And ultimately, as we are a part of showing that that's how it should work, here's some corners of the industry where it does work that way. This is open source. People get a taste for, oh, well, this is handy. Why am I not getting that from this other manufacturer? And maybe we can change the norm.
How does it work in the current electronics industry? Who's the main buyer of reference hardware designs for different chips? It's system builders, right? It's not people that end up putting them into products. Maybe some very passionate DIY folks, right? But it's system builders. It's other.
You're right. It's builders of all types, right? It's engineers at companies that are trying to develop a new product. They will get these reference designs, right? And a lot of times the manufacturers will manufacture the reference designs, and you can get one so you can actually hands-on try it out. But yeah, it's engineers who are building things that are the main buyers of these reference designs, because they're tasked with like, make this thing that works, that does, X, Y, Z.
And the chip manufacturers want to sell more chips.
Yeah, this is the ridiculous part, right? The big chip manufacturers outside of mining ASICs, they spend tons of money and time and effort. They have staff dedicated to making these reference designs that they essentially give away, for free, or at least sell them at cost, because it's marketing. It sells more chips, right? If you're an engineer and you're tasked with making this thing that does X, Y, Z, and there's, let's say, 3 manufacturers that make chips that do basically what you want to do, or make a component of what you want to do. As an engineer, the first thing you're going to do is go and research all those chips, and the one that has the best reference design, the best documented, that seems like it's closest to your application, you're just going to go with it. You're just going to go. It makes your job easier. It makes it so that you can get to what you're trying to do faster. And so all the major non-ASIC chip manufacturers push this. Like, they will send a field application engineer to your office to rain these things down on you for free, just to convince you to go with their product so you buy more chips, because it sells more chips.
A fully proprietary in-house stack does exist in other industries. I think of the Apple ecosystem, my MacBook that's sitting in front of me. They now design their own silicon, right? I know you know a lot of Apple lore, Ryan. Like, that's where we're that's where we're at now with Bitmain, for example. They make the firmware, they make the chips, they make the chassis. I'm sure they have suppliers for the fans and the power supplies, right? They define the whole system. I don't think we're saying that might not ever exist. I mean, right? You could still make your own closed-sourced, full-stack system yourself, and you just have to win over the market and make it better than everyone else. What we're saying is the open-source building blocks have never even existed for people to understand how these things work under the hood and to go build what they need. Is that fair to say? Anyone? It seems kind of backwards where we're at right now.
Oh, no, 100%.
Yeah.
But, like, imagine you would tell a house construction company that that any truck or digger that they build, that they buy, they're not allowed to repair, or there's
Right.
no documentation on how to do it, and things like that. Like, that's
I guess
nobody would go into this industry than like the Bitcoin miner that already are in it. Like we will never have other companies that come from another world enter this industry, because they look at this and it seems like kindergarten to them, like how we work.
I guess I bring it up because it seems like the market does sometimes decide for these fully integrated stacks. Like, I mean, even John Deere, to your construction analogy, they are reducing right to repair, right? They want you in their system.
Correct.
Apple's whole ecosystem, it was a big, massive breakthrough in computing power when they actually stepped away from Intel and x86 and went to Apple Silicon. So I guess I'm wondering is like, will that end up being the winner in the end anyways? Because you should speak to this, Michael, because you have a lot of experience in seeing open source take over the world. Why don't you talk to this? Because I'm trying to play devil's advocate against myself here, which is like, will we ever catch up? Will the guys that are good at it ever make it? Will the guys that are good at it ever stop being the best? I mean, I'm already trying to fuse my own argument because I don't think they're the best. I think the systems are kind of shit. But just talk on this for a little bit, like open source versus the full stack, the full integrated stack.
I mean, myself, I've been now in open source since 25 years, right? In every industry, for me, open source is like this virus or this cancer for proprietary. As soon as open source touches it a little bit, this idea spreads throughout everything. And you see it, like, if you look back into operating systems, for years, the only real operating system that there was a Windows system. Like, every server in the world ran Windows because you knew what you get, but you also locked in. If you want to change something, you couldn't. But people At the beginning, they were just happy that there was even a server. And then Linux came, and when I started, like there were people that were saying, "Oh, you should use Linux," but it was hard. It was hard to use. But over time, yeah, if there's an actual problem, you could debug it, you could figure out what's going on, and you can fix it. And so, specifically on the server level, like today, nobody's using Microsoft Windows Server unless you really, really have to, because like maybe you use Outlook on the back end, you have like Active Directory stuff. But if you just want to have a server, and the best proof point is that actually Microsoft, which runs in Azure, which is a public cloud, there reports that 70 to 80% of the servers, they run Linux. So the company that used to build the tool that everybody used, and then Linux came, they are now their own user because they realized that it's just a lot better to use that. And connected to that is they are now one of the biggest contributors to the Linux Foundation. So for me, that's just like one of the best case of showing that open source over time, like I remember 25 years ago, people said, oh, next year is the year of the Linux desktop. Like that's the thing, we're still joking about that people are not using it on the desktop yet, but on the servers. But it happens over time because eventually everybody will realize it's just a much better system.
Yeah, it can become better because you have the whole world acting as your developer community, right?
Correct.
You're building on top of one another, but also something that I learned from you guys was the de-risk angle. When you're a large institution, you don't want to be reliant on a domino that might fall and topple your whole business.
Correct.
And so open source in that sense aims to solve that problem by saying, hey, we all own it. It's
Correct.
all of our
Yes.
problem.
Yeah, and that's what big companies are doing today. So I went myself as a service provider that uses open source to make money. We've seen that where companies used to say, no, open source, this is insecure, to now they're demanding it. Like if you bring a software and it's not open source, you have a lot higher or a lot more problem actually deploying a software inside the data center or just for a customer. Because if it's open source, they can verify it, they can check if the code is secure and all that stuff. But also, as a service provider, I cannot lock them into a world. Like if I bring proprietary software and for whatever reason, my customer doesn't like me as the company because I'm providing a shit service or whatever, if that's proprietary software, they need to think about not only removing me, but also the software. If the software is open source, they can say, well, I'm just kicking out Michael, but I'm teaching my own team how to use it, or I find another provider, right? In Linux today, if I have a company that runs Linux for me, there's thousands of Ubuntu or Debian Linux managed service providers, and I can literally pick them off the shelf and just bring them in. I can even run 2 of them at the same time if I want to. But with proprietary software, that's not possible. And interestingly, a lot of companies realize that, enterprises, that this is a massive reduction of risk, because one of the biggest thing with these like multi-million-dollar contracts, like it's the lock-in. If you bring proprietary software, I'm basically binding myself to my vendor, possibly forever. And companies used to do this willy-nilly. They were like, that's okay. Why do I even want to use another one? Right? And now in the world that we are today, which is very uncertain, things change all the time. Yeah, a lot of companies are doing a risk assessment, and that involves risk of vendors, and open source fixes that.
I saw that back when I worked in the aerospace industry. We were using Fortran, and whenever we had a problem, we had to call some 80-year-old guy who retired 20 years ago to come in and help it because we were reliant on him.
Yeah. But one of the crazy things, I just sent you a LinkedIn signal if you maybe want to open this up. Right? We're talking about software. All of this happens also in hardware. So Facebook actually started an open compute hardware project, which is a project that shares reference designs for data centers. And what you can see there, do the PDF.
Yeah, the first one.
Yes. This is crazy. So look at this. So this is by Google, a 127-page PDF that describes exactly how a data center is built, with every fitting, everything.
Please load. I'll let it load for a minute. Keep talking.
Yeah, so I'm opening it up on my side, and we can see it there. So basically, they're describing every single thing from how you build the data center, how the racks are connected, how the fittings need to be of the cooling system, things like that. I don't think we can see it.
I don't know
If you
why.
reload.
Sorry, guys, my computer's slow.
Anyway,
so
we're
why
gonna
would
look
they,
at it later.
Why
but-
would they open source this?
Okay, so why do they open source this? Well, as a
Oh, there's us.
think about your Facebook, right? And you have thousands of data center all over the world, and you want to standardize them, right? Because if you have one PSU or one rack in one country, and then it works completely different because you have another vendor in another country, right? Because every vendor in every country, and it also doesn't make sense to buy them all from the US because shipping them all over the world is also crazy. So what you end up with is you end up having different data center designs in every country. And if one of them fails, right, you cannot learn from it. You cannot reuse it. It's all about repeatability. Industrial scale is all about repeatability. And what you end up with is having different data centers, completely different in different places. So what they said is, we're going to standardize, but we're going to open source the standard. So instead of saying you need to pay to use the standard, they just publicly announced it. They wrote the standard and it said, hey, vendors, so these are the rack builders, the cooling providers, the
Then the
electronic.
products end up exactly how they want them.
Correct. And so they said, look, here is a spec. If you build the hardware to our spec, we're going to buy it from you. So suddenly the vendors have an actual incentivation to build it, because now even a tiny company, right, that would never be able to sell to Facebook because they're maybe just producing a small amount or whatever, but because they can build it in that specific spec. Facebook can take it, install it, and it will fit because it's built by the spec. And that commoditized like everything, right? Suddenly there's a standard, and now then what happened is all these vendors started to build this hardware design that's literally hardware by the spec of Facebook, and then they went to all the other data center companies and said, well, we're building it as Facebook built it. Do you want to buy it themselves? And then the other companies are saying, well, that totally makes sense. So we're also going to stand. And today you have, let me open it up real short. So you have a website on Open Compute, which has thousands of different specifications of companies like Intel, Microsoft, NVIDIA, AMD, Broadcom, even OpenAI, right? These companies, they're all standardizing on that because it just totally makes sense. Because I can, if I go to a vendor and I know I need a PSU or power supply, I know this will fit into my data center. And we're going back to the miners, how this relates to there. It's that I could buy PSUs separately from the hash boards and from the networking system and everything. So that's basically what we're building towards. And people sometimes don't understand that this is already happening. So we're trying one more.
That makes a lot of sense. How long did that take to play out? Sounds like a colossal undertaking, but inevitable at the same time.
Yeah, I mean, I think they started. That was started in 2009, right? It's not. Yes, it's a couple of years ago.
This was Google or
Facebook started it.
Facebook started it. Okay.
But now, so the
Oh, there we
PDF that
go.
we see, that's authors Google, right? So that is their data center facility documentation. And if you scroll down, this is from, there's a couple of pictures, right? So this is actual specs where how the product requirements of a pump, of a water cooling system.
Oh yeah, for their cooling system.
Yeah.
Expansion tank,
How big,
variable frequency drive,
correct.
pumps.
And now go further down, like there's basically, if you follow these things, you basically know how Google builds their data center, right? They're opening up completely how they build the data centers, but Google has an incentivation of this because now companies can build according to that. Like even to like approval of welds, and it's...
Right. Which means they don't have to rechain their technicians if they're between different sites.
Correct.
It's all the same.
Exactly.
Maintenance operations,
So it's an
SOPs.
incentivization for the provider of the data center and also an incentivization for the vendors. And yes, the technicians that are trained on this, they can basically go to another company because they will know it's going to work exactly the same. So I think that's where we're working towards.
This is an excellent example of the importance of open source hardware, not just software. But I think it's undervalued. What are you going to say, Ryan?
I was just going to say, yeah. And it didn't start like this on day one.
100%.
It started with some guys thinking, we're buying a lot of servers from XYZ company. We're a big operation. How about we build a few of our, let's try building some of our own. We can do this. We have the scale to do this. And then, we're not here to sell these servers. We're here to operate them. So what the heck? Let's make this open source.
No way. Sorry. Megawatt highest difficulty, 2 trillion.
Oh,
Megawatt. Badass.
Megawatt. They have
Let's
lucky.
go megawatt.
Maybe their locations are like
They are
These guys
lucky.
are
in the
lucky.
magnetic field in just the right place.
2.47 trillion. As a reminder, they were the ones that solved the block in Telehash number 1 and had the highest difficulty in Telehash number 2. I don't
Wouldn't it be fun? Electron bringing 1 exahash and megawatt.
Again, yeah.
With
Shout
45
out to,
petahash steals it.
We got Electron in the audience. We're thrilled to have their support. 1.3 exahash right
Wow.
here. Fantastic to see. Let's check in quick on the loyalty leaderboard. I don't think anyone's catching that. 6,598 exahashes since they've turned on their hash rate.
That's a lot of hashes.
What were you saying, Ryan? I cut you off. We didn't start here.
Didn't start here. The benefits of open source grow organically, compound over time, until you get to the point where you've transformed a whole industry, and it seems obvious in hindsight. So even the efforts that we're making now that are starting small, even the BitAx, like these things grow. These things compound. People see like the benefit of having an open thing and like, oh, now I can build on what that guy did over there instead of starting from scratch in my own silo. And over time, it changes an industry.
Yeah, really. I think it really accelerates, right? It starts off slow, but then, it goes exponential, right? Because it's permissionless to get involved, right? You're like, oh, seems like a lot of people are buying that like component over there. Like, here's the specs. We could make it, right? You're going to lower the cost. You're going to be another alternate vendor. It grows incredibly fast once it gets that momentum behind it. And I think, we've seen it. We've seen it happen in software. I guess it's happening in hardware for servers and stuff. I'm absolutely convinced the same thing will happen in Bitcoin mining. We're just early.
Let's stay on the hardware topic quickly. So Scott went into detail about the Ember 1 project, the hashboard reference design. The other open source hardware project under the 256 Foundation that we sought out to build and kickstart as a community ecosystem and platform to build upon is the Libra control board that Schnitzel is the lead engineer for. Why don't you tell us what that is, why this is an important step in the open source mining stack, and what it unlocks?
Yeah, so the Libra board is basically the solution to all my pain of years of trying to build hash rate heating systems, but also all the pain of what I've heard from other people, either small miners or big miners. And that's really to the point that in the industrial way, how we run Bitcoin miners, right, they get usually plugged into power. They run 24/7 with maybe doing a little bit of load demand. So they maybe get turned on and off once, but that's it. They also run in an environment where you have Ethernet, where you basically have a lot of control systems around. But what we're trying to build is we're trying to heat at home or run maybe a couple of miners together, connect them to other systems. That could be temperature sensors, that could be room sensors, that could be solar panels, that could be even mining, like we just saw for for 3D printers and whatever. And the problem with the current control boards that you get on these miners is that they're extremely limited on what you can do with them, because they're purposely built just to basically have one Ethernet connection and that's it. But what we want to do is connect temperature sensors, displays. Right? The BitX is so successful because there's a little display on it that tells you what the IP address is and how much hash rate you have. Anybody that's ever tried to install a regular Bitmain or Watts miner, it's a pain because you don't know the IP address of that thing. So you first have to download the software that that scans your net. It's just like, yeah, it feels so archaic. We could just have a little display that shows you the IP address. And so that's the situation. We have a control board, but they're not really useful for how we want to use them. So
real quick, why is it important that the control board is separate from the hash board for anyone who's
Good point.
unfamiliar?
Yes. So as we heard before, BitX is all in one. How we're trying to buy, or any miner that has more than a couple of, maybe 4 ASIC chips, it makes sense to separate the hash board from the control board, because the hash board is actually the piece that most of the time breaks, because the chips either overheat or there's another problem. Plus, that's also the thing that you actually want to upgrade. So it makes total sense that you have a hash board, multiple of them, so if one of them dies, you can easily replace it.
Like upgrading GPUs and not needing
Correct.
a whole new
Or RAM,
motherboard.
correct, or RAM in a computer, yes. And we also see, right, a lot of people that are starting mining and they don't want to pay, whatever, $5,000 yet or $10,000, but maybe they want to at one point. And so the fact that you have hash boards, that's really the expensive part. And with our software, you can actually upgrade. Now, for most miners, it's actually not possible, right? I cannot take an S9 and connect an S19 hash board. Even an S19 and S21 doesn't really, even though they fit in it, the control board and the firmware cannot really handle this. So that's one of the things that will allow us to do. But it basically allows you to mix and match these hash boards to whatever you want to do. And it just gives you a lot more flexibility and capability to upgrade and do stuff. So that's the biggest reason that we're separating the control board and the hash boards. And so we went off and basically looked, okay, what is the status quo and how can we solve this? Now, obviously, a control board, it needs a CPU and RAM, right? Because it needs to actually run Linux on it, it needs to run Mojina or any other tools, it needs to be able to talk to your Wi-Fi, to your Ethernet, it needs to talk to a pool, it maybe needs to talk to your thermostat. So you need some kind of computer on it. Now, these regular control boards, they have just very simple CPUs. You can buy them like systems on a chip, they're called, like it's all in one. The CPU and the memory is all in one. But again, that would lock us in. So we wanted a system that people can decide, do I need a powerful or a less powerful CPU? And there's a very awesome project by Raspberry Pi that is called the compute module. So a regular Raspberry Pi already has Ethernet ports and USB and HDMI and all that stuff connected. But they also realized that there's a massive market to just provide the CPU and the RAM without actual any connectors. And that's the compute module. The compute module has at the bottom of the module, like the PCB, and at the bottom it has two 200-pin connectors. And you can basically make boards that you plug the compute module on top in. And there's different compute modules by Raspberry Pi, and there's also different compute modules by different providers. So again, going back to standards, Raspberry Pi published which pins are connected on these 200 pins, and now other companies are building because there's a spec that people can use. And so what I did, we decided we're going to use these compute modules because it allows people to basically configure their control board to how complex, how fast, whatever it needs. And what I built is basically the receiving board that has the 200 pins, but has specific connectors to the need of what a regular miner needs to be. Yes.
So this is where the compute module interface connects.
Yep. So you plug this in, and then all the other connectors are basically all feeding to that main. So if you look, you can see some of the traces. That's basically these highways that are all connected. So without the compute module, nothing is going to happen on this. But what we decided upon is that, right, I've met with a lot of people and talked about, okay, what do we actually need to run these hash rate heating systems and things like that? And what we decided upon is, well, obviously we need USB-Cs to connect to the Ember 1.
Right.
We have 4 USB-Cs. That's not a specific limitation. It was just the easiest way because we actually have a USB hub and that provides us 4 ports. But because it is USB, you could actually just connect the USB hub and connect more hash ports to it. So that's what you see on the top left. We also see in the top in the middle, it has the same voltage range input as the Ember 1s. It actually says here 12 to 24 volts. We changed this now recently to 12 to 18 volts. So however you run the Ember 1s, you also run the control board. Like you don't have to think about another voltage rail or another PSU. However you can run the Ember 1s, you can also run the Libre boards. And then on the left, we have all these like power buttons and SD card and things like that. At the very bottom, we have a display port. That's for actually touch screen. We have an HDMI port, we have Ethernet, we have USB 3, so you can connect your SSD, whatever you want to connect. And then the long with the 4 dots there, that's an M2 slot, so that allows you to connect an NVMe and SSD, because you can run a full Bitcoin node on this, right? You can put a 2 terabyte SSD in it, and you can run a full Bitcoin node on this. And then we have 4 fan connectors. Because we have 4 hash boards, it made sense that we also have 4 hash boards. And the Ember 1, the control board, the Raspberry Pi compute module comes actually by itself with Bluetooth and Wi-Fi. So one of the major problems that we always see is people, they don't have Wi-Fi in their utility, they don't have Ethernet in the utility closet, so you can run it on Wi-Fi as well. And then one really cool connector is the Quick that you see in the middle. And that's like a standard. We're going to see this later on if we look a bit closer at the Dumax. It's a standard for connecting displays and sensors very simply to these control boards. So it's going to be extremely simple to have a temperature sensor or a display connected to your Bitcoin miner that can do whatever you want. So if you want to measure a room temperature or liquid temperature or flow sensors, you can just plug them in. And you don't have to solder anything or whatever. You can literally just plug them in.
Yeah, because the status quo right now, since the control boards are so locked down, the only thing that's really exposed on some mining firmwares and some aftermarket firmwares are limited APIs to control the miner.
Yes.
And if you want to make a system that responds and controls a pump or a power switch or whatever it may be, fan speeds, etc., responding to temperature sensors, you're bound by the API on the miner side, meaning you have to get a pump that connects to an API. And like we know Home Assistant to solve this problem where we create like a home IoT network as an intermediary.
Correct. Yes.
But it's really convoluted and unnecessary when you're trying to build a complete closed system.
Correct. Yeah. So the only way today how to build this is to still take a Raspberry Pi, connect it somehow to your pump and to your temperature sensors. Like there are solutions to that. But then for the Raspberry Pi to, let's say, talk to your 4 S19s, the only way, as you mentioned, is through their APIs. But these APIs change all the time. They don't give you all the data. And it's just not a really good way to have a system that really needs to work together. And I had failures where the miners stopped. It looked like they stopped mining, and they continued to mining. My Home Assistant thought, oh, I told the miners to stop, but they can still keep heating. And because they're just talk through like Wi-Fi or like through a very weird APIs, yeah, you can run into massive problems. And on this level, right, it's literally the same CPU that sends shares to the hash boards is also getting the signal of the temperature sensor. So you can much better integrate them and have much better fail-safes and just overall more efficient systems. Because in my house, like I have a Raspberry Pi, 4 control boards that the Raspberry Pi tries to talk to all 4 control boards through APIs, and it's a horrible system. But it's the only way we can do it today.
The control board in an industrial miner is really just meant to be a controller of hash boards in that industrial miner that's exactly what it does.
Yeah, and they're not foreign to a scanning tool to bring up all their IPs and get them running.
LibreBoard, I mean, really, it just does mining as a small side project. It's really a control board for a system. But what that system is up to the builder. Mining is just a very small part of what LibreBoard is capable of. It's a computer with a lot of interfaces on which you can run any software. It is just a embedded Linux computer just waiting for something to do. So, yes, it mines. It mines on the side, but 90% of its capacity and interfaces are sitting there waiting to be part of a larger system that has nothing to do with mining.
I just wanted to add that the main way that the current miner manufacturers lock you in to using their firmware, the firmware that dictates basically how you can use the machine, is through the control board. The control boards that are shipped by Bitmain, WhatsMiner, they all use Secure Boot, and they make it so you cannot load your own firmware on there. You cannot change your own firmware on there. And so I think that's another big reason for developing our own control board is like, fuck that. Like, these aren't that hard to make. Like, we can make our own that doesn't have Secure Boot, and we can do what we want with it, finally.
So looping this back to the reference design framing, like Scott talked about for the Ember 1, and building off your point, Ryan, this is a reference of it's a computer, an embedded Linux computer, that mining is one of the things it can do. The real beauty of it in this form factor, in this reference design, is all the various different I/O.
Correct.
Right? But if you were a large miner, say, and you developed a specific system that could even be a water heater, you might not need half the things on here.
Exactly.
And so the point here is to show you, here's how you can connect anything you may want to connect to a hash board, modify it to your liking, reduce the components list, make that BOM cheaper, and then mass manufacture it.
Correct, yeah, because that's the thing with PCB design, right? It's a lot easier to remove components than to add them. So what I basically tried to do is to optimize as much as possible I can get on one PCB. It's a 6-layer PCB with pretty much all space completely used, right? There's not a lot of space left. That's actually one revision earlier. There's a newer one that has even less space. But yes, for anybody that wants to build this, right? If you don't want to run a whole Bitcoin node, just remove the M2. Like, you can literally go into KiCad, select it, delete it, and the system will still work. Or you can actually just use it and don't just propagate it, right? Just like because the PCB building, you don't pay by trace or you don't pay by how many holes. It's the same price. So you could just not put the components on and it will still work. So yeah, if you don't need an HDMI or no DisplayPort, or you have only 2 fans, don't propagate it and you're going to be happy. Or you can change it. It's going to be a little bit complex to add more, but also not impossible. Right? So if somebody says, hey, I need 12 fans, yeah, there is a fan controller. You can just add a second and a third one and do it all. So it's really meant to show this is like the max version, right, in the world of naming. But you can totally build like light versions of this with less complexity.
Yeah, that's a funny point. Some reference designs are meant to be added to. I'd put the Ember 1 in that category. That's a small demonstration system. You probably grow that into something larger. And some reference designs, like you get with a lot of processors, or this is a perfect example, it's meant to be taken. It's probably meant to be taken away from,
Correct.
Honestly.
Yeah. And I could totally see, right, that let's say you have a mining may have, like, let's say 500 or 600 miners. Maybe some of them have an M2 slot and all these things deployed because they are maybe like more the controlling, like they maybe take more control. And then you have simpler miners or control boards that have less stuff on them because they maybe don't need that. But you could build the same PCB and you can just like during when you put all the components on, you would have less component there.
Yeah.
So it gives you a lot of flexibility on how to deploy all of this.
I'd say LibreBoard is maybe, if there's a spectrum, like Ember 1, probably definitely a reference design. I mean, it'll find uses, but LibreBoard can be thought of as a reference design, but probably even more something that you might just use straight up. I mean, Raspberry Pi, Beagle boards, all these popular single board computers sort of started as reference designs for their processors, and people were just like, "Oh, that's perfect. I'm gonna buy 1,000 of these and put them into products," and they do.
Really?
So, oh yeah. So I
We'll see.
Libra
Yeah,
board
I
can
mean,
see
it
lots
saves a
of
lot of-
uses just on its own.
Yeah, it saves a lot of rework. That makes sense. Okay. What about? I mean, this links back to Mujina, which we're going to dive in here in a second. Is like Mujina could run on a Raspberry Pi or a laptop or a phone for that matter, and USB-C. You can connect it to the hash board. Really, the beauty here is all the I/O you want is already there.
Yes, correct. Yeah, no, that's correct. Yeah, I mean, I think that's the brilliant decision of using USB-C, is that you don't have to use the Libra board, right? That's the same, again, how these big miners lock us in. Their control board works only with their hash boards. You cannot exchange. There have been now other companies that build third-party control boards. We know from Marathon, we know Brains, Epic, they built their own control boards.
Which necessitates a third-party firmware, right?
Correct, that's another thing. But we said we're going to open this up from the very beginning. So yeah, so you can connect to the Libra board, you can connect Ember 1s, you can connect S19s. You don't even have to connect a miner, or you can connect 4-bit access to it if you want to, right? Or you say, okay, no, I want to connect my hash boards directly to my phone or to some other smaller computer. So it's this exchangeability that allows people to build whatever they want. And of course, we could have said we're creating like our proprietary connector between the Ember 1s and the Libra boards, and they only work together, etc., etc. But that would have been the same mistake again, that that creates so much pain in the current environment. Thank you. That we're in. And yeah, I think the decision to use USB-C, shout out also to Proto that uses also USB-C for their hash boards.
Oh, they do?
Yeah. It's not a USB-C connector.
Not USB-C.
I think the protocol is USB-C, it's just not the connector.
Yeah, it's the USB-C is the connector, USB 3 is the protocol.
Oh, sorry, yes, okay. Yeah.
But yeah, I mean, they're
All
using
USB.
USB-C. I think they've also honed in on that as being a
And I
very
think-
good way to connect these things.
And that's like, if I would build a new miner tomorrow from scratch, even if it's proprietary, to not build it with USB would be a very bad mistake. Because that's kind of like 2-3 teams already decided, and that's just the standard now. Like, it's not
I
documented
didn't realize
somewhere.
that. So it's its own communication protocol, the pin connectors on closed source miners?
Yeah.
It's not USB?
Yeah.
Wow.
And in some cases, it's even encrypted, right? I think we know that WhatsMiner does some little encryption through it.
I think so. I've heard rumors. I don't know if we've fully dug into that. It certainly is obfuscated.
And so yeah, like you cannot take a WhatsMiner control board and put it into an end miner. Like, it doesn't work. It might even explode. Who knows? Like, don't try it.
Yeah, don't try it.
I mean, you can't put an Intel chip on a motherboard designed for an AMD.
That's correct. But you can take a USB mouse, like you can take your Logitech mouse and connect it to an Apple. Like,
Right.
that's the type of things we're trying to do. Yeah, because people realized, right, it makes sense. Apple for the longest time used Lightning, and they kind of got forced, but I think they also like realized that it makes a lot more sense to just have one single connector, and that's the same that is going to happen here. Like, it's like if we would, the fact that we have fan connectors, like they're standards, you can just buy, you can walk into any Best Buy or whatever
Micro Center.
in a micro center and just buy a fan, and nobody thinks about that this might not work. And people expect that the fan I can buy, I can connect to it. Sure, we could have come up with our own fancy connector, like Bitmain has some proprietary fan connectors that nobody else has seen before.
Yeah, that's right. They have that 2x2 one that's a little bit obscure. I think WhatsMiner has some weird fan connectors too. And I think Canon also has got some weird ones.
And so, yeah, people just expect this. And so, yeah, this is going to give anybody that wants to mine either for small or big industrial stuff, the world that they always expected. And in many cases, people that come from outside of Bitcoin mining, they walk into this industry, and the first thing is that they realize is, right, that we don't use these standards. Like, that is not how you do it, because everywhere else in the world, in like data centers, yeah, there's standards, like we just saw it before. It's fully standardized. Everybody uses the same because it just makes sense.
While we're definitely making reference designs that anyone can and is encouraged to get and modify, we're also making a complete system, like a reference design for a complete system, right? Both because we want this to be useful, and we need to test it, right? We need to test the functionality of each of these components, and the way to do that is to connect them all together and have them work. So,
Correct.
you know,
Yeah.
this is a cohesive system, right?
Yep.
The Libra board is the same size as the Ember One. It uses the same power connectors. You know, it's designed. The Libra board is designed so that it can run a node and Hydropool, right? And it can run Mujina. You know, these things will all work together, so you can get a demonstration of a complete system.
Yeah, and I do expect, right, that as soon as we have validated all of this, and what we see in front of us is part of this, and doing all Telehash to also validate a lot of the software side is also part of this, there will probably be companies that build the Libra board as we see it, just exactly that, and sell it, and people will use it. That's probably going to happen at the first, right? Because why would I try to modify it before it even exists? But probably over time, there's going to be, yeah, maybe the Libra board Max, which is what we see here, and then there's maybe the Pro, and there's the Lite version that has less stuff on it. And also there, we're going to have, like we also see in the BitX, like there's not just one BitX right now. There's multiple different, but there's also not thousands of them. Like usually we start to standardize around a couple of different use cases, and that's exactly going to happen on Libra board.
That's a great point. I mean, after the first BitX and all the work you did, Scott, no one said you have to make them all ESP32 based. No one said you have to have one chip, right? But they haven't really changed in form factor that much, or initial design. And I think that's a good point, that, you know, a lot of the work has already been done and you just build on top of it. Let's transition to the software. So we talked about the control board and the hash board as reference designs, maybe more of a product fit for a Libra board in the early stages. But Mujina, the firmware that Ryan's the lead engineer on, aims to serve as the Linux kernel of Bitcoin mining. I don't know, you wouldn't necessarily call it a product, would you? But it's not intended to serve solely as a reference. Do you want to talk about that?
Yeah, sure. Of the three things we've discussed in the stack so far, Mujina is not exactly meant to be a reference design because it's software and it's a little more flexible. So it is meant to be used in many different contexts, and it is meant to be so all of this mining requires software. What is mining? Essentially, we need to talk to the Bitcoin network to get the latest, understand what the latest block was, a set of transactions to prospectively form into the next block and try to solve it. And so it's software that puts all that together in the end, ultimately. Software has to have a place to run. That's the control board. The calculations it is trying to do to solve the block. That math we want to do as fast as possible, and so we use acceleration chips, which are on the hash boards. But the software kind of sits in the middle of the whole system and coordinates all of that. And if you build it right, that software should be able to perform that same task with using all different kinds of hash boards, because they're all essentially doing the same thing at the end of the day. And it should be able to run on all sorts of control boards, because anywhere you can run some compiled Rust software, anywhere you can run Linux, you should be able to run Mujina. And because of the choice for USB and other standard interfaces, other systems will have similar interfaces for connecting all the different hash boards we're talking about. So Mugina is firmware that is built from the beginning to not just run in a specific product, in a specific context, but to be something that is ultimately very flexible, very modular, very pluggable with new drivers, so that it can be used on many different types of hardware. Obviously, we're starting with our hardware first, the 256 stack. So the Ember 1 is, the first driver we set out to write. We also support BitX gammas in Mugina because that makes for a convenient development setup, because BitXs are very available and easy to power and low power, quiet. They can sit on your desk. We talked a little earlier in the program about the fact that it can treat your CPU as a hash board on the inside for development purposes. And I'm sure we'll talk about, as we go forward here, the many things we're working on porting Mugina to right now. Other hash boards we're trying to support. The Intel chip entry from Johnny we saw earlier, that is the Mugina version, do you think? Or is that an ESP Miner version?
That's definitely the Mugina version.
Okay.
Yeah.
So
ESP Miner version is still
in the works.
early development.
So that is Mugina with brand new hash boards with Intel chips, so a totally different driver plugging in to power that miner on completely different hardware. And then as far as variety of control boards work, I mean, we run this in all sorts of different contexts. So I often develop on a server, on a Linux server. You can run it off my Mac laptop. We're running it off a Libre board on the example hardware we have in the room here. So that's how Mugina fits into this system. And to answer your original question, I guess, is not a reference design like the others necessarily. It's software that's meant to have support for all the different type of hardware, hash boards and control boards that we run across.
You hacked this onto an S19, right, Scott? You want to
Yes.
talk about that?
Yes. As Ryan was saying, this is designed to be running on basically any computer system, including embedded computer systems like are on the control board for an S19. So I've always wanted to do this, and I took an early branch that Ryan had made that had support for the chips in the S19J Pro that he did for the Ember 1 support, and basically pointed my AI at it and was like, I want to be running this on my control board on my S19J Pro. And I didn't exactly one-shot it, and I had done some previous legwork to figure out how to load arbitrary software onto the control board. But basically, yeah, just vibed it. Like, it totally works. I was going to lug it here and demo it, but it's just way too heavy. But anyways, it totally works. It's insane. Like, Mugina, this software that you created, that it's running on an Antminer. I mean, to me, that is so exciting. So it runs on the Amlogic CPU that's on the control board. The hash boards are connected over that same ribbon cable interface. We can read the temperature sensors on the control boards. We reverse engineered how you communicate with the power supply, so we can turn that on, ramp up the voltage, like control the fans, control the fans dynamically from the temperature. It's really cool. And so, yeah, I mean, it can just be, obviously this is a proof of concept, vibe coded, but it proves that, yeah, this can totally do it. Like, Mugina it's an application, really, right, that can run on any system, including this S19J Pro. And then I kind of got a little bit carried away and kept hacking on the Amlogic control board, the Bitmain stock one, and got the USB port turned on. So now I added Wi-Fi to it. I can plug in a Wi-Fi dongle into my Bitmain control board, and now don't have to use Ethernet to connect it anymore. Boom. Thank you. There you go. So
There it is.
I've got a little USB like travel hub plugged in to the control board there on the left, that box. You can see there's a Wi-Fi dongle in there. And then also, I took this touchscreen display that some people in the OSMU community developed for the BitAxe Touch, and that also connects over USB, and vibe coded this interface for it, so it's showing all the stats of the miner. So that's connected and being controlled from the Amlogic control board. It's a touch screen, so getting Wi-Fi devices on the network is kind of tough. So this is, if you go to one of the other screens on the touch screen there, you can scan for Wi-Fi networks, pick the one you want, put in your password, it configures the miner and connects, and yeah, it works pretty good. You can see I actually brought a pretty decent best share there. What's that, like 579 million?
Yeah.
The hash rate there, that's only one, that power supply has been hacked to work on 120 volts, which is what I have in my lab, and so I can only run one of the control boards. So I'm just running that middle, one of the hash boards. I'm just running that middle hash board only, so that's why the hash rate's a little bit lower. But yeah, it's performing pretty well, very efficient. Yeah, I don't know. This was so much fun, and it was just like this happened because we have this sort of groundwork laid. Like the initial work has been done to put together all these pieces. I can point my AI at it and got this done in like a couple hours.
Yeah, there was like a week or two a couple months ago where our Signal chat was just exploding with everybody sharing like, oh, I made this work, and I made that work, and then I made that work.
Yeah.
Like it felt like we
Yeah,
had hit this critical mass.
Yeah, that was the
where,
craziest thing. So
everything was really coming together fast.
So
Scary fast.
Scott built the first version of running Mugini on the S19, and I was like, I want to try this too. For me, the crazy thing, like for people that don't know, there's not just one S19 hash board. There's at least 10 different versions of S19 hash boards, and some of them have a so-called PIC on it, which means that you need to communicate with the hash board to actually turn it on. So they have, for super simplified, there's a relay on the hash board to turn it on and off. You get some advantages of this, right? For example, if you have 3 hash boards and one of them is broken for whatever reason, if you cannot turn it off, the hash board, it will basically destroy the other 2 as well. And so for some reason, Bitmain decided for some of the hash board will have this relay. It's a MOSFET, but it's basically a possibility to turn it on and off. The chips or the S19 that Scott used did not have a PIC. So his software or his version of Mugina did not communicate to the PICs. I only had S19s with the PICs. So I went to my AI and said, hey, here is the S19, can you install Mugina on it? And here's the repository from Scott, and it happily installed it. And I was like, okay, start mining, and nothing happened. And so I asked it, like, can you try to figure out? And so it figured out by itself with like looking on the internet, there's different hash boards and whatever, and it was like, I have this PIC, I have no idea how do I talk to it, right? So like how, because you have to tell the PIC, hey, turn it on and off. And I was like, well, we do have like Brains and LuxOS that can talk to the PIC, right? Because, so I asked the AI, can you sniff the I2C from the LuxOS, how it talks to the PIC, so you can learn the communication protocol? And it said, yeah, totally, let me do this. So it deinstalled Mugina, installed LuxOS again, and because of Linux, because it's open source, I can sniff every protocol. So I can sniff on Ethernet, I can sniff on Wi-Fi, I can sniff on Serial, and I can sniff on I2C. So I installed the sniffer on I2C, measured the protocol, told LuxOS to start mining, and it found what communication protocols. And it said, yeah, I think I have a good understanding. And before it actually installed it to Mugina, it wrote its own little bash script that only turned the PIC on and off. So it turned it off and looked like, oh yeah, this is the response that I got back. Then he came back to Mugina, and then he built all of this into Mugina, deployed it, and maybe like half an hour later, I literally had PIC support with Mugina, and I was able to do it. And like I had to do nothing. Before that, I mean, maybe Scott, you could say like, what do you think? If I come to you and say like, you need to reverse engineer an I2C of a hardware that you have no idea, we would talk days or weeks.
Yeah, definitely into the week plus range. It certainly wouldn't be an evening exercise, and we probably wouldn't have had as complete understanding of it even after that amount of time that you got.
Correct.
In an evening.
Yeah.
This is massive.
It's so fun to watch it work in that way.
It really is. You're like,
Because like these are things, I mean, it's always been there. You can always, you can attach through the ptrace, strace interface in Linux to a process and watch its system calls. And oh yeah, I could probably see what it was doing on an I2C bus if I watched that traffic long enough and figured out which of the 100 open file descriptors is for that bus, and then, I'd probably have to I dump this out to a log, and then I guess I'd have to write something to parse that to sort of piece it together into something that looks like a serial stream, and then I'd have to stare at it and be like, wow, that kind of looks like a delimiter, and okay, I'll write some software again to maybe I parse this into frames, and then it would take a week.
Yeah.
To do something like this.
Yeah.
And now you can see AI kind of use all the same techniques and tools, but it's done in 5 minutes.
Yeah, I mean, it would have taken me...
done in 5 minutes what took me a week before. And
Exactly.
I'm like, okay.
Yeah, and this is, and I want to emphasize this is only possible because the tools that we use are open source, right? The
Yeah.
fact that...
But the AI here was sniffing a closed source firmware, LuxOS.
Correct,
so
but it was running on top of an open source Linux. So it can change Linux in a way that it can sniff it, right? Because
the communication protocols.
Correct, because the LuxOS uses Linux to communicate to the hashboard.
I see.
And because the Linux part is open source, the thing that actually sends the commands to the hashboard, because that is open source, there are debugging tools that allows you to debug these protocols. Like, for example, if you're a Linux developer and you want to have an I2C communication, there's a bug, you have a debug tool. And Windows, more Microsoft, has these debug tools as well, but because they're proprietary, they're not open source. On Linux, I can literally just install the same debug tools that the people that build the code for all of this, I can download them as well, and I can use them myself. So I can use the debug tools to sniff the communication. And that's only possible because Linux is open source.
and this is the crazy cool compounding effect that accelerates development, right? Because now you spent that, previously a week, now an evening, to figure out the communication protocol with the PIC, right? So now the next person that wants to do something to incorporate PIC control, right? It's not an evening, it's 30 seconds.
Yeah, because it's already in the code.
Because it's already in the code, right?
Yep.
So now it's 30 seconds. All right, cool. We totally got the PIC under control. I want to build the next thing on
Yep.
top of it, and then the next thing,
Yep.
and then it branches out, and
Yep.
just
Yeah.
it gets crazy cool.
And the other thing is there's now, let's say there's 10 different hashboards. We will probably never get access to all the 10 hashboards, but what I can also do, I can now go to my AIs and saying, hey, can you build a skill that I can give to anybody else that has another hashboard, and then they will load their skill in their AI, point it to their S19s, and their AI will know exactly what they should do. Right, so we can crowdfund now or crowdsource the knowledge, but because my AI has it done once, it knows what to tell to other AIs to do the exact same work that it has done for me, and we could literally build all these hashboard recognizing skills, tell people, hey, just give them the AI, point them to your miners, and they will then take the data and upload it to, let's say, a wiki or to a GitHub repository, and within weeks, we're going to have every single miner in the world analyzed. We will have an index of all the different hashboards, how to talk to them, what are the protocols. Things that people have taken years to build, we can now fully automate.
And this is the reason why, over the long term, Mujina is going to win. This is why open software wins. This is why I want to keep calling it the Linux kernel of Bitcoin mining, is because even in the world before AI, this is the dynamic. But now, especially in the world of AI, you need a place where the progress that gets made gets banked. So someone figures something out. It's one thing to have a wiki page out there with the protocol documented. I mean, that's great and useful. It's also not always discoverable. So many things get lost because it's a one-off project. Someone documents something or publishes something, and it may or may not get attention, whatever. But what Mujina as an open source project can be is a central place where where the knowledge sort of pools, where it collects in a refined form. Gonna start sounding like Michael Saylor. But this is happening right now. Like, there's probably 10 vibe-coded branches of different things floating around out there where people have tried on different hardware. And I look at the code sometimes and I think, well, that's really cool. It's really cool to see how the AI has sort of comprehended the design of Mujina and been like, oh, I just need to build another one of these to plug in there. And like, sometimes it just fits in perfectly the way I would have like imagined it. And because the interface is right and and it had everything it needed, and it's like, wow, that did it as good as another developer. And sometimes the AI just like really brute forces some ugly thing, and you're like,
Inline Python in a bash script or
right,
something.
it's sort of like, well, it sort of missed the point. Or sometimes I look at it and think, well, if the AI couldn't understand the modularity and how it should have implemented that, then that probably says that the design of Mujina isn't quite right in that spot yet. So it's sort of instructive. But in any case, like, a lot of these black boxes, I don't think we're at the point yet where we can just stick them straight into Mujina, the mainline branch of Mujina, and ship them to everyone who uses our project and have confidence in it. But Mujina can be a central place where like all these good ideas sort of get refined into and curated. And then once they're in mainline Mujina, they're sort of banked as like done, or at least captured, and that compounding, has a place to live. So I'm really excited. What a wild time and what a cool time to be an open source project. Like, this is going to be totally different than it would have been 5 years ago. And in some ways that's difficult to manage. Like, people just show up with huge loads of code that are like, here you go. And it's like, as maintainers, it's going to be an interesting challenge to figure out how do we even review this stuff as fast as it sometimes can come in. But it's also super exciting,
Yeah, I think that's one of the things that I don't think we talk about enough yet, is this, like, that we have this one ripple in the water. It's just open source mining and hardware and software, and then at the same time the AI comes from the other side, and I think they will together, like, it creates this massive spike, right? Like, yeah, the fact that it's open source and the fact that there's AIs that can now analyze this closed source hardware, and yes, even though a lot of it's closed source, the fact that they use still open source under the hood allows us access to a lot of things.
Well, does that exercise still play out for a miner that doesn't have Lux or Brains or an aftermarket mining firmware on it? Like, is it Linux under
Yes.
What's Miner
Yep.
or Bitmain
Yep.
firmware?
It's a bit harder.
So you can do these sniffing exercises.
You can do the sniffing. Yeah, so we have to be careful, right? The newest versions of, specifically, I know it from Bitmain, they now locked down the firmware so much that you can actually not SSH in anymore. Like, and you need some kind of access to that Linux. But we don't need the newest versions of firmware in order to know how to talk to these PSUs or to the PICs or whatever. So yes, we don't need a LuxOS or whatever. It's easier, right? Because they also, sometimes having actually multiple firmwares allows the AI to find a lot more similarities. Like, if you have just one, you kind of see this for the truth, but if you have access to multiple one, you can find better patterns.
Right, because I'm thinking about the M64, which doesn't have any aftermarket firmware support, right?
Correct, but it has a Linux on it.
I see.
It runs a Linux.
So it's a little bit harder to get Mujina working on it, but not impossible.
Yes, correct.
I see.
And it, again there, right, a lot of this reverse engineering is basically just trial and error. And a lot of the times what Ryan before described is like just one human looking at zeros and ones or maybe hexadecimal strings and just kind of guessing of like seeing, it's like in the movie Matrix, like they looked at this Matrix thing and you just look at it and some people can say what's happening. That's literally what reverse engineering is. You just use all your experience and somehow like you come into this state of mind that this stuff starts to talk to you in some way or another. But that can take days or months sometimes, right? There's people that's all they do is they reverse engineer code. But the AIs can do this 24/7 without sleep, and actually a lot faster than a human mind can do it, because it's the perfect case. Like it's ingesting a lot of data and finding patterns in the data. That's what AI is extremely good at.
Yeah, you bring up a good point too, Ryan. Like the context is king for the AIs, so the more resources they have to look at, the better they'll be. And as we curate and refine these features and architectures and structures into Mujina, the AI should get a lot better over time at implementing future changes, right? I think of it, because like AI is non-deterministic. You could ask for one thing to two different AIs, you get two completely different answers, the way
Correct.
they word it.
Correct.
And it's kind of like saying like, I want to bowl a strike, but the strike can happen, the pins can fall a bunch of different ways, right? And still get a strike. And then you can kind of add guardrails up that help you get the strike.
Yep.
And you want tall guardrails to ensure the strike, you get what you want.
But the AI can also write computer code, which is then deterministic again. Right? So you use the
Yes.
non-deterministic system to build something that is reproducible. So that's why I'm saying like,
These scripts to debug.
correct,
Yeah,
correct.
sniff.
Or the Rust code in the end that in Mujina is in there. But me that only has access to one S19 and maybe two different hash boards, I can only build the script one like for these two. And so in the past, it was just basically hopeful that somebody else out there has the same knowledge that I have or sends me their hardware. But now I could literally give it to you. You have never done any reverse engineering. You don't even need to know what I²C is. All you do is you take the skill that I wrote with my AI, you give it to your AI and saying, okay, go and analyze your miner. And suddenly you become a reverse engineer.
Sweet. Everyone's going to become one.
Yeah, you're right. The context matters a lot. The better, and it does compound, the better Mujina is, the better AI is at writing Mujina. Yeah. And it works in the other direction too. Just 2 days ago, I was fighting something where it was writing this unit test, and it kept saying that a bit X, like the nominal hash rate of a bit X gamma was 500 gigahash per second. I'm like, why do you keep, and I was frustrated. I'm like, why do you keep telling me that a bit X gamma, should be like about 1.2 terahash? Why do you keep insisting that a bit X gamma is 500? And it said, well, there's this comment in this one part of Mujina that says that. And it was like something that I don't even know how that got there like a year ago. But, just some straight, anyway, so it's like, well, you said this is the way it works, and I try, I'm running off, that's my context, I'm trusting you.
But while we talk about AI and Mujina, I would love to talk about also how, right, we're now using AI to build Mujina, but I think there's a whole field of using AI while Mujina is running and optimizing, because a lot, maybe Ryan, you can talk about this a bit more, like a lot of optimizing these chips and getting them to peak performance is also a lot of guessing or like finding optimized. Maybe explain us how does a firmware actually do tuning and what is involved?
Well, this is something Mujina doesn't do much of yet because we're just not at that stage of maturity. We're at the get things working state of maturity. But with each chip, basically, you have the ability to control its clock frequency and the voltage applied to a large number of chips. Basically, let's just say that those are your two knobs.
Yeah.
And
the default firmware, like a stock firmware, they're just running all chips on the same level?
Well, a very naive approach would be yes, to just treat, a hash board may have 100 plus chips on it, and each chip, can have sub chips within it essentially. So there's a lot of different pieces, and a naive way to run it would just be to kind of give them all the same settings.
Like a standard known working settings.
Oh, cool, thanks. But that isn't necessarily optimum because there's, as everyone knows, silicon parts are physical parts. They're not all identically the same. They don't all perform the same way. Chips get binned into different performance categories because they have slightly different voltage versus current versus heat versus frequency characteristics and stuff. So what you want to do in a real miner that you're really optimizing for peak efficiency, let's say, is to go in there and change at the most granular level you can. Maybe you tweak the clock rate of one of the chips so that the voltage drop across it is a little bit different so that it balances out with the rest of them. And I believe a lot of these algorithms are sort of like training an AI model in the detailed sense, like in this sort of a gradient descent sense. Is you're tweaking these parameters, you're seeing what happens, you're letting it run for a second with some temperature, and then you're going back and you're optimizing through. It's not like a deterministic. Every chip this deep in the stack, I'm going to adjust by 1% upwards. Like, it's a very iterative adjust and see process that is different for each physical piece of hardware, because what you're trying to do is tune out and optimize for silicon variations from chip to chip and the way they behave. And this part of the hashboard, the temperature across the hashboard is not completely uniform. So you're balancing out all these things to optimize for peak efficiency, and it's a lot of trial and error. It's basically trial and error with an algorithm. So, where did we start? Oh, we're starting, back to the AI part. Yeah, I think we've talked about this in a lot of ways. It's very conceivable that if you gave AI the right knobs to turn, that it could experiment with different algorithms for tuning. Maybe you could come up with something that converged faster. Maybe it could come up with something that optimized better. We don't know, but we live in this world where it's pretty easy to try things like this out. So if you give it the right knobs via the API, and tell it to tune a live system and see what happens.
And not only,
I
right,
think that's
like
part of the future for sure.
What most miners do right now, they try to optimize this tuning for highest performance, meaning highest hash rate versus lowest wattage input. But I could imagine in some cases, I actually want to optimize for highest temperature. And that's something that doesn't exist right now. Like, I cannot go to a Brains, a Luxor, or whatever and saying, tune me, but I'm interested in this, right? Or I want to tune for the lowest noise or whatever. Like, there's all these different other possible optimizations. And I could imagine that, yes, if you give an AI, you can give it additional factors or context that is maybe just important for my specific use case. And it could then figure out the algorithm or do the tuning for that specific case. That's what I'm super interested in, because it's nice that we have these algorithms, and yes, they take sometimes an hour and two to run. So to optimize them, maybe with AI would be cool. But yeah, there might be a temperature sensor in another room that I want to optimize for, and there might be a relation between that temperature and the hash rate or the voltage of the chips, and I give my AI access to it and say, just go and try to figure it out, and it will come up with its own way of optimizing for that specific way. That's what I think is really cool.
It's like I don't really feel comfortable with having like AI in the loop, right? Just burning tokens every time you want to like change something. But what you could imagine is if you have access to additional knobs, like you're saying, like you have more control points, and then you have, a lot more data points. A lot more data points. Like, what's the result of turning those knobs? Yeah. Right now, you can experiment and then condense that down into the algorithm that does exactly what you want when you want, and like this could be a significantly faster process.
Yeah, like I have, for example, I have a lot of people that are writing me because I maintain the Has miner together with Brent. The idea to control miners from Home Assistant. And we have a lot of people that already have their solar panel system connected to Home Assistant. So what in their perfect world, the solar system will tell Home Assistant how much watts, down to the single watt, that the solar panels are currently using. And then I would like my miners to follow that wattage in a perfect world. Now, I have a couple of knobs already. Like if I have 2 miners, I could turn on and off a whole miner. That's like a very archaic way, but that's one of the ways. If I, let's say, Brains or Luxors, I can change the wattage, but the problem is they always stop mining and then they go back. Like it's not an immediate, okay, now 2,000, 3,000, 1,000, like it doesn't go that fast. With Mugina, I suddenly have a lot more capabilities, right? I could turn on and off individual hash boards, or I can give them different, like, and so, yeah, suddenly I actually have a lot of inputs and a lot of control systems, and telling an AI just like, and maybe the AI will even find a pattern in the behavior of your specific solar system or solar panel system, right? Depending on where you live, the curve is different for everybody. So you could give the AI access to all the historical curves of your usage, and then all the knobs of the miner, and it could probably find a way to match that as perfectly as possible for your specific solar panel system, but also your miners, depending on how fast they react to changes. Can you turn on and off individual hash boards, yes or not? And also like the cooling system that sits behind and all that stuff. That I would love to see, right? This is just like, and people already built Claude already into Home Assistant. So you can tell Home Assistant, here is Claude, give it all the data about your solar panel. Right now, we don't have the capability yet from Home Assistant to actually tune the individual chips, but Machina will allow it to do this. So yeah, you could have an AI that sits in your Home Assistant and tweaks the chips perfectly to whatever the solar panels currently tell you.
One of the things we're trying to dial in is better ability to control for finer granularity in how much power you're consuming for exactly situations like this.
Yeah.
And this is slightly tangential, but we do have 8 hours fill. I was thinking earlier when we were talking about reference designs, like this is one of those places where reference designs not only help hardware engineers, but help software engineers. It's super helpful to me to be able to have, I've got like the BitAxe, like 1 chip version of something, and I've got the Ember one chain of chips version of something, and then, a whole hash board with 40 some chips stacked, 3 wide. Sometimes it's really helpful to be able to simplify the hardware for the sake of figuring out some of these things in software. Much harder to just jump into the whole hash board and be like, oh, I want to work on tuning. This new idea I have for tuning, with a 42, chip stack at a higher voltage, and you don't have the ability to probe it the same way. Being able to work on a reference design that is much more simplified, or even to take it down to the single chip level. That's why, it would not have much hash rate, but I'd love to see a single chip BitAxe Bonanza style. Like that would, to me, that fits the like product categories that I love to consume as a software engineer. Is like, oh, I like the 1 chip version, the small stack version, and then the full up system, so that I can pick my poison when I'm trying to reverse engineer something or
Tangent to the
work on software.
tangent.
Yeah.
Could you install Mugina on an ESP32?
Probably no.
No.
You can compile Rust for ESP32s, but we take full advantage of the fact
of
we're on
Linux.
Linux
Yep.
to use certain libraries and stuff that you just would never. That software will never run on. Shouldn't say never, but no.
Okay.
No, not meant for pure embedded. It's meant to run under Linux.
But we could make like a Raspberry Pi or a Raspberry W version with a BitAxe, right? That would work.
Oh yeah, definitely. Yeah.
So
Yeah, the
this is-
Pi Zero,
Zero, yes. Sorry.
Yeah.
Yeah, Raspberry Zero with.
yeah, that'll run unmodified Mugina.
So this is why people should join the Mugina dev calls and start contributing either to the GitHub repository or the forum with feature requests, comments, questions, ideas, because the world is our oyster here.
going to be a lot of fun.
It'll be a ton of fun.
It really is. Like diving into this stuff is so cool and it's so exciting. We're just like making all these discoveries now even faster. And I mean, the only problem now is just like the limitless number of possibilities and potential projects that you could be working on at any given time. So got to get those agents spun up.
Well, let's complete the picture, the painting of the full stack with a discussion on HydraPool, which we're using for the Telehash here, the hash dash being the visual GUI for that. What is HydraPool? Why do we need an open source mining pool reference? And what kind of features and things has it enabled? You want to talk about that, Michael?
Yeah, I can. Well, the reason is really that while there are existing open source pool implementations, as we talked about in the beginning, unfortunately they were built by individual people that never really planned that they become open source project. Or they open sourced it probably for good reasons, which is awesome, and that allows people to run them themselves. Like we have many versions of CK Pool running on all kind of Umbrels and Start9 and in the cloud also, which is awesome. Like that's super cool. But as soon as you want to integrate that pool into other systems, being able to actually integrate it, change the code, have good APIs, have good documentations, have tests, that's important. That without that it doesn't work. Like even AI, if there is no test, how does the AI know that what it just wrote, it broke or not? And that's where, unfortunately, the current open source pool implementations are, is that they exist, that you can use them, you can build them, but to extend them, unfortunately, is extremely hard. And we tried, right, the third Telehash we did, where we tried to run our own pool. We had a forked version of CK Pool, but unfortunately, we ran into some weird memory issue that we could not figure out. And yeah, that was basically one of the reasons that we said, no, we need to re-implement it in Rust. So HydraPool is built from scratch with Rust, properly documented with tests, and meant to be extended upon to whatever you like to do. Is it right connecting to some kind of payout or supporting different payout schemes, exporting data like to a website? Like we could never have done what we see here with CK Pool. It would have taken a lot longer to do like a dashboard like this, to integrate into modern monitoring software like Prometheus and all that stuff. But also, yeah, to be also a reference implementation of a pool itself. Because maybe we can talk about this later, what Stratum actually is and the problems around that. There is no real specification. And so that's the other goal of HydraPool, is to also be a reference implementation of an actual spec, being it Stratum 1 or Stratum 2, to allow other people to test against, right? Because when Ryan built Mugina, you're going to have to test against the pool, and to which pool do you test against? So that's another thing that HydraPool can be, is this reference implementation that people start to agree upon. This is how we are building it, and I can test it, and if my firmware works against that one, I can be very sure that it works against others as well. And so Zhongli, he has a project called P2Pool, which is a slightly different approach on a pool, and he built HydraPool, which has now been running for 2 telehashes and has found many blocks, not on mainnet, but has found many blocks on test infrastructures. So, yeah, I don't know. You want to add anything, or?
Yeah, I just think that this sort of reference pool implementation that is modular enough that it sort of invites modification and changing it and experimentation, because the way mining pools are today is it's not finished. It's not done. Like there's a lot of work that can be done to improve on decentralization. I'm thinking different mining mining payout schemes. And so we need people to be trying these things. We need people to be, not satisfied with the way it's done now and trying new things, because there's a lot of work to be done to ensure that Bitcoin remains decentralized, that Bitcoin mining remains decentralized. And so, from my point of view, a lot of the goals associated with Hydropool was like, this is a platform you can take and try these things out on. And maybe some of those become, production-ready things. A lot of them don't, but we've got to keep working on this because it's not a solved problem. There's a lot of work to do. And so any tools that we can build to make those people who want to try out a new idea, to make their lives easier, to make it faster, I think is worthwhile.
Because we don't know how the large pools work.
No?
No, not really. I mean, we can
I
see
mean,
how
it's
they're
probably some kind of CK pool.
It's probably some kind of CK pool. I think.
I don't think
definitely-
anybody went that crazy and built their own implementation from scratch. But
Yeah, who knows? I mean, obviously they have to work with the Bitcoin network, and they have to work with Stratum, so we can see how their interfaces are done. But sort of the logic behind it is a
But I can tell
mystery.
you, like, I tried now. We can talk maybe about Hashscope later, but like, there's a lot of different ways how these pools react to different things. So, from what we can see from the API and the responses, there must be heavily modified versions. Because usually you wouldn't change the error codes or whatever of a software.
We should talk about Hashscope now then. I mean, what is Hashscope? Why did you build it? It seemed like a debugging tool,
Yes.
but now it might actually serve actual utility to specific mining operators or developers that are modifying pool instances, firmware changes, etc.
Yeah, so Hashscope really solved two purposes. One, I myself have never actually seen the protocol Stratum working, right? I've seen it in logs of a BitX or in logs of a Bitmain, but I've never actually seen the actual communication protocol. And so the idea came from like the idea of WireGuard. For anybody that has used WireGuard, it's basically a network analyzing tool where you can see individual network packages. But I wanted this to see on a Stratum level. So the main feature is that it allows you to inspect what a miner and a pool actually communicate with each other. And you do this with basically a man-in-the-middle. Usually people call it a man-in-the-middle attack. But so you point your miner instead of to the pool, you point it to Hashscope, and then in Hashscope you point it to the pool. So the miner thinks it talks to a pool, but it actually talks to Hashscope. And then Hashscope sends the request to the pool. And you can see every single message. So you can see how the miner announces itself to the pool, what the pool sends back to the miner, how the negotiation of the hash rate, of the difficulty happens. You see every single share that the miner sends to the pool, and you can also see the pool when it sends work back to the...
So this was necessary for Hydropool development.
Yes, so it was necessary because, right, there is no real spec. So actually during the last Telehash, we had some very weird issues with LuxOS miners, and we could not figure out, just because you go in there, you enter a pool address in a miner, and all it tells you cannot connect. Again, LuxOS is not open source, so I can't go in and change the verbosity. In Mugina, I can go in and I can just change the verbosity to trace, and I get every single data that goes in and out. LuxOS decided to not implement this. Now, in that case, I could have, again, pointing to a running Hydropool that runs in the public. I couldn't enable the tracing, because then I would suddenly have tracing of everybody. So I told the person that was at the Telehash in the audience, pointed to that Hashscope. He pointed it there, and I pointed Hashscope back to Hydropool, and we could see that it sends the order of messages in a very weird way. Again, there's no spec. It sends the right data, but not in the correct way, and Hydropool assumed that the connection was never opened, And so, yeah, we were able to figure out that the order is slightly different. And so it's first and foremost came as this idea of an analyzer of Stratum v1 to see this protocol. However, getting ready for the third telehash, we wanted to do some load testing. And there is this weird thing that I never realized until that point. It's right, load testing outside of Bitcoin is extremely easy. Because if let's say I have a web server and I will load test that, I can go to AWS and I can just start a couple of servers and I can just send thousands of requests, fake requests, to a server. And the server will try to respond to all of them, and that's how I load test. With Bitcoin, we have proof of work. So the pool is actually validating if the sender has done their work. And I cannot fake it, because if I could fake it to any pool. So it's the protocol in the world that you actually can only load test with sending real proof of work, having real miners, having real done the work for real. And that was because my first implementation was like, well, I connected the BitX to Hydropool, I put Hashscope in between, and every share that was sent, I just sent to some servers running in AWS, and I told all these servers, hey, send the same share. And I was like, I'm clever, that's gonna work. And the pool said, nope, because that's not the work I sent you. Right? It verified the proof of work, it knows. And a proper pool will actually verify that this share is a real share. And it's very simple. That's the cool thing about Bitcoin, right? For the pool to verify that this share is a real share, it takes it a couple of milliseconds. For the miner, it takes it 100,000 of hashes to generate them, but the verification goes really fast. So we then had to basically find a way, how can we do load testing without running, like an exahash costs you around $1,000 an hour. So how can we load test this? And the only way that we found is to basically change some things in Hydropool. So Hydropool has a debug where it basically accepts any share. So we disabled the proof of work. And so how this works is in Hashscope, you can connect external workers. They actually connect via Nostr. They register themselves through its own kind message. They register themselves at Hashscope, and then Hashscope that monitors the actual traffic between, let's say, a BitX and the pool, and it takes any share, and it sends it to all these other servers that are registered, and we started them, I think, in 10 different AWS regions. Oh. Yeah, the Dumax is unhappy.
The Dumax is unhappy. Well, we're going to build up to that, but why don't you address it? New battery needed?
Yep.
At least
I was
it warned
hoping
you.
I found a block.
Yeah.
No.
I thought it was going to self-destruct here for a second.
No, it's just the battery's empty. Yeah, so it basically sends all these the single hash that the BitX find, it sends to thousands of other workers all over the world. And so Hashscope extended from a debugging tool to also a load testing tool.
I see.
So that's what it is today. You can use it to analyze Stratum v1. Would love to also add Stratum v2. But you can also you can do some load testing. However, and maybe people want to try this, like technically this shouldn't work. If this is correct, then the pool will correctly prevent Hashscope from doing the load test because there's no proof of work. But during that work, I actually pointed it to different pools, and the response from the pools, for example, for like a share that needs to be rejected, the message looked very different for every pool. So that tells me they either went in and modified it, like to change the error code, or maybe they built the pool completely themselves. But yeah, we have no idea. There's no real way to know what they're running.
What about, I remember when you were describing Hashscope to me, there was some feature described that has come up actually for the Telehash today, which is this proxy mode. Is that still a feature of Hashscope? And what problem does that solve?
Yes, so the idea of a proxy is that Bitcoin with the shares, right? So what we need to understand is when a firmware, let's say Mugina or Luxus or Brains, it actually gives work to the hashboards. The hashboards return with a lot of different possibilities of the nonce, and the firmware will then decide which of them to actually send to the pool. And the difficulty of these shares basically is how the pool can figure out how much exahash or how much terahash that your miner actually has. Right, so it's just like a mathematical calculation based on the difficulty that you achieved. This is probably your hash rate. Now, one way is, let's say, like with Electron, like you have 2,000 miners, you could point all 2,000 miners to the pool. However, at one point, you will actually run into some limitations of like Linux and things like that. Like Linux, for example, anything above, I think, 50 or 60,000 open TCP connections is going to be a problem. So if you have more miners, you kind of need more pools, or you need like a load balanced pool and all that stuff. But because the firmware already decides to only send a specific amount of difficulty to the pool, what you could actually have is a proxy where all the miners are connecting to a proxy, and that proxy will behave to the pool as one very good miner. And this very good miner is basically the pool will look at all the shares, and it will just pick out the ones with the very good difficulty. It will only send them to the pool, and then the pool thinks, oh, you are very powerful, even though it's one of the shares that just has been. So if you look at the stats, if we scroll down,
Yeah.
there are probably like, so all these brains hash rate, oh, we have a new difficulty, 3T.
Ooh.
Ooh, look at that.
Wrigley.
block party. So this is proxied, I think.
Correct, yes. Yeah,
Let's-
so if we go to Wrigley,
Let's find them.
yeah, probably higher up.
Not terahash. That'd be awesome, though.
Yeah, so see, Wrigley block party Telehash.
There's not
They
a
ap-
16 petahash miner.
Exactly, not yet. Number one, next.
Next
Number
one,
two.
yeah.
Yeah, so what they're doing is they're doing some kind of proxy. Like behind that is going to be at least a couple of hundred miners. So they basically have a proxy software that probably even more multiple thousand miners all sending it to that proxy, and that proxy then sends
Saz as well, who we've got, shout out to Saz there in the audience. Looks like they have.
Correct. Same as Compass mining.
And Compass,
yeah, so
yep.
basically anything that is above. What's the highest level we have right now of miners? 250 terahash.
They have those Hydro 20 kW bitmains that are like a petahash.
Okay. Yeah.
Okay.
So
Or anything above a petahash
Yeah.
is a proxy. Yes. Now, what we're talking about is there is no real open source proxy. There is one by Brains, the farm proxy, they call it. So you can do proxying there, but it's not open source. So the idea would be to build an open source proxy, which then can be used by miners, right? Instead of pointing 2,000 miners to one place, they can just point to their proxy, and then from the proxy there is a bit more efficient. And we actually have been talking to very big miners. For example, if you try to run a lot of miners through Starlink, which some people have to do because these these data centers, they maybe have power, but they don't have fiber connected yet, so they need to run it through Starlink. And running 2,000 miners or 50,000 miners through Starlink is a bad idea. So you can actually run a proxy. So it will be helpful for these proxies, for these miners. But also for anybody that wants to build something like Compass or Wrigley or SAS, whatever, like they want to provide a service of like hash rate rental system. There's no open source project for that as well. Right? So Brains, they all build it themselves again. It's closed source. So the proxy could be the first step for an open source hash rate rental system. Now, I don't think that is going to be inside HashScope. There's a slightly different, but the code is very similar, like receiving requests from different miners and forwarding it to a pool. The only difference is that I need to then pluck out the correct hash rate or the correct share and decide which of them I send. Or maybe I have different pools, right? A proxy cannot only forward to one pool, I could actually forward it to multiple pools and decide where I send the hash rate and what do I send to the miners and all that stuff. So having an open source proxy would just, again, in this whole Bitcoin mining ecosystem, allow a lot of people and a lot easier access to use it and build whatever they want.
That's what I was just about to say. I mean, the beauty here of these ecosystem projects, that's exactly how we frame them, is that all of this, back to the point of accelerating development, all of this adds more context, more documentation, more know-how for the next guy to go and say, I can just start here and build on top of it versus having to figure this all out yourself. So projects like HashScope, ASIC RS, which we should give a shout out to Brett Rowan as well. You mentioned that these miners have all these various different API endpoints. Sometimes they'll change version over version.
Yep.
So if you want to build tools that rely on communicating with the miners over API, you want a library that constantly has them up to date to support new miners or changes therefore. So I think these ecosystem projects are paramount for the development of the 4 core pillars, obviously, as well, but they just add to the whole stack.
Correct, yeah. So if you want to spend a little time on ASIC RS, so...
Yeah, you got it.
Yeah, it's...
I'm going to use it.
Basically, whenever, you want to talk to these APIs, you realize, of these miners, you realize very fast that the APIs change randomly. It seems like different versions of firmware, but also like different firmware and hardware configurations, right? That's the other thing. Bitmain, for example, there's not only one control board. I think there's at least 3 or 4.
Yeah, at least.
And so the firmware, even though you install the same firmware on an AM Logic and what's the other, like a Beagle board, the API reacts differently of what they give you. And so that's a massive problem. And so Brent started ASIC, or PyASIC first. That was a Python implementation. And now there's a Rust implementation, which basically standardizes all the API of these miners. So what is really cool, you can go to ASIC RS, you can point a Watts miner, a Bitmain to it, you just give it the IP addresses. It figures out how to talk to it. It knows the standard passwords of all these systems. Some of them don't even have passwords, another thing we should talk about. But it basically figures out how to talk to them, and you can just then talk to them like a fleet. So you can all of them, you can say, turn yourself on and off, and it knows, how do I turn off a specific S19 with that control board and that firmware? How do I do the same with Watts miner? Or how do I change the pool? Right? So I can go in and saying, for the next 7 hours, point the pool to the 256 Telehash, and you don't need to worry that a BitX has a different API than Mugina, than a Bitmain S19, a Bitmain S21. For ASIC RS, it looks for you that's just one interface. ASIC RS, though, it is not a UI, it's not a fleet management system, it's an SDK. So the idea is that you plug in ASIC RS into some kind of other tool. I use it for the home assistant stuff. So yes, if you want to control your miners with your temperature or your thermostat, and you have a home assistant. So when you install HasMiner, it installs PyASIC still, but we're on a version working on that uses ASIC RS. But we also seen other companies now, like Proto, using it in their fleet, because it, as far as anybody that I know is aware, this is the most or the widest support of all the different miner APIs out there. And there is, I think, at least 300 to 400 different APIs that Brent somehow figured out. He got his hands on these APIs somehow and implemented support for them, and that's awesome. Like, this makes a lot of things easier for teams, companies that have different types of ASICs that they need to control.
It's so amazing to have this sort of one-stop shop that gets you, the ability to access all these APIs. I mean, this is huge for people building fleet management software, and it was really cool that Proto, for their Proto Fleet software, utilized this because it's an open source tool, and they use open source ASIC RS to basically just drop in support for nearly all miners'
90%
APIs.
of all miners in the world.
Just like, boom, there you go, you got it. And this is a pretty cool story, but Mugina,
we're going to get there.
Mugina we got to tee that up.
Mugina was added right quick to it. So now,
Yeah.
you know,
But another ASIC RS is another example of something that really could only happen as an open source project, right? I mean,
Yes.
it's not like all these different minor manufacturers were ever going to cooperate on a standard or cooperate on a library, or which one of them is going to publish a library that supports all the other ones too. Like, this is really sort of
Shows
a,
how
a unique
early
niche
we
that
are.
only a unique niche that open source.
Yeah, but that's how
enables.
the revolution happens, right? It's one person having an idea, building it. I mean, Brent built it because they had it in upstream data. Like he works at upstream. They built these. How do they call it?
He needed it. It's his itch described.
Yeah, these like
The
these
containers,
gas powered
yeah, the
containers with
containers.
gas powered, and they had different types of miners, and so he could just have decided, okay, I'm building this and I'm using it internally, but for some awesome idea, he was like, hey, I'm going to put this on the upstream data GitHub repository. I found it because when I built HasMiner first, I only had S9 support. Because I had one S9 at home, or 4, and that's the APIs I built for it. And then people came to me and said like, oh, can you add S19 support? And I'm like, I don't have one, you can ship me one. But like, that was like, why would I, as an open source maintainer, now pay thousands of dollars to, and they were thousands of dollars at the time, now you get them for $100. But, and so then I started looking around and I found his repository, and it took me maybe 5 minutes to rip out my code, plug in PyASIC, and suddenly HasMiner had support for every miner that PyASIC supported. Right? It lifted me from a tiny project that only I could use, or the 3 other people in the world that had exactly S9, the same version that I had, with the same firmware version that I had, right? Because the APIs are different, to suddenly be able to used by everybody that has any miner. And that's the power of this open source, right? That we can work together on stuff that I could have never built. And now I'm so happy for what we're seeing, right? He switched to ASIC RS, which makes total sense. Or like he uses Rust now because Rust actually has bindings in Python and all this other stuff. So that's the really cool thing about Rust. But now public traded companies are using this tool, right? Like imagine from he uses it in his own shop to he makes it open source to other tools are going to use it, and now it's probably going to run the fleet. It's going to be part of the fleet management of the future of all Bitcoin mining all over the world.
Yes, and it's a public repository on the 256 Foundation GitHub repo, ASIC RS. There it is. Always working on it.
2 hours ago, of course.
Yeah. Yeah. Oh, I know. Brett's always working on it.
Seal miner, like try to figure out the API of Seal miner. The only way to do this is if you have one. And yeah, I think that's the part that I think is like, if you would try to do this and convince companies, like you said, if you try to build a correlation between all these companies, we agree on an API standard, whatever, this would never happen. Because these are all competitors, but there's one random person in the world that built something, makes it open source, and that step of him clicking public in the settings of GitHub changed the world. Like, I would have never been able to build HasMiner. Fleet would never have had access to all this support of everything. So yeah, this is like these tiny decisions that are massive.
And it's just like, it's permissionless to get involved with it. Like you're making a new miner, like rando miner 123, and you're like, I want to get support added in there. Like you download this, you're using it for your fleet management software. You got a new miner, you're going to add that, and contribute back into it so you can, have all these other tools support your new miner.
Correct.
Right.
Yes.
And that's just like how it grows.
And what is also really interesting now, there's kind of now an incentivization. If I build a brand new miner from scratch, it actually makes sense for me now to build an API that is already supported by PyASIC or by ASIC.
So you don't have to redo it.
Exactly. Because now, right, if I build something, I could build my own API and I could contribute to ASIC RS, or I could just use one of the APIs that everybody uses. And so,
And which API is going to be the most feature rich?
Well, I think they're all shit right now. So I think we
Probably
need to ask.
Mugina.
We would need to. Well, yes,
Brett
but it
looked at
doesn't-
ours and said it was pretty good.
Say again.
Pretty
So that's a pretty
Oh,
good
Brett
vote of
did?
yeah.
There we go.
Yeah, but like there is no standard yet, and yeah, totally. I think it's gonna be the one that is also used by an open source firmware. But fun tangent of another tangent, like this is actually what's happening in the AI world. So OpenAI created their own standard or their API schema, how to talk to an LLM through the OpenAI API, and today every company is re-implementing that specific API standard. Because if I do this, I can just replace, I can just change the endpoint. If I have a tool that speaks OpenAI's API, and I have another company that wants to do the same, instead of rebuilding the tool, all I need to change is the host name and the username password, and suddenly it works. Like, so there is an incentivation in the end that everybody uses the same API standard. Now, in some cases, this happens from the beginning, as we saw it in OpenAI. In the mining world, this hasn't happened yet. That's why we need these shims, how some people call it, like ASIC RS. But yes, as soon as a standard will become like an open source firmware, this will automatically become the standard. And yes, in the future, if Bitmain is still here in 10 years, they will build the API based on the Mugina API.
And if that's the standard, then you don't need a library like ASIC RS at that point.
Yes, because so ASIC RS does two things, right? It normalizes the APIs, but it also allows me to talk to many miners at once. And that is probably still something that ASIC RS will fix. But correct, the whole API normalization layer we probably don't need anymore. Or there's maybe to support all these legacy miners.
Right.
But yeah, if you look 20, 30 years in the future, correct, that's probably not going to be necessary.
Pretty good is high praise coming from Brett. That's
Yes.
what Sandy says.
That's true. This pretty good seal of approval.
Hey, I was texting just briefly here with Wayne at Megawatt, and he said he might want to call in at 5 o'clock. So in 20 minutes or so, if we could do that, hear from
That'd be- yeah.
those
Is he
guys, and
bringing
then I
an
think
exahash?
we should offer up to bring anyone in the audience to come up on stage and talk to. What did you say?
Didn't we say like you have to bring at least an exahash to?
They've got 45 petahash. You know, it's funny. I said, what about in 30 minutes? This was 8 minutes ago. He goes, we have a curtailment event, and all of our hash rate will shut off in 30 minutes. But no, we should definitely open up the floor to him to hear what those guys are up to and thank them for their hash rate. I'm curious to ask the folks in the room and anyone that wants to call in, like what they're excited about with open source mining, particularly what pain points they're facing in their minds and operations. So we could do that. There's a pizza in front of us. You guys feeling bathroom breaks yet? How are we doing?
I can eat.
Pizza smells really good.
Pizza does smell. We can still spitball and munch. I'm just
Well, I mean,
saying.
we could-
I'm just saying in
two
20
of us
minutes,
could-
let's, yeah, that's true. Does anybody want to take a break?
I'm good.
Good?
I mean, go for it. I already took a bathroom
I'm
break.
going to go
so-
chow probably and then be back in 5
Okay.
minutes.
All right.
Yeah.
Let's do
But
it.
I do think we should perhaps in the next 20 minutes before we start hearing from other folks is talk about the combination of all of the projects in this physical manifestation here.
Yes. Do you want me to get it running again?
Yeah, Scott, why don't you tee it up?
Do
I'm
we,
gonna-
X, do we want to try my camera? Try my camera again?
What's the? We got a little. While we're getting that set up, we got a little change up in the workers that are sending us hash rate. Nice Hash is apparently buying some hash rate with USDT. It's an interesting strategy. I'm not really sure. Apparently, you can get 110 petahash with it, so that's cool. We got megawatt. Oh, Dylan's got more brains. I found some more stats to rent hash rate. That's cool. Good job. Click here. Oh, really? Okay. All right. Let's go down to the difficulty leaderboard.
Ooh. Whoa.
Yeah.
Oh,
5.6. Oh man. All right. The The browser extension is a little slow to load that. Okay, cool. But yeah, that's getting there. Gotta get those numbers up a little bit, but we got this. Shout out to 172x20x113x47. That's got to be like some coordinates of this machine in this massive farm of miners.
Yeah, I was wondering that in Telehash last time. I think that's one of the things we should ask them. What does these numbers actually mean?
It's like
cool.
room 172 on the rack 20,
Row 28.
row
rack
20, column
113.
113.
Yeah, that's the IP address.
It's 100% the
It's
IP.
more fun to.
That'd be a good way to lay it out. All right. IP address in the machine. That's cool with the X's.
Well, because you can't do dots, like in a worker
right.
name.
That's right.
But I would have done dashes. X's is a weird.
Compass Mining, SAS Mining, hardestblocks.org. Got a rental there. Crank it up. Got an A3 Hydro. A3 Hydro, is that the seal miner? Don't they call their machines A something, right? That's the new seal miner from BitDeer. Got a Hydro one, I guess. Daryl Zero. Guardrail Group. They use dashes instead of dots. Josh. The Rehash Lab heater, filament dryer, the camper van water heater. I think he's just showering this whole time, just so his hot water heater can just hash unlimited.
Yeah, I hope he's just connected. The camper van is just set up to take a bunch of water from a campsite.
From a campsite, and just got
just heat it.
sprinklers, spraying the hot water around.
mean,
That's cool.
That's one of the tricks, right? On these campsites, you
Yeah,
don't
you're
pay. You
familiar
don't
with
pay
this.
by kilowatt.
You just
So-
pay the camping fee?
Yeah, you pay the camping fee. They don't charge you by how much power you use.
Do you? Would they be concerned if you
So-
just rolled up with a trailer full of miners instead
So
of?
fun fact. So when I did my first S9 build, it was for an Airstream trailer, and I posted pictures of the S9 sitting outside heating my Airstream trailer. And I said in the Twitter thread, I was like, well, this doesn't cost it's free. And so I had a couple of people DMing me pictures from their rigs with 8 or 12 S19s
In their camper?
in their camper, just heating the outside, not even heating the inside, just the outside.
Your picture was in the snow, right?
Yes.
It's everyone's all snowed in.
You were
and
road
just
tripping.
melted.
And it was actually when Ruth and I got married. We were in Colorado, and one of the problems, it actually solved the problem to me, right? So we have an Airstream trailer, and it has 2 regular propane tanks. And the issue is that we had to fill up the propane every 2 or 3 days. And with the S9, we only had to fill it up every 4 or 5 days.
That's what I'm saying, dude. Solves propane.
Yeah. But yeah, so I got pictures of people that sent me of their fifth wheels with in the auxiliary panels. They have some S9s. But what is interesting is these rigs, they're already loud because they all have AC units on top or heaters anyway. They make a lot of noise already. So the guy that sent me the picture is I've never been asked. And they use a lot of energy already, right? To heat. Some of them actually have some of these AC units.
Yeah.
They have auxiliary heating, just with resistant heating. So if you run out of propane, you have to heat your massive rig, your fifth wheel, with electricity already. And so he was well, I'm doing what everybody else is doing, and nobody of the campsites complained so far.
So how many amp service is typical at one of these sites?
50.
50. Yeah. We need these sites that review different campgrounds and stuff. We need to get them to add. We crowdsource to add how many amp service that you get.
Oh, they have this already.
Really?
Yeah. Yes. So if you have a rig that needs 50 amps, there is I think Compendium is one of them, which is like a camper site, and
Yeah.
it tells you how sometimes for each campsite, if it's 30 or 50 amp, and sometimes down to the each individual stall, like because sometimes they have like it's limited that this part of the campsite is only 30 amp and this one is 50 amp. So it's made for us.
Genius. I saw a used Tesla for sale that they grandfathered in like unlimited free supercharging,
Oh,
and it's a 100 kilowatt hour battery and unlimited free supercharging. And I was like, ooh,
yeah.
you could run a solid 4 or 5 kilowatts.
We need to get into this
Each
power
all day.
electronics thing and basically do, an adapter to your miners from that like charging plug directly.
There is an open source project that does exactly
Really?
that. Yes.
Yes.
People reverse engineered the communication protocol of the Tesla charger. Is super simple.
Well, it's a standard now.
Yeah, now it's a
NACS,
standard.
North
yes.
American charging standard.
The only problem is the supercharger is DC. So in cars, the slow charging is AC.
Okay.
The fast charging is DC. So, and we're talking like DC 400 volts. So,
It's some power electronics. We can figure this out.
but yeah, you could totally fake these chargers that you are like. There's nothing encrypted or in any way. It's just a communication protocol where the car tells the battery or the gas whatever the control system what battery you have, how much power you expect, is it DC or AC, and you tell it how much you want, and then you will get it.
Oh man, I can't wait to build this box that's got the car charging port on one side and then a bunch of cables that go out to those Anderson power pole plugs that all the miners use, right? Just like connect them all up that way directly.
I think the only problem is like how do you argue that you're gonna basically squat at the superchargers all the time?
Yeah, maybe you have your Cybertruck or whatever that's towing this trailer full of miners, right? And you're just charging.
Yeah, but like there's a lot of places where like at offices or like office complex where there's just chargers in the basement.
Do they limit you on like for this unlimited charging plan? Are you like limited on time, or they just figure you're just charging your car and it's going to be done pretty soon and you'll leave?
That's the idea around the supercharger, yes. But like if you use, let's say if you have a charger by your company, sponsored by your company, yeah, sometimes you can just charge for free. Like it's a perk for the employee to charge your car at the employees in your office building. And I've seen ways that there's like limited. So like you can charge for 2 hours for free and then the price goes up, so it encourages you to remove. But
Okay.
sometimes it's also completely free, so you can just connect all day.
Yes.
So yeah, you can have a couple of miners in the back.
Yeah, you're just. So that's the thing is right. You're charging your car, but maybe you don't need that much charge, so you're just always in max current supercharger mode, and the excess goes to your miners. Because you're just rolling them around with them in your car anyways.
Correct. Yeah. Yes. I mean, the possibilities are endless. Or the other thing is, right, you can just, a lot of times you actually don't discharge the battery in your car anyway, all the way down. So that like if you know that you're going to end up at a supercharger, and let's say you're going to be there for an hour, but charging only takes half an hour, you can just run the miners in the back of your car while you're driving.
While you're driving.
And that's the AI again that comes in. Like the AI in Mujina realizes, oh wait, you're going to be there. It's going to only cost half an hour to charge, but you're going to be there a whole hour. I'm just going to mine a bit more.
Oh yeah, because the Teslas have that thing where it's like, it knows where all the chargers are,
Correct.
and it tells you how long it could take to get there. So you just kind of tap into that and make sure that you're on 0% by the time you coast into that
Exactly.
charger,
Yes.
like every single time.
Yep. And the first 80% is ultra fast anyway, right? It's like with any LiPo that at the beginning, the initial charge you can do extremely fast, and the remaining 20% takes a long time.
Okay.
That's why most people charge their cars anyway only to 80%, because you wait 20 minutes to charge to 80, and then you wait a whole hour for the remaining 20.
Okay.
But yeah, you could totally plan it in a way that is like, yeah, so maybe, yeah, that's probably the best solution. So you don't actually want to mine while you're connected to the supercharger, but you want to mine while you're driving before you fill up your battery again.
Oh man, that's so cool. I mean, that's like the sort of dream of that, price arbitrage controller for solar, right? It's like you always need to make this decision at a given time. Is it more profitable to send my power back to the grid to charge my batteries, or to use the power in your house?
Correct.
Right, in a given time. And so you could basically take that same sort of thing and then add it into your electric car.
Yeah, and then nobody will look at you weird if you drive up to the supercharger with 10% remaining and you just charge it fully up.
What are we talking about?
Just gaming the system to put miners into our
So
electric
we decided you
vehicles.
should buy that car, and we're gonna install a couple of miners.
Dude, it sold for like $9,000. Would you spend $9,000 to have unlimited free supercharging for life?
I mean, if I live close to a supercharger and I can just
And turn the car into a Bitcoin mining machine with wheels?
I mean, if you got miners attached to it, you could
I
probably
mean, if you could
recoup
work
that.
remote, like if you could work at the
Could
supercharger.
you mine while you're sitting at the supercharger and then the car never fills up?
Well, that's the thing we talked about. So I think that would not work because they would probably at one point kick you out. Like there's probably some time limit.
They already charge you if your car
idle.
finishes charging and you idle, yeah.
Correct. No, but what we're saying is, let's say you drive up to a supercharger. Your car is currently, let's say, at 50% full, and you have a couple of miners in the back, and the miners know that you will get to a supercharger, so you will just mine along the way, driving to the supercharger, deplete the battery faster, and then
And
when you
exhaust the heat out the back as thrust.
yes, you get like 0.01% improvement. Nobody can heat your car. You can have a sauna car.
That's true.
Driving sauna.
I think they have heat pumps.
And then you arrive at the supercharger, and you just charge full.
Yeah, you
So-
basically show up to the charger at 0%
And then
every single time.
and the system that monitors your usage, right? It will not see you chilling for longer than you need because all you do is you charge up the battery again. And so basically, yeah, if let's say you drive anyway with your car, let's say your commute anyways is you drive by a supercharger and you're willing to just sit another 20 minutes longer, right? Because the charge, the first 80% goes really, really, really fast.
Yeah.
And so you just mine, then you leave the supercharger again, and just while the commute, you're mining. And if you can work remote, there's like, at all the superchargers, there's people sitting in the cars working. So it's completely normal that this is like, yeah, a missed opportunity.
Totally missed opportunity. Let's see if Megawatt's going to join in here. Yes, I need to send him the Jitsi link. Is that all we have to do, Frog? All right, so in 5 minutes here, we're going to hear from Megawatt, then we should hear from Saz. I saw Kent in the room and others. If Electron still wants to come up and say anything. And then we have some hardware to show off, I think. Let's see here. Yeah, grab that pizza. It's delicious. Sure, for 5 minutes, that'd be great. We'll be back in 5. Oh, the browser extension. I gotta. Let me back out and rejoin.
Running the shadows, damn your love, damn your life. Break the silence, damn the dark, damn the light.
Okay. My laptop audio is on.
And if you don't love me now,
I hear you through my laptop speakers. Yeah. We'll do it live. Let's sort it out. Yeah, we can kill the music and just talk a little bit until we're ready to bring Wayne on, if that sounds good.
Mega Wayne.
Mega Wayne. You guys refueled? I'm refueled.
Getting there.
I just inhaled 3 slices of pizza.
Yeah. It's a record.
I hear him through my computer audio.
I know, I'm just not getting him into my computer audio out to you guys, so it's going to take me a minute. I had to reboot the computer. Of course, everything works when you need it.
It's like the old school telethons, right? They would always take breaks and they would show you like a TV show or something, right? Yeah. Do you remember this? Yeah, like, I do. You'd be watching your PBS station and it'd be like, there's a show, and then there's like hours of
20 minutes,
telethon,
yeah.
and then-
I remember that as a kid. It was frustrating.
It was super frustrating. Like, I want to watch this.
Their normal programming
Yes.
for 20 minutes of
And they would do it. They would do it for like
phone week. Yeah.
What are you talking about?
back in the old days when there was just like stuff on the TV, you know?
Oh yeah, the trying to sell you jewelry.
No, not home shopping.
Not home shopping.
No, it's not. That was the home shopping
Channel.
channel. Yeah. Network. If you had cable.
This is like public TV used to raise money 3 times a year, let's say.
Oh, I see.
So after every show, there'd be like 20 minutes of fundraising, like live.
Yeah, live like
A phone bank behind it, like people answering
the
phones.
desks,
Like
all the phones, and then constantly.
you hear the ringing. Constantly. I'm sure that was.
Oh, the tele part refers to telephone, and it was a.
What's that?
It's like
People would call in and pledge donations because you couldn't settle at the speed of lightning or Bitcoin or even credit cards.
I see.
So you would call in and talk to an operator and like, I pledge $1,000, and they'll write you down for $1,000 and then send you a letter so you follow up with a check or something. You heard of those?
Test.
Go ahead, mute your computer now.
My computer is muted.
And then
It's funny. People don't necessarily know what a telethon.
they don't. It was like the most frustrating.
Got
thing
him pinned.
ever, right? Because you're like, I just want to watch my like cartoons or whatever on PBS, and they're just like,
We got him?
Yep.
Wayne. Mega Wayne.
Yeah.
What's up, dude?
Hey, I can hear you through Frog's computer. I'm just getting like an echo of you.
Yeah, we got a speaker right by the mic. That's why. If you can handle the echo, then we're going to rock with it. I think.
Okay. I have just speakers behind me, so am I echoing at all?
No, you
Are we
sound
all
great.
good? Okay. If I put headphones on randomly, it's because you're quiet, and I need to just make you louder. So
Gotcha. I'll,
cool.
yeah, X-Rock can make you us a little bit louder for you.
Nice.
How are you doing?
I'm good. How are you guys? Fourth Telehash. Look at this.
Fourth Telehash. We gonna mine a block?
What's that?
Are we gonna mine a block?
Yeah, I told one of our technicians to just sit and stare at some of the machines, so hopefully that'll like help speed it up.
Does the miner that mined the last block, does that one still exist?
I think it's this same machine that keeps hitting like all these difficulties because we've been like the highest difficulty the last like 3, I think, as well. And I think it's just one machine that's just been chugging along, doing all the work.
never unplug that one.
Yeah, never unplug it. It needs a sticker or something, an indicator.
Yeah. No, it's crazy. I can't believe you guys are doing this again. It's been super fun to support this and watch all the other people join in and support you guys and just point thousands of bit axes and other ASICs towards this really cool kind of open source fundraiser. So
We appreciate that. Longtime supporter. Highest difficulty in Telehash number 2. Actually solved the block in Telehash number 1. We forget what happened in Telehash 3. At least I do. We'd have to maybe go back and do some digging around. Maybe you know. But yeah, curious to hear what's going on with Megawatt, how things are going at your end, what you guys are excited about. And maybe we can talk a little bit more about what excites you in the open source mining domain as well.
yeah, I think I got all of that question. It's still a little tough to hear, but it's been good. We've been busy. The big thing we were gonna kind of just chat with everyone and showcase like live on the Telehash, like I was talking to you about earlier, is some of the real time rates that we've been working on. We've been building and running real time day ahead and peak avoidance strategies up in MISO, which is big in the Midwest. If you're not familiar with the area, MISO is one of the larger RTOs in the US. And we've been doing all that through our own in-house curtailment logic, which has been pretty cool. I'm not even the main one on it. I was hoping to get Dean or Ilya, who've been ahead of that, on here to chat about that a bit more in depth, but figured I'd kind of share this with you all a little bit. But it's very similar to the real-time rates that a lot of people see down in ERCOT. They have like 4 CP. As of today, we're opening up access for other operators, other miners that want to use this software. It's similar to what you've seen before. It maximizes uptime, minimizes dollars per megawatt hour, and effectively avoids MISO 12 CP, your 12 CP for local balancing authorities, Ameren, Duke, NIPSCO, stuff like that. So if there's anyone out there that's listening to this that wants to get involved with checking out that software, just reach out to us. You can go to our website at megawatthq.com or just get a hold of the guys at the Telehash and they'll point you our direction. So that's what we've been working on, which has been fun. So
That's awesome to hear. Is this related? I saw some of the announcements from Ilya's account, Ilya, who leads Megawatt, with some legislation in Indiana as well. Fill us in there.
yeah, that's been really cool to watch as well. Ilya's been working on that for, I think, 3 years now, which just goes to show you how kind of slow things can move in the political world. But yeah, he's been working on that for a few years. That just passed. We got to go up to the governor's office, the state house here in Indiana, and shake the governor's hand. He officially passed that through a few weeks ago. Actually right after, basically during the Bitcoin conference. It's worth a read. Ilya posted on his LinkedIn, Ilya Rector. He had a bit of like a crazy story from going from basically the Vegas conference, taking a red eye back to Indiana to make that on top of a few other complications that were going on. He wrote a LinkedIn article about it. Go give it a read. I don't know if you can like pull that up on the screen or like link that somewhere. Pretty good story to put Ilya on for kind of championing that whole process.
That's amazing. Yeah, kudos to him and the team. Super cool to see. Well, I'm glad things are going well. We appreciate all the support. You guys coming in hot with these lucky miners that always have high difficulties solving blocks. It's awesome to see. What kind of pain points exist in the mining hardware and software that you guys have had to overcome? Or more specifically, what kind of features or things are you excited about that would be helpful for the developers here we got on stage with us for an open source mining stack? Anything come to mind?
Yeah, it's been cool to see all the stuff that's been built by all of you. I mean, it's kind of inspiring. And I think so much of what this industry is going to look like, in 10 years down the road, 5 years down the road is going to be built off the things that you guys are building. Guys like Brett Rowan building ASIC RS. I mean, those are just like all of these stepping stones that are going to fuel this distributed network that's going to run down the road. I'm really excited for the scratch-off community to better understand solo mining. That's a great one. That'll be nice. And no, I mean, it's amazing to see the vibe coding kind of community or whatever you want to call it, how it's just really like lit tinder or a little fire into how many people have stepped in and just started building stuff in this space. And I think that's what we needed more of, the last couple of years. It's just more people involved, more people contributing, pulling and committing, new options on top of the software stack that existed.
The barrier of entry is certainly coming down. Everyone's kind of soon going to be able or is already able to be a mining developer, which is exciting. Yeah. I'm thinking about you guys and what Michael and I were talking about with the group here on stage earlier, just like with this open source reference design for a data center. I imagine that will someday exist for a mining site, right? So you can just rinse and repeat and deploy these things faster, better, stronger, easier to maintain. So we do hope we believe it's going to solve a lot of challenges for the mining industry as a whole, from the bit axes all the way up to the large scale deployment. So very much appreciate the donation and the hash rate. You got to tell the team, everyone, we all say hi. Anybody else want to say anything to the Megawatt crew?
You guys are the best. It's fact.
Yeah, you guys are great. This is Ryan, Wayne. I have a question in particular when it comes to curtailment. What could the mining firmware do better to make that easier or more performant?
That's a good question. I think the hardest challenge, and I'm probably the worst person at Megawatt to talk on this, but I think I have kind of a good idea. The miners natively, in most cases, have the ability to curtail in seconds, right? And that's kind of native, built on the machine. So probably just the communication over the API, because like what our logic does that we've built out is takes all of the pricing data, all sorts of other factors that figures out, hey, should we curtail now? Should we not curtail now? Rinse and repeat every second of every day, 24/7. And then it's just that bridge between the logic of what tells us when to curtail and then with the existing miner firmware, whatever you're running, actually shutting the machine down. So making sure that there's a good connection there is probably the last thing that's needed to put that full picture in place, I would say. That's my guess.
When you curtail, do you shut everything down completely? Or is there types of curtailment where maybe you drop to 50%?
In our cases, it's usually like all the equipment. We leave fans on, stuff like that. I don't know if that's what you're referring to, exhaust fans and stuff like that. But for the actual mining units, it's, straight to sleep mode. Some curtailments last, they're scheduled if it's like a day ahead where you're offline for 6 hours, something like that, something crazy. If it's a real-time event where you're offline for as little as 5 minutes, those factors play in. So it's not always a black and white answer there. But I think in most cases, it's usually you're sleeping the equipment, you're not powering it off. And that's usually really simple to do at a high level. And I think a lot of the open source fleet management stuff can handle that now, which is good. That's what we use. So it's cool. Curtailment's so fun. I think it's so important. Like I was telling Tyler earlier, I'm pretty sure we're curtailed right now. So I think megawatts dropped off the leaderboard, but it's because there's a really big storm going on here in Indiana. And basically the market saw that was going to happen and said, hey, let's curtail megawatt because the grid's going to be stressed tomorrow around this time when this big storm rolls in. And it's just like, it's watching this living, breathing thing that is Bitcoin, respond to the live grid and everyone that participates in it. It's just so cool to see it work every day.
Hey, Wayne, question. Do you have like an API or how do they tell you when you should curtail and how much?
This is a great question. I wish I knew the great answer to give you all the details there, but that's more of a question for Ilya, Dean, and the software team that's been building that. So we should talk about that though later. We should set up a call and can dig into the details there.
Have you on the podcast?
Yeah, would love to have you guys on Pod 256 too, because it would be helpful to learn exactly how this works. Because maybe there's an opportunity where you could curtail down 90% and still keep a small stream of hash rate online, because the firmware allows that on an individual miner level, where you can dial it in, exactly meet the grid's request, and you guys can still make the Bitcoin that you're allowed to make per that contract.
I also wonder about turning back on. Like, how long does that take?
Yeah, are there ramp rates that the utility requires? Do you drop everything at once? Do you ramp up or ramp down? Is one nicer on the grid than the other? Maybe it depends how big your site is, how much load you really are representing.
Yeah, I'm sure that there's some sort of demand from the utilities, but then also demands from your site too, right? It's like you can't just flip everything back on 100%, right? That seems like it could be a huge inrush current. So there could be some strategies there to increase the lifetime of your equipment, increase the lifetime of your miners, ramp them back on.
I think we should get these guys on Pod 256 to learn about it.
Yes.
That'd be awesome.
Yes, it would. I'd love to.
Well, sweet. Awesome to see you, Wayne. We appreciate the support. Tell everyone at Megawatt we say thank you, and we're going to keep the ball rolling here for another hour and a half or 2 hours and a half or so.
We'll be following up. I've got one other cool thing to leave you guys with before I go. One of our site technicians is a race car driver. It's pretty cool stuff. And I've had this crazy idea. I want to strap a bit axe to his race car, and then it's like this Circle 8 race car track that they do. So the cars are literally crossing, going 80 or 90 miles an hour, something crazy. It's nuts. So I don't know if you guys know if there's a world record for fastest speed that someone's ever been traveling while mining Bitcoin. But we're going to try and break that record.
I think it should be some crazy air-cooled thing, too, where it doesn't even have a little fan. It's just the force of the speed of the vehicle.
Like a hot rod scoop, just,
a little
scoop into it. That would definitely be a land speed record. I know someone's mining an airplane. Those are pretty quick.
Yeah. We should do that.
We should do that.
That's sweet.
That'd be awesome.
Love the Bitcoin racing stuff. We need more of that.
Megawatt is as a longtime champion of Bitcoin racing tie-in, I went out to an event with the Megawatt sponsored car at the Indianapolis Motor Speedway. That was a couple years ago. That was.
Doesn't Ilya have? Isn't he a BMW geek?
Say that again?
Didn't Ilya have a racing BMW that he autocrossed and all that stuff?
It was a BMW M2 CS.
Yeah,
that was sponsored.
Heck yeah.
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 I was thinking about that the other day, Scott, because that's when I first met Scott, when we had him out for that at the Indianapolis Motor Speedway. And the Indy 500's coming up pretty quick. So I was thinking about that not too long ago.
That's cool.
Well, check out the Megawatt guys. What's the website for everyone listening?
It's megawatthq.com.
Awesome. Appreciate it, brother. Good to hear from you. Until next time. Until next Telehash.
Yes, till the next Telehash, we'll be there. Hopefully get some more exahashes and mine some more blocks. So see you guys.
Godspeed. See ya.
See you later, man.
So cool.
Nice.
Shout out to X-Frog for making that all possible with our crazy AV setup over here.
Yeah, this is pretty. We've really leveled up this time with the AV setup. This is cool.
Big
Where are we
time.
at? We're 1.2 exahash. It's kind of insane that we're like, oh, we're still at 1.2 exahash. That's like the most we've ever had.
I love this idea of over the next season of the podcast, maybe doing several interviews with people from industry to learn about pain points in hardware and software.
Yeah, that's a great idea. You mean you don't want to just hear us say the same thing over and over and over?
Oh, well, that's fun too. But I just mean as a means of collecting requirements and stuff, that would be
That'd
be
be
great.
fantastic. Yeah, there's so many people out there doing fantastic stuff, and figuring out what's working for them and what's not working for them. To inspire them or other developers to take these tools and build these solutions on top of it, because now it's easier than ever. It's more accessible than ever.
Mm-hmm. Yeah, I really like that idea of hearing pain points, because every mining operation is a little bit unique. I mean, I didn't know that it was even possible to plug into grid APIs in Indiana and curtail like that. We're going to learn more about that tomorrow and the day after here at the Texas Energy and Mining Summit at Bitcoin Park down in Austin, Texas. What should we do next? Should we talk about the Dumax?
Before the battery runs out, yeah.
Before the battery runs out, which is a teaser for anyone listening. Battery-powered Bitcoin miner.
Yes.
So, Michael, we talked about extensively all the 4 core pillar projects of the 256 Foundation, and for Bitcoin Las Vegas a couple of weeks ago, we wanted to have tangible physical hardware in hand to showcase these projects, the progress
Yes.
we've made. And because there's a working version of all components, you had the nifty idea of building a battery-powered Bitcoin miner, open source, hardware and software, in I think just a couple of days.
Yeah, so
Walk us through it.
So the original idea actually did not come from building a mobile miner. The main idea was, like, I built the Libre board, Eco assembled the first Libre board, and I had to test this somehow. So I basically went to Amazon, and for every connector on the thingy, on the Libre board, we talked about them before, I was like, I will buy a display, I will buy an M2 slot, I will buy a Raspberry Pi, a couple of displays, like just the things that I wanted to do to verify all of this. So I started to hack them together, used AI for all of it, and eventually I realized, wait, this is now a complete Bitcoin miner. And then Eco actually nerd sniped me, because in one of our one-on-ones, he was like, well, couldn't you bring it to Las Vegas, and couldn't you put a battery in it? And I was like, okay, I'm not going to sleep now, and I'm going to figure this all out. So
Keep going. They're
So-
figuring out the video camera.
So what I built is what we call the Dumax. It will become clear why it's called the Dumax later. But it's basically all 4 projects, like you mentioned, inside one box that is battery powered. So if we look inside, so on the left, we have a Libre board with the Raspberry Pi on the top right. It runs a Linux with Machina deployed, but because you can have an NVMe, so and it's a full Linux. I also installed a Bitcoin full node, and I also installed Hydropool on it. So it runs Bitcoin, Hydropool, and Mugina, and it's connected to the BitAx, Now this BitX runs BitX raw, so basically the BitX just behaves like a hash board. I could have
So
used
nothing's running on the ESP32.
correct. The ESP32 is just like in pass-through mode, so Mugina sees it actually as an hash board. And I used that because bringing an Ember 1, while would have been possible, it would have drained the battery a lot faster. And Ryan actually used BitXRaw to develop Mugina because at the beginning we didn't have Ember 1s yet or hash boards yet. So you basically flash BitXRaw on it and then it just appears as a hash board. And that's what Mugina that runs on there. And correct, like the idea is to show it off at Bitcoin Las Vegas, the 256 Foundation. As a team, we didn't have a booth, so I knew we were going to walk around a lot. So I was like, hey, because I have a wide input range for the Libre board, which is 12 to 18 volts, these batteries have 14.5 volts, so we're spot on. This is just a regular LiPo battery that you find in like mobile scooters or whatever. So they have 12 volts. Of course, the voltage goes up and down, like depending on how much charge there is. But the voltage regulator that sits on here that regulates the 12 to 18 volts to 5 volts, because that's what the Raspberry Pi needs, it can handle that. You can give it whatever voltage between 12 and 18 volts, and it will regulate it down to 5 volts. So that worked. Then there is actually the BitX, funny enough, also needs 5 volts. So I actually soldered on a connector directly, so the BitX is actually also powered through that 5 volt rail. And because I built it, I know where the 5 volt ports are, right? So I can just like solder that in. And yeah, so this is, as far as I know, one of the first, again, there probably were some in the past, complete open source hardware and software Bitcoin miners that runs a full Bitcoin node and a pool, everything all in one contained. All it needs is Wi-Fi. But it needs Wi-Fi not to talk to the pool, it needs Wi-Fi to talk to the Bitcoin network. So this thingy now is actually connected, I just checked, to 30 different Bitcoin nodes all over the world. It receives new block, and if the little BitX that has 1 terahash, so the chance of finding a block is like 1 in 17,000 years, it will propagate the block to the world. So yeah, that's what we've built. However, I mentioned, right, it's more about also testing all the different connectors. So we have the SSD I talked about, we have a fan, like I'm testing the fan through here, so that I actually have a little temperature sensor over here, so that measures the temperature of inside the box, right? So that's one of the things. A regular control board usually measures the temperature of the fans, of the chips, and modulates the speed of the fans based on that. But what I'm doing is this fan here is modulated based off the temperature inside the box. So it measures it, and depending on how warm or how cold it is, it automatically changes the speed of the fan. And then I also have on top, because so Raspberry Pi makes these awesome displays that also touch screen. So there are full multi-touch screens. And what I deployed on here is the hash dash. However, I told my AI to make it more in Dumax version, so that's why it looks slightly different. But yeah, it's basically, obviously there is exactly one thing connected, because it's its own pool and with its own Bitcoin node. Yeah, so that's a display. So you could imagine, right, this could be your full control system to control your house or whatever. But then on the side, I wanted to look at some different things, and there is this Sense hat that has this cool 8x8 multi-RGB LED display. So again, I asked my AI to show some data on it. It also comes with a joystick. That's just part of that. It actually also has an accelerator, a barometer, like other sensors that I could use for other things. But as we talked about, we want displays on our miners so we know what they're doing. So I actually built a little, with the joystick I can switch between. So if first we see how much the BitX is currently mining. It's auto jumping around, so 1.15 terahash, how many shares, how fast the fan is. the ASIC temperature. Then if we go one further, it monitors the voltage of the battery. So it can tell us how much power it currently uses and how much power there's left in the battery. We see 70%. We can see stats about the Bitcoin node. It shows us the current block height, how many peers are connected, the difficulty of the network, 136T, that's what we need to hit right now. How much exahash, looks like we have one zettahash again in the network. We can see the pool stats, so how many shares. The highest share is 44,000, it just started mining. The earnings, so I make right now 53 sats a day, assuming I would mine, but I solo mine, so I obviously don't, but it tells me 16,000 years to mine. And then a little temperature sensor, so it shows me. But, right, as we're nerds, and if there is a little display on anything, the big question obviously is, can you play Doom on it? And so I asked my AI to basically deploy Doom on this little display, so you can totally play Doom on a Bitcoin miner. And as far as I know, this is the first Bitcoin miner that also plays Doom.
Incredible.
I actually showed this to my wife, and she was like, Doom? Who wants to play Doom? We should play Snake. So I also did that, so you can also play Snake on this little RGB LED thingy. And it tells you on the display, it actually gives you the stats, and then when you run into the wall. So if anybody wants to do a Snake tournament running on an open source Bitcoin miner, I guess that's something we could do tomorrow.
Yeah, find the Doomax here.
Find the Doomax and do the high score on Snake. You just press 6 times down, and then Snake starts, and it tells you. Yeah, so, but what is really cool, what I haven't talked about, a lot, like all these things, so this display, the small display, the big display, Snake, the display on here, I've wrote 0 lines of code. All I did, I went to Cloud Code, I pointed it to that Raspberry Pi, and I said, hey, here is a Bitcoin miner. I think you have a display connected. Look yourself, right? So these are these quick connectors that we talked about. It enumerated the I2C bus, which is what this quick connector does. It found it by itself, and it asked me, what do you want to show on it? And it's like, well, you come up with an idea. So it by itself realized, oh wait, you have an X, you have a Bitcoin miner, you have a pool, you have all these things. Let's make individual displays. So this whole display of all these things, I did nothing in terms of design. This was all the AI coming up, deciding to show the terahash in a bigger, or these bars. That was all itself coming. And the same for Doom. I just asked it, hey, can you play Doom? And it actually asked me, how do you want Doom to start? And I'm like, I don't know, you come up. So the 6 times pressing in the middle is actually the AI's idea. So like, sounds like that it knows to shoot, that in Doom you shoot. And so that was really also the other thing that was so crazy to me, right? Like, if you would ask me to build this, I would probably estimate it 3 or 4 weeks. Being granted, like, I'm doing this in my free time in the evening, so that's probably how long it would take. But yeah, it literally took me 2 nights. So all in all, maybe 3 to 4 hours to build all of this.
Showcases how easy and quick it is to modify when everything is open source.
Correct.
And with the agentic world, AI coding tools being able to access the source directly, it knows exactly what to modify, how to modify it,
Correct.
what changes to make, to implement features ranging from something to optimize for curtailment, like the megawatt guys, maybe we should dive in with them, all the way to playing Doom on your Bitcoin miner.
Correct. Yeah, I mean, like I told it, hey, there's a BitX, there's Mugina, and it figured out the API of Mugina itself. It's documented in the source code or in the docs, and was just able to talk to it by itself. Yeah, so that's really the part that showed me personally the first time, is this power of open source and AI together in the hardware space. Like, we've obviously heard about it in the software space. It can build us dashboards and things like that. But the fact that it can actually help us build faster hardware or connect stuff that otherwise I would need to read hours of spec sheets of these displays and how to show pixels and how to do bars. Like, yeah, it would have taken me so much longer.
And everyone at Vegas was like, when can I buy it?
Yeah, that's the funny thing. We talked about this before we went to Vegas. I was like, we were joking, like how many times I'm gonna get asked, where can I buy this and how much it is. The reaction was really interesting. There's definitely people that are like, oh, this is novel, I want this. So yeah, they asked, where can I buy it? And there were other people that were like, that doesn't make any sense, right? Like the people asked, so how long can you mine? I was like, well, maybe for 3 to 4 hours. And they're like, yeah, that's not very long. This doesn't make any sense. So and like we have the same system, or same issue also with the sous vide. The last Telehash, when we showed the sous vide system, people were like, why would I need a sous vide Bitcoin miner? Like this is like trying to show, no, this is not an end product, but this is a proof of concept of what can be built. Because try to build this with a proprietary Bitcoin miner. I will challenge you will not be able to do this with a Bitcoin miner today. It's impossible.
It's an amazing display of like how fast you can iterate on ideas you have. Like, you know, whatever it may be you want to add to the miner, whether it's Doom or, you know, some functionality, control pumps and flow rate sensors for your hydro system, right? Like, I feel like now you can add these things like quickly, and you can test them like to make sure that they really work and are going to be reliable for your operation. Whereas I just don't know if people even considered it before because it was so hard. Right? It would be so hard to, like you said, to add this to a proprietary system. It opens up so many doors, and then, you know, each time someone adds something like this on there, now that's like a trivial install for the next person, and they can add something on top of that.
Quickly here, I want to pick this up, but I know that Kent has to run, and I'd love to have him join us on stage briefly. One of our large supporters, Kent, CEO of SAS Mining, to talk about what they're working on, and maybe we can dive into some open source mining as well. Kent, welcome.
Hey, fellas. Happy to be here. Do I need to eat the mic here?
Yeah, you got to eat the mic.
Got to eat the mic.
All right.
Thanks for the 6 petahash here we got on the hash dash.
You're welcome. Least we can do.
Let's go.
How are things going at SAS Mining?
SAS Mining, man, we're ripping and roaring. You know, I was sitting here in the audience just listening to you guys. I'm like, wow, I'm just downloading so much information. It's amazing how big the mining ecosystem actually is. You know, I'm operating my little corner of that ecosystem, which is, you know, mining as a service. We've built this tech layer to make it accessible for anybody to come in and mine, in kind of the same way that like Airbnb made it easy to do a home share, room rent out, that sort of thing, right? So it's a very different problem that we're trying to solve, which is access to the masses, right? Like, our competition is less like a traditional hosting player and more like an exchange, right? We want Bitcoin mining to be the way that people acquire their
Those
sats.
wild sats.
Yeah, those wild sats, which is amazingly the way Satoshi designed the network. Can you believe that? He didn't design the network to go buy your sats on an exchange. Isn't that weird? So anyway, that's what we're working, is to make that easy. But I'm like listening to you guys, and you guys are like, the way I look at it is like mining is this stack, right? and you build up to the top of the stack, and that's where I think we are. And you guys are working, a lot of what you're doing is kind of like the bottom layers of the stack.
Under the hood.
Yeah, under the hood. And I'm just like, wow, you guys are the real mechanics here, right? Like actually getting in there and like grease up to your elbows and like figuring it all out. And I mean, the thing with like what is it, ASIC RS?
Yeah.
Like that sort of like fundamental infrastructure is so incredibly important. As I was thinking about it, you know, I spent a decade in rooftop solar, right? And one of the things that I saw there, if you guys want to talk solar at all, happy to, you know, answer a few questions. But one of the things that I've seen there is, you know, it's an emergent industry like ours is. And as different players got big, like these issues popped up of like, how do we actually talk with each other's systems and tools? And so it's not new to Bitcoin mining that we have these same issues, but I love how it's being solved in this open source way instead of in an industry consortium sort of way of like, okay, now we're all the big players in the room and let's go in and duke it all out and figure out who can power play each other around. It's like, no, we're just going to open source and figured this out, and now we've solved it for everybody. Like, anyway, so I can see that being like the base layer, like this sort of stuff that the ASIC RS represents. Like, it's just one example of what you guys are helping to push forward as being fundamental to the growth of the entire ecosystem.
Yeah, it's absolutely huge. I imagine a lot of these tools, I mean, that's the goal, is to solve problems and leverage the community development that open source provides for mining operations of all sizes, from people that want the DIY setup and they want to tinker and learn the stack, to they just want mining as a service where they can get some of these wild sats. So very insightful to hear. What do you think are some of the pain points that you think you're facing, particularly with things under the hood, or have the cars been driving nicely? In the mine?
No. I mean, there's a few things that I think we haven't gotten to the point where it makes sense to tackle, right? Like, we're still fairly early stage ourselves, even though we've been operating mines for 4 years. You know, we've trying to solve, like, we're close to, like, our 1.0 roadmap is close to being complete, which is easy end to end. Your grandma can mine and get wild sats direct to her wallet, right? But what I see is, like, some of the layers that we've built on, we'd love to replace with open source solutions. So one of the things we're looking at is, right now we're using a for-profit monitoring service. I don't want to besmirch them in any way here, but you know, it's kind of a jack of all trades solution, but not quite tailored for ours. So we'd love to get like something like Proto, you know, the fleet manager, and we're tinkering around with that a little bit on the side and potentially replace it so that we can take that open source solution for monitoring, you know, power, like measuring power on a per mining rig level. Because what we have to do is we wind up measuring every mining rig to see its power consumption, and then we've got to take that data on a monthly basis, push it through our billing system, which ties into QuickBooks and invoicing and payment rails, collect the funds to make sure that we're paying back our service provider. So the way we operate is we take the costs of mining and we pass them through to our customers. So we're not making any profit off of hardware or electricity sales. Instead, on the back end, we do a revenue share model. So that means that all the Bitcoin that's mined, 15% goes to our wallet. And that means that if I can't make you Bitcoin, Tyler, then I actually don't get paid.
Right, and so in that sense, you know, firmware without a dev fee or a monitoring service without some subscription cost, this all gets passed down, savings to the customer and more profit to the company as well.
You got it. So we definitely have an incentive to come further down the stack and to actually open source more of what we're doing than less. But it hasn't been justifiable until we get some of the other problems sorted out and the company gets a bit bigger. But eventually, yeah, that's the direction we're tacking to. So that's so donating to you guys is like just basically like paying it forward for what our needs are going to be in the future. It just makes sense.
I feel like this, you know, it's a slightly non-standard Bitcoin mining case, at least for what historically we've seen, right? What you're trying to build, right? This integrated system, the mining sharing. You know, I feel like the more that you can have lower level control over that system, more monitoring, more like specific controls that operate the way that you want to, you know, your customers and you can be more profitable. It actually sounds a lot like we were talking about with the solar installs too, right? I mean, it's a similar kind of paradigm, right? You're trying to install these solar panels. You got systems that are built of components from a lot of different manufacturers. You got to figure out how to get them to talk together, be reliable, and yeah, I'm excited to build the tools that can help you build this system and operate it more efficiently and just have, you know, more control and insight into your whole operation.
Yeah, I absolutely. I mean, it's interesting coming from the solar background. You know, there's a lot of like almost asymmetric knowledge that I was able to pull through coming into this industry, and it's why I wound up in mining. You know, I read Jeff Booth, The Price of Tomorrow, back in like, I think 2020, and I was like, oh, my background in solar, like, why have I been trying to do these other things in Bitcoin? Like, I belong in the mining side of things, and that's how I found SAS Mining and got started, and we've developed what we've currently developed. But, you know, solar is, I think, the only industry that's analogous to Bitcoin mining, oddly enough. You know, some of the properties that I think they hold in common are they're both decentralized, right? And I'm talking specifically rooftop solar. So there's nuance with solar, like there's nuance to every industry on the planet. You know, I'm not talking about big industrial fields full of solar panels. I'm talking specifically utilizing real estate that's already there. So when you look at like rooftop solar, it's decentralized. It's distributed. It's emergent. Its main hardware is coming from China. You are also confined, your profits are, to an energy grid. And you are also, what's the last one? I'm forgetting it, but there's a sixth one. And taking all these properties together, there's not really that big a difference between our industry here in mining and solar. And so there's some parallels that I've been able to draw. And one of those was, hey, coming into this, solve the customer's pain point. And my thesis was that there's a lot of people that actually want to get into mining, but it's just been too complicated. And so these open source tools are absolutely critical. They need to be developed by the tinkers in the garage. Saw the exact same thing happen in solar, but then they need to be scaled to the masses, right? So you need, like, the combination is the winning ticket.
We got a deep dive once you remember that 6 point on Pod 256, I think, on the analogies
Yes,
between the
100%.
solar industry. That's super fascinating. I hadn't thought of it that way. I've heard you mention that to me before, but yeah, super exciting. The open source stack, that doesn't exist in solar, really, does it?
No, there's like inverter communication protocols.
Sure, have been standardized.
Have been a bit standardized, right? Because, I mean, here's the thing, like so I'm again talking rooftop solar. Like if you have, let's say, a 20 kilowatt array, or you got a big barn, you got a 20 kilowatt array on it. Do you want one 20 kilowatt inverter, or do you want 4 or 5 kilowatt inverters? And the answer is you want 4 or 5 kilowatt inverters, because if your inverter goes down, it's not your entire power system, right? So how do you get all those inverters talking to each other to make sure that they're not fighting each other when they put out their sine wave? There has to be a communication protocol. And what happens if a manufacturer stops producing their inverter, but you still need to replace that 5 kilowatt inverter with another brand? Well, now you need a standard communication protocol, right? So these things exist in multiple industries that we're having to build through here.
And they take time. I'm
Yeah.
sure it took forever in the solar industry, yeah.
I'm not even sure that it's totally solved, to be completely honest. Some of the things that are also similar, like the IV curve, right? So like maximizing your power, like multiple PowerPoint trackers. That was a big source when I was in the industry and left about 2012, 2014 sort of time frame was going on. Do we want those contained in the inverter? Do we want those out on an individual solar panel basis? Because maximizing the IV curve is how you get the most amount of power, right? And so if you don't know what I mean by that, if you look at power versus current, right, there is a curve by which you can draw the actual output, right? And so solar panels produce power, chips consume power, but it's the same concept. If you want to maximize the power, there's a point on that curve on which voltage times current is the maximum, and that's where you get your maximum output. So how do you get there? And in solar, that was called MPPT trackers, right, where they would sort of tune in on where we can actually get the maximum on a per solar panel basis.
I wonder, like, when you're developing these systems, whether it be in Bitcoin mining or in solar, right, you kind of, I imagine there's all-in-one solutions, or there's some all-in-one solutions, but they're kind of, limited in what they can do, right? It's like, there's this all-in-one solution, it'll do X, Y, Z, and you're like, oh, but I kind of want to do this.
Well, I mean, from a residential solar, like, yeah, there was solar in a box sort of systems that you could buy, but for the most part, when you were talking about an actual scaled out, hey, I want to no longer buy my power from the grid, those are construction projects.
Yeah.
And there was hundreds of pieces that went into them. And yeah, certainly people tried to figure out how we can streamline different pieces. But in general, you had the panels, you had the rack the panel sat on, you had an inverter, and then you had your tie into the grid, right? Those are kind of the general components. And each of those were like refined, but everybody was buying different panels, different inverters, and coming up with their own overall solution to offer the end consumers. And it's one of the things, in my opinion, on why solar has struggled to scale very well on a residential level is, the built environment is incredibly different. Like, I was working for a publicly traded company, and we were installing rooftop solar systems, like 100 plus a month across 9 different states. And I'm telling you, the solar system you install in Massachusetts is not the same one as you install down in the Inland Empire in California. Like, those have different conditions, ice, cold. You know, it's not dissimilar from Bitcoin mining. Like, you need to deal with cold when you're in Wisconsin. When you're in Arizona, you need to deal with heat, right? Just simple things that are different. So the built environment really changes things and makes it difficult to have a one-size-fits-all solution if you're in the outside of a built environment instead of perhaps in the inside. You know, your electric circuitry is pretty much the same across the U.S., right? You want to. Speaking of protocols, you want to plug something into the wall. You know, if you have a typical outlet plug, you're going to be able to plug that thing in.
I know you have a lot of Bitcoin mining installations all around the world, and I'm guessing it's pretty similar. Like, there is no one-size-fits-all situation, right? You're dealing with the local, conditions at each site.
Yeah, I mean, it is different everywhere. For the most part, we've done air-cooled, and what you see is places that have more cold conditions, you need less cooling, right? You can do just more general fans, but like in Paraguay, right, where we have a lot of swamp cooler-esque, like water curtains, right, that we're using to cool. And those all have different performance criteria, and each of them, what I see happening in our industry is we're still learning about what works and what doesn't. And so like the iteration, like when I first came in, the first containers I saw are very different than what I see today, like 5 years in. And that's because we're learning. The feedback loop is there. Like, oh, let's give a little more space so that the people that are actually working in these things can function, right? Like basic stuff like that. The engineer that's sitting in the background, dealing with the blueprint and schematic doesn't think about, but then the guy out in the field says, shit, I keep hitting my head. This sucks. Like, let's make a little space.
We're totally learning it in real time. It's an emergent industry. It makes it exciting. It shows how early we are. But I just reiterate, I think we can all learn together as an industry and share specific knowledge. That's what I think the power of open source is. Kent, I know you got to run here for a meeting soon, but last comments, where can people find SAS Mining?
Oh, sasmining.com, please. At K Halliburton if you want to DM me on X. It's probably the best place to reach me personally. But just really stoked with what you guys are building. Thank you.
Thank you.
I mean, it's something that's absolutely critical to the growth of our ecosystem and to allow more people to come into it. And I know that a lot of the folks right now that are looking at what you're building are more the guys in the garage that want to get hands-on. And I don't think that that's where it will be in the long term. I think that this is like a layer of open source critical software that's going to get sucked into other people's tools and processes and allow them to scale. I mean, that's what I see for us at SAS Mining. So thank you guys for what you're doing. And, I hope we hit a block here.
Thank you. Yeah, fully agree. We got to chop it up on the pod sometime.
Let's do it. Scott.
Thanks, man.
Tyler.
Thanks, Kent. Should we do a quick update?
Let's do an update.
1.2 exahash, still crushing it thanks to Electron.
Block counter is still at 0, but
Block counter is still at 0. We still got an hour and a half to go, a little bit more than that. 2208 active workers. Let's see here. Electron leading the charge with a full exahash. Oh, this one has 2 IPs.
Ooh, 2 IPs. Uh-oh. It's because it's
the same IP with upper and lowercase x's.
I like their Noster, Neat Bulldog 30 at primal.net.
the Neat Bulldog.
Nice Hash, shout out to Nice Hash with their 120 petahash bought with USDT. We might get a live feature of some of the Nice Hash crew. I know they're flying in for the Texas Energy and Mining Summit as we speak. It'd be great to have them join us here on stage. Dylan's Rental's crushing it. Wrigley, shout out to Wrigley, Block Party, Telehash. If you like this type of event and you want to just do more of these, definitely go check out wrigley.io where you can join their next scheduled block party and have pool payouts. So you don't win the full block, but you do get a substantial portion of that when you just team up with a handful of other users. Click here in case of mined block. We got to click there when we mine a block. Exergy, we're still heating the office. Actually, how hot is it in the building? Oh, it's only 77 degrees on it.
Are people in the building?
Yeah,
Yeah,
Tyler,
it's 5 o'clock.
you should tell us what's going on there. What's the setup? Why is this so funny, and why is it so rad?
Okay, so this is Home Assistant, which is an open source OS to manage IoT devices in the home. People might use it to connect like a Google Nest thermostat and a Ring doorbell camera and all these things together. So you have one app to monitor your whole smart home, smart lights, etc. Schnitzel mentioned HassMiner. He built one of the first integrations to control Bitcoin miners as IoT devices in the home. And we've built some custom integrations. We should ultimately merge to HassMiner just for certain home-focused miners. Things that come to like are like the Avalon miners from Canaan, where their firmware exposes unique API features like heat mode that like an S19 wouldn't have a heat mode, right? Or a temperature set point, right? Because these are space heater-focused devices. So we've got a handful of them in the office back in Denver, and we've connected a couple miners into the ductwork for our thermostat 2. So when you call for heat on the wall thermostat, stage 1 is actually the Bitcoin miner, stage 2 is the gas, etc. We've got radiant floor, we've got a heated hot tub, all this fun stuff. And I created a mode. Oh no, the let me see. The extension is hiding. There we go. So I created this mode here called Max Mining Mode.
Max mining mode.
And when I click this, it disables all the thermostats in the office, and it cranks every miner to full power. And so the caveat is the building will reach 80 plus degrees.
Sauna mode.
You see I have a scheduled option here, Max Mining Scheduled. That's actually based off of our, if I go to the Energy tab, our time of use rates. So our off-peak is 5.9 cent power. All these miners are actually profitable off-peak. And then we have the off-peak window. If I click this and edit it, like I can edit when the schedule is. So this is the off-peak schedule.
Yeah.
So the automation knows if I turn on that scheduled max mining mode, basically whenever power is 6 cents and no one's at the office, I gave it a window, from 11 p.m. to 6 a.m. Just crank all the miners, sweat out the building, and then at 6 a.m. it will recover the temperature.
So it checks to see if anyone's in the building?
I could link the motion sensors we have from our security system. That's actually something I should do, such as if say we got a late night party going on, it won't trigger the automation. This is all the kind of fun stuff you can do. And we actually have the Claude MCP connection as an integration to Home Assistant. So all of this complex automation, I'm literally just talking to Claude Code. I'm saying, hey, here's all these Bitcoin miners. I want to do this automation. This is our time of use rate. And I think it's going to make smart home IoT stuff much more accessible to people, because it's a bit overwhelming when you add all these devices. Every additional device you add adds a whole nother layer of possibilities. But you just describe the automation you want, and it'll build
You
it.
should have like a max heat mode display in the entrance or something, and whenever it's running, like it's
a light or something.
It's light
Some
up,
light.
yeah. So like an old
Sirens or, like,
neon
warning
a
lights?
neon sign.
Entering max heat mode.
Yeah, so we've got these are all the different apps from Home Assistant, Ocean Pool, so we can see some sats, Brains miners, What's Miner miners, Canaan miners. These are our thermostats. These are the temperature sensors, etc. So it makes for a fun automation. I want to get the next thing I want to do is bring in difficulty and actually embed the efficiency of the miners. If we have the API, we can read out the efficiency, but build out logic where the building knows, not just based on time of use, but it knows basically if the Bitcoin price is up or difficulty's down, oh, this miner is now profitable, turn it on. So not just based on a time-based schedule, but a profitability schedule. Only run this miner when it's profitable.
And to make things more complicated but more awesome is, right, miners can be underclocked to get additional efficiency out of them.
That's right. The AI tuning rabbit hole here could be incredible. And then lastly, we have a heat dump. So our heated flooring system, the boiler, it heats the floors on the first floor. We actually also have a dry cooler outside. So if we turn off the pump for the heated floors but keep the miner on, it will dump that heat outside. So that's a way to not bake everyone in the building. If the power's cheap, we can just heat the air outside.
Nice.
So we're getting like half a petahash out of the building. When the hot tub's on, it's more like 700 T. So that's a fun one. That's all these miners you see from Exergy here. We're heating the whole office. 6 petahash from Compass Mining. Shout out to them. Another awesome hosting company, SAS Mining. Awesome talking with Kent. Hardestblocks.org.
Cool website.
Oh yeah, great website. See some of the blockchain's hardest blocks.
Hardestblocks.org is just a
go to
cool,
it.
like, it's pretty nerdy, but I don't know, we're into this stuff, so we can talk about it. But the idea here is that, when you solve a block, that just means that the difficulty of that share is over the network difficulty. But you have to be just over it. And so some blocks, it turns out, thanks to this website that we can see them, some blocks are significantly over the network difficulty.
Yeah, I'm trying to get it to load here.
So it's still loading, but error loading. Okay.
But you can see some of the notable blocks here.
Yeah, so he's got the Genesis block, the first block. I think
2.5 thousand was the difficulty. 2.5K.
so. The difficulty of the first block was at 1. The network difficulty in the beginning.
I think that's my understanding. Yes,
I
but
think
here
it was
actually
one.
says
And the CPU guessed 2.5 thousand.
Yeah, so good job, Satoshi, with that one. Blew it out of the park. So, and then they have it kind of ordered by the first million difficulty, the first billion difficulty, first trillion, and on. But the network difficulty right now is 130T, right? And so
Right about here.
we see that there are blocks that are
Oh, there we go.
significantly more. In fact, that first one at the top.
I mean, the highest, the first one at the top should be the highest, right?
Yeah, I think so. There we go.
50E.
October 3rd, 2022, when the network difficulty was 31T, they got 50E. So
one-
it's like,
2 orders of
1.6
magnitude.
million times higher.
oh yeah, 1.6 million times.
A
So
little bit of an overachiever.
yes, a significant overachiever. You obviously don't get any more reward. You get the block reward.
When was that solved?
2022.
Yeah.
So I don't know. This is just a geeky thing.
There
but
was
it's-
one on 15th of May, 4 days ago, that was 1.7E, which is 13,000 times over. So they still happen.
1.7E, you're right. 4 days ago. There it is.
Isn't it sad? Like, you mine a block, and then it's like, it's so much over the difficulty, and you get nothing more.
You get nothing more. But you're certainly not gonna.
If it's pooled mining, yeah.
You're gonna submit.
you don't even get a
if
bigger
it's solar
reward. Yeah,
block,
you don't
right?
get a
Like,
bigger
Well, you
reward.
get an entry on this page.
You do get an entry on hardestblocks.org.
Yes.
Longtime supporter of Pod 256 and the Hash
Yes.
Dash.
Cool website.
Big fans of them.
We should
It's worth it right
maybe
there.
that's one thing we should do as a 256 Foundation. We should make like an award together with Hardest Blocks and hand it out if we can find whoever that person was.
Well, I was wondering what the hardest, because you had that awesome talk, I think, down in El Salvador about 6 or so open source blocks in the past 10 years.
Yeah.
It'd be cool to track highest difficulty of the open source blocks.
Yeah, I was originally right around the time the BitAxe solved its first block. It was I don't know, maybe a little bit less than 2 times.
It was Bitcoin Nashville 2024.
Yes, Bitcoin Nashville 2024. I think the difficulty was like, I think it was like in the 70s, 70 something T, and the BitAxe block was, it was like 150 T. So it was like twice. I was like, that's crazy. It got twice, the network difficulty. And so then we're talking about what is the hardest block. And so we were trying to kind of manually figure this out, which was not as easy. So I don't know. I was always stoked to see this website.
Which, by the
Super
way,
cool website.
if you go to mempool.space right now, there's something other interesting going on. Foundry just found 6 blocks in a row.
6 blocks in a
Yeah.
row. Look at that.
Wow.
And now the last block is 34 minutes ago. So
So they're waiting for us.
They're waiting for us.
I think so, yes. They paved the way.
Pave the way. Got all the easy ones.
And now, like,
Got all the easy
Come
ones
on.
out.
now it's your time.
Yeah, this is kind of insane. I mean, it really shouldn't be this way. I mean, there shouldn't be anyone that has enough hash rate to command.
Yeah,
that
they
many
have
blocks.
30%. Like 30% is enough to find 6 blocks in a row.
Is it?
Yeah, they have 30%, yeah.
That is just madness. And this happens fairly regularly. I feel like we see this quite a bit
Yeah.
now, that Foundry solves 6, 7 blocks in a row. And then if you look at mempool.space, it's basically like foundry, ant pool, foundry, foundry, ant pool, ant pool, foundry, ant pool.
Yes.
So mining's, we can see the sort of estimated hash rate distribution on that pie chart down below.
This is not true, though.
Yeah, that is. So who solves the block is actually self-reported. It's totally optional and it's not verified, right? I mean, if we wanted to, we could put Foundry as the block that we're going to solve today. So this is totally self-reported and not verifiable at all. So the pie chart just picks off what the blocks have self-reported that they, what pool that they're associated with.
But there might be some white labeling going on.
There's definitely some white label. There's another chart from, I think it's OX10 BC that kind of, they try and guess what pools are actually white labels, like which ones are actually just proxies for one another, and makes a new pie chart. Stratum.work.
Stratum.work, yeah.
So, they try and do different things where they look at the payout addresses associated with the blocks and try and correlate that to miners. And it's obvious that a number of them are working together.
Yeah, so
we can see
all the same colors.
when a row here has all the same colors in the columns as one next to it, that's a pretty sure sign that they are working on the same templates. It's pretty unlikely that two unrelated pools would have exactly the same template.
Yeah,
that they
or
mined.
different blocks, but the same output, right? The Coinbase output being the same can also be an indicator.
Yes,
Like
definitely.
there are all these 6Ks here. They have different templates, but these three have the same Coinbase output, so they go to the same place.
So
This is a really cool website from our friend Boris. It's really neat because he has to connect to all these mining pools and get the work that they send. So he's continually connecting to every single mine pool and saying like, what template do you have for me at any given time, and then parsing that and putting it all in this.
It's an open
format.
source project.
That's right.
You can run it yourself. Yeah. The problem is for some of these pools you need a username password.
Yeah. So he must have
you can't
some
even-
friends. Like, how do you get on a Foundry? Right. That's a
Right.
private pool.
I don't know.
So-
Is Foundry on here? I don't think so.
Oh, that's a good question.
I think we just found a block. The network, not us, but
Yeah, maybe
I
Foundry's
don't
not on
see
there.
Foundry on here.
Okay. Maybe that's
even Foundry can't actually verify who is who. That's the next thing. Like, if somebody gives him a Foundry username password and just never minds, Foundry also couldn't figure out that it is the website. I mean, maybe based on the
client.
IP address, yeah.
Yeah, probably not. Probably not. But they would, yeah. That's the other thing is most all pools, if you don't actually mine, will kick you off. So it's got to be sending at least some minimum amount of
Is he
hash rate to
connecting
all
with
of these.
miners or what?
Yeah, because the pool won't send you, if you never send shares back to the pool, they'll just kick you off. So yeah, he's got to be sending at least their minimum number of shares.
He's a hero.
He is a hero. This is a really cool website.
Super cool.
He has some it gets really crazy, like these Sankey charts.
Timing. So this is timing when they send work?
Yeah, that would be my guess.
No.
Hey.
Oh man. Data overload.
Yeah, I think this is trying to
Oh.
pair up the templates sent from each pool and see how they compare. Like we're seeing this grouping here, right? 21
Yep.
pool, Lincoin, SPI crypto. We know that I think Lincoin is confirmed a white label for SPI crypto. Yeah, you got Binance, Brains, Cloverpool, right? These are all confirmed the same templates from all of them. So there's a high likelihood that those are essentially the same pool. So anyways, all this is to say is that hash rate distribution chart, or pool distribution chart, I guess, is it's worse than it looks.
It's a bummer that we don't even have insight to Foundry here.
Yeah. Yeah, I don't know. Maybe they don't white label it.
Yeah, super cool website.
Super cool.
I mean, we could go
Stratum.org.
to Foundry now and saying, hey, we have an exahash. You want to just forward all the hash rate to them? They find more blocks than we do.
6 in a row.
Yeah.
Zarka, Daryl, Guardrail, Thack777, Tesserae, DJW, Ryan. I
Oh,
don't think
FutureBit just joined.
Where?
200 petahash at the
Woo!
second place. Scroll all the way up.
Wait, Ryan, what's this Skunkworks project?
That's in my garage.
Sounds pretty
all good
Skunkworks.
Skunkworks projects
Whoa,
are.
new highest hash rate. I think this is the highest hash rate perhaps of all 4 telehashes.
Oh, definitely. 1.4. Boom.
Should we add a little more?
You want to add more?
Yeah.
Okay.
I think we're going to add a little more.
We're going to a little more. Just turn
a
on a
little.
couple more miners.
Just a
Schnitzel
couple.
found a few more miners up his sleeve.
Maybe you have a couple.
Yeah.
Turn on
Maybe
a
a
couple
couple
more.
hundred.
Okay. Couple hundred miners.
That's right.
Fire 'em up.
FutureBit, there we go. 200 petahash from FutureBit.
Wow.
Excited to see John. I think he's going to be here this week for the Texas Energy and Mining Summit, right?
Yeah, definitely. I think I got a message that he's here.
Amazing.
He's here. He's in
Amazing.
town.
Yeah, they're doing some cool stuff with home miner node all-in-ones. Almost very similar to this in a sense, a productized version.
Yeah, a productized version of that. I think they have a new miner.
Apollo
that's
3?
Apollo 3, 10 terahash.
Maybe up to 14. It was a little confusing because the chip efficiency doesn't just multiply by the total power output of the device.
Okay.
You know what I mean? Like the efficiency goes down at higher output. So
Yeah, sure.
Yeah, I forget. but-
Overclocking. Yeah, that makes sense. There's sort of an interesting dynamic there between hash rate and power consumption.
Yeah.
Makes sense though. You overclock, you get more power, you get more hash rate, but not linearly related to the power. Well, yeah, not linearly related to the power. But yeah, the FutureBit Apollo is cool, and it is the first, certainly the first of its size miner that is made in the USA.
Incredible.
Yeah, they're using. I mean, all ASICs are made in Taiwan, but it's from an American company. It's from Ardine, so he's got American companies' ASICs in there. The whole thing is designed. I think a large number of the boards and stuff are assembled in the USA. So that's cool. It's good to see.
It's super cool. I hope we can see one in the next day or so. We should also give a shout out to the Mara Foundation, and
Yes.
the big takeaway from the Las Vegas conference was an opportunity. Mara launched the Mara Foundation, which is their effort to support Bitcoin, the protocol, open source projects, Bitcoin education, an effort led by our friend Isabel at Mara, now at the Mara Foundation. And they kickstarted this with an announcement from Fred Thiel on the main stage on the first day of the conference on Monday, and then offered the opportunity for a competition between 3 projects to win $100,000 from Mara to issue based on community votes. So there was online and in-person voting in Las Vegas. The projects were the 256 Foundation. We were honored to be a part of that, as well as Libreria de Satoshi and Satanet. So Satanet is ISP internet for some African nations. Obi's behind that project. Obi of Fedi, awesome guy. And then Libreria de Satoshi, my understanding is Bitcoin education in Latin America.
That's right.
And it was a hard-fought battle, bouncing back and forth from different votes throughout the course of 3 days. So it was announced in the afternoon of Wednesday, the last day of the conference. And we were fortunate enough to win that vote.
Yes.
Yeah, so we have been awarded a $100,000 donation from the Mara Foundation, which is super exciting to see. We obviously see a lot of analogies with what we're building and how it can help large mining operators like Mara, who actually solo mines, which is pretty cool.
Yeah, I think they're one of they're the biggest miner that solo mines, meaning that they run their own pool, right? I think that unfortunately most of the other big miners don't mine to their own pool. They'll use someone like Foundry or some other service to kind of handle that side of things, make their block templates, and yeah, Mara runs their whole stack.
What do we got here?
A
Oh,
new
boy.
record.
1.7. Oh my gosh, all the way up.
All the way up. Who is that guy? 500 petahash from Schnitzel.
And
There's
the
more
fish tank.
coming.
Don't forget the
Yes,
fish tank.
my fish tag gang helps. 500 gigahash versus 500 petahash.
500 gigahash, 500 petahash.
Which
That's,
BitX is 500 gigahash? The first one?
The 40, the one before the gamma?
the oh gosh, the
New
Ultra.
all-time
The
high
Ultra.
here.
The Ultra was 500 gigahash. You got 2 miners, 1 million times different hash rate.
It's coming in hot. I think we're going to cross
1.8.
2 exahash here.
1.9.
Whoa.
This chart's gonna blow off the top here.
Yeah, not for long.
Blowing off the
Gotta
top.
hit 2. I'm taking a picture.
I know. I got to.
It's gonna get
I
higher.
gotta tweet this.
I want to be on the top. I'm going to hit Electron. If Brains does what they promise.
Michael's going to quickly
Electron
jump.
just texted me, sent me a telegram, let's fucking go. So
It's on, boys.
it's on now.
Oh, there it is.
There it is. 2
2
exahash. Boom.
Wow, we're like
2.5? Want to go 2.5?
Yes.
Amazing.
2.1.
2.1. You're duking it out here on the pie chart, Schnitzel.
Yeah, what's the
oh.
number 6 on the loyalty?
Already.
Dylan, I have you in 3 minutes.
You might dethrone Electron briefly here.
Oh, and yes. That's the goal.
Because of the fish tank axe.
Yes.
If you
gonna
rented
put
1
you over,
exahash
yeah.
and you have the fish tank axe, you'll beat Electron.
Oh, there it is. He
No, I
flipped
rented
him.
a bit more. I wanted to make sure that I get it.
The flippening.
Make sure to screen cap this.
So John is saying he could join us in like 20 minutes.
Okay. Let's do it.
I got a screenshot for you, Michael, at the very top. Poor Dylan, he's asleep.
Woohoo!
Wow.
Moving up
2.3.
fast.
Look at it climb.
Wow.
Mike, can you buy 5 exahash? Okay.
For 1
You
second.
can't actually.
What's the limit?
Right now they have. There's another exahash available. The total they have is 3.
There's 1 exahash available.
Finance says no.
Put it on the Amex,
Well, you can.
and then refute the charge.
You have to buy it with Bitcoin.
That's smart.
Yeah.
That'd be so degenerate if they accepted credit cards and you just like got a bunch of 0 interest credit cards and were spamming hash rate rentals. It's got to
All
be.
right, 2.4.
Actually, I think that's one of the few ways you can buy non-KYC Bitcoin with a credit card is hash rate rentals. Certain services will accept credit card. I know Dylan's keen on this.
Oh gosh, he's just maxing them all out.
I don't know maxing them all out, but it's just more private than buying on an exchange.
That makes sense.
Yeah.
2.5.
I got to get another screen grab.
Yeah. And a 1,000 sat donation. Thank you.
All right. Thanks, Anon. Yes, you can donate sats. Go to dash.256f.org
That's right.
and get that get that Lightning donation address. You can send it in there. If you send in if you
Here's
put
some
a
comments.
comment with your Lightning payment, you can get on our prestigious Lightning chat.
Yeah, I got a few nice messages here. Electron Rocks, Bonanza Time, Top 4 Loyalty, Bedtime for Me.
That's Dylan.
Yeah. Fantastic. Blockite 950,000. I didn't realize we passed that. Thank you for the Anon 1,000 sat donation. What else should we talk about here?
This little game, or looking at these numbers that we've been doing the last couple minutes, makes me think about stuff we talked about a few times, probably in our meetings or hanging out in Vegas or whatever, and that is the role of dashboards, gamification, interesting payout schemes, community mining pools, and stuff like that, the role that has in encouraging decentralization, really, because, let's be honest, most of us with a BitAxe aren't going to hit a block, so there are other ways to make this fun, and all the way to the point of where, like, a competition, right? Like, so we're sort of sitting here and we have 2.5 exahash because
That's crazy to think about.
Schnitzel wants to one up Electron, and maybe someone wants to one up Schnitzel, and we're playing a game here, but we are actually increasing the security and distribution of the Bitcoin network at the same time. So, what? I don't know. What do we see in the future? What would make for these?
Well, I want to give a shout out to Parasite Pool, right?
Yeah.
They have a pretty cool payout structure
That's
that
right.
could be implemented into Hydra Pool and other open source pools, which allows, my understanding is, if you mine a block, you get a full Bitcoin. Anyone who mines the block gets a full Bitcoin, but the rest of the payouts are distributed fairly in pool mining mode.
Yeah, that's right. I mean, that's a really cool idea, right? It's a novel new payout scheme. I believe it's open source, the Parasite Pool implementation, so you can check it out. I mean, I think more people need to be experimenting with this. And to your comment about making it social, a lot of people are mining because, well, they're just like, I don't know, they're techies. They're interested in it. They're interested in Bitcoin. They're interested in hardware. They want to be doing this. They want to be involved. But, it can get a little bit lonely because you're not solving blocks on the regular. Whether you're solo mining or you're pool mining, you're not making much sats, right? So I think adding these social aspects to it is really important, right? Because you want to show off what you're doing. Like, you want to show off, I don't know, what kind of hardware you're running, what's, the crazy worker name you have is. So I think this is really cool, and I think it is spreading sort of awareness of solo mining, which is an important part of Bitcoin. I really do think solo mining is important, especially with these lower hash rate miners where you're just not going to make any money pool mining. I think you should solo mine. Obviously you can do whatever you want, but I think solo mining is important, and this just increases the excitement of doing it.
It certainly does. I know that, and now you can't game it and just go live when Pod 256 is live because we've got the loyalty dashboard. The loyalty
Yes.
leaderboard. Thanks again to D++. That's part of the benefit here was you could just turn on your hash rate previously before we had the loyalty leaderboard when we were live for the podcast, in which we usually read a live shout out to all the current hashers. But now we'll be able to see who's actually long-term committed to supporting the organization. You can do all kinds of fun stuff. You could, as we've said, the Bitcoin veterans have forked this dashboard and modified it to their liking. You can do the same for your group of friends, your company, your organization, whatever it may be, to make mining more fun, more interesting, and more engaging. Schnitzel, I see you in 4th place on the loyalty leaderboard. You passed Dylan. Bummer.
No difficulty yet.
No difficulty yet. Hopefully you can get one of the hardest blocks. Well, I want to point people towards a new resource that we just curated, and that is the new 256 Foundation forum.
Oh yeah, this is cool. We haven't talked about that yet.
We
This
have
is really
not.
cool.
Forum.256foundation.org is now a discourse forum, good old-fashioned forum style, where there are categories and topics, and you can make an account with just an email address. And it's really serving as I think Ryan framed this well to me when I was trying to understand better what goes in GitHub, what goes in the forum. And the forum I really view as like the application layer of trying to get started, asking novice level questions. How do I do this? I asked a comment yesterday, like, what are the best practices for hacking Mujina onto other miners, which we talked about a little bit on stage here with Schnitzel, all the way to organizing the Mujina dev call office hours that we do, scheduling things of that nature. Really, we aim for this discourse forum to be a central knowledge repository for guides, tips, and tricks. We can mark topics as solved. We can introduce new concepts. We can have a whole thread that deep dives into something very specific, like how to flash something onto a specific miner. And then the GitHub repository for each of those projects really is, we don't want to muddy things up here. It's where the developers, the contributors will live with their comments, their pull requests, their merges, things of that nature. So it's exciting to have this forum. I mean, it's already been pretty helpful. Things like the calendar for upcoming events. We got the Telehash here live. You can see when our next podcast will be once we get on there. The dev calls, linking to all the different categories. Yeah, it's been pretty good so far.
You know, before we've had a Telegram chat room, and we had a section on the OSMU Discord, but those chats they're sort of fleeting, right? It doesn't sort of add to the ledger of knowledge and discussion and everything that's gone into that, and it's definitely not indexed by search engines. It's very helpful to have that live chat, but then it just kind of vaporizes and isn't really searchable. And so I think this is going to be important to capture all this and keep it there for the random person that might just Google a question and show up.
And not even just a person Googling a question. That was a huge unlock for me is the AI agents will Google the question. Yeah, whereas they wouldn't go join a Telegram group chat and find an answer to something. But this properly does index the conversations, the topics, the categories, such that all of the inherent knowledge of everyone building on the open source stack should be recorded and logged, which helps us skyrocket and accelerate development.
Yeah, we can't discount the effect of lurkers, basically.
That's true.
They just will never sign up for this, but they're just reading, they're following along, and then at some point it's going to click and they can jump in. I know that I lurked on Bitcoin Talk for years before ever doing anything. So
yeah, so come check it out. We have a good amount of people joining this forum. It's a pretty new thing in the last couple weeks. The developers are our moderators, and then Scott and Eco and I are the admins. Feel free to introduce yourself in the general category. There's also links to everything else. Like if you do want to join this Telegram group chat just to shoot the shit with more people interested in the ecosystem, the link's on there for that as well. Also to the Hashdash and everything you may want to find. Yeah. Why'd you sigh? What happened?
We haven't found a block yet.
Oh no, we haven't found a block yet. Buy another exahash. Let's see here, 2.4. You're still in the lead, Michael.
Now I'm trying to tease Electron to send some more, but they stopped responding in the Telegram. So either they're sad or they're plugging in more miners.
We still have another hour to go. Someone said, with the leaderboard anyway, to reward total uptime to the single BitX plebs. Anyway,
that's a good idea.
Reward total uptime to the single BitX plebs.
We've thought about this. We had a discussion about this. One of the problems is it's impossible to verify what's a BitX, what's a pleb, what's a small miner.
But you could figure out the longest connected miner.
Yeah.
You could based on time.
Yes. That's not what they mean?
No, I think they mean like have a separate loyalty leaderboard for the small miners, but that's an arbitrary definition.
Yeah, that's an arbitrary definition, and you could potentially, if you wanted to game it, you could by splitting up a single miner.
By the way, Megawatt really dropped off. They really left.
They really curtailed.
Yeah.
It's almost like they signed a contract or something.
I guess their software is working.
We
right?
got to refine that contract to say,
Not
except for
doing
Telehash events, we will shut.
The
Well, maybe
utility
we should-
sends the signal that like energy prices are 10xing, and they're like, yeah, you know, it's a Telehash. We'll leave it on.
We got John in the room now, here from FutureBit. Should we have him come join on stage and talk about
Yeah.
what he's working on? John,
Totally.
take my spot for a little bit. Ooh, he's got a box, too.
Oh, he's got something
Oh.
to show and tell. I like this.
Ooh. Breaking news. Alpha.
Hey, hello.
Hey man, it's good to see you.
Good to see you. We're filling 8 hours. Maybe you can help.
We're doing this. We're doing
this
this
man a
crazy
microphone.
Telehash thing. Have you heard about this?
I know something about that.
Yeah, you've heard about it. I feel like. Let's see. You're on this list, huh?
Am I working here? Hello, hello.
Yeah, you need to eat it.
Yeah, I don't know. Where are we at? I think we're having a bidding war. Might have to bid myself up again.
Yeah, you got to get those numbers
there's
up.
definitely a bidding war right now.
What's going on? Am I on there?
I saw you on there before.
Oh yeah.
Oh, we got Agent P on the list.
I just bid
Garage
myself up.
heater. All right. Well, I mean, basically everyone knows you, but what's going on? Who are you? What are you doing?
I literally just came from the factory.
You just came from the factory.
Yeah.
Well, what kind of factory? It's like a
Our production factory. It's in Austin.
production factory. It's in Austin.
So
What are you producing?
We're ready to launch the Apollo 3. We launched it back in February, and we're full on scaling right now. We have to ship a lot of units, so it's a crazy scaling thing right now, and getting the units in and shipped out. We're going to start shipping probably end of the month. So it's been a crazy time of flying back from Brooklyn to Austin and dealing with production problems and the whole 9 yards of hardware.
I love these details, but what's going on in this factory? Like, what are they doing in there?
So this right here, we do all of PCB fab, PCB assembly, and then end assembly of the product.
Very nice. So you're making the PCBs, like
Yeah.
So you're making the PCBs. That's the boards without any of the parts on
Yep.
it. That's the. I don't know. I guess I saw yours are black. Normally they're green.
Right.
But that's a pretty involved process.
Yeah. It's there's not a lot of fabs in the U.S. There's a few in Austin actually, and the
Interesting.
one that we use is pretty cool. We've partnered with them for a while. You know how it goes. It's the quality. You can't find quality fabs.
Certainly
abroad.
not at a. It's. There's lots of manufacturers, but as far as I understand it, with PCB manufacturers in the United States, they're just all very expensive because they
Yeah.
like to gouge the U.S. government on ITAR
Right.
stuff.
Yeah, they all do military contracts, so they're
Right.
used to charging crazy amounts for PCBs. So we convinced this guy, this company that listen, we're going to be the next consumer product in the U.S. and they went on board with it. They're like, yeah, we'd love to help you guys out, and they've been able to match pretty much Chinese pricing, which is pretty crazy.
That is crazy.
Oh, wow.
Oh, wow, yeah.
That's really crazy.
So.
So they're making the PCBs in the factory, which is a crazy complicated process. This is like, multiple layers, like different
Drilling, etching, soldier
electroplating.
mask, all
yeah.
that, yeah.
And so then, all right, so the PCBs come out, and then you got to solder all the parts on there.
Yep, and then it goes to our production line where there's a bunch of SMT machines that pick and place all the little components and put the ASICs on. Goes through an optical inspection process, then goes into the oven where everything's baked, and the finished PCB comes out.
And so you guys are pretty unique in the Bitcoin mining world in that you're the only one doing this with like ASICs, mining ASICs from a U.S. company.
Yeah, I mean I've gotten a little flack with that because I guess there are a few small companies that do it, but as far as I know, we're the only one that does it at scale. Thousands of units. So at least that I know of. So
This is huge. I want to talk about this on our panel tomorrow, but we can talk about it now too.
Yeah.
Like, it's probably tough to know exactly, like, what percentage of the hash rate out there is on, like, non-Chinese ASICs?
It's very little.
Very little,
yeah.
right?
I mean, most of the hash rate is from Bitmain, obviously, What's Miner, and Canaan are the top three. US based, I would peg it at probably 5%, 10% if we're lucky.
Yeah, there's Ardyne, there's
Intel, whatever they did, but
Intel, but those are probably aren't running anymore.
Yeah.
There's
Whatever Block is doing.
those probably aren't running yet.
Those are the top
Yeah,
manufacturers that are making actually USA engineered chips right now. So
that's so cool. That's so cool. We need to see this trend change.
no, we do, and I hope. I hope Block's going to be a leader in that.
Yeah.
Obviously, unfortunately, we partnered with Auradine for a while. We helped them develop the chip, and as soon as the cycle went down, they just bounced. They went straight to AI. So.
They just There's got to be a lot of pressure to do that. So I don't know.
Yeah, it's hard. It's we haven't we've been in this business for 10 years now. We haven't found a single partner that can last a full cycle. It's insane. They spend $50 to $100 million to develop these ASICs. They develop it during the top where they're like, okay, we're going to get $100, $200 million worth of orders. They start shipping in the middle of the bear market. They get half of that and they go bankrupt. And then it's like just a repeating cycle.
It's hard to overstate how insanely complicated and resource intensive and expensive it is to make these ASICs.
Yeah, that's what people don't understand. It's the stuff you do and what we do is it's complicated, deep engineering stuff. But when we go to the ASIC level,
oh man,
that's orders of magnitude more complex, more capital intensive. It's insane, and there's very few people that can pull that off.
I mean, I've heard
people, let alone companies that can pull it off. So.
I've heard, and I tend to agree with it, that ASICs, is 3 nanometer, 2 nanometer ASICs like this, are the most complicated things humanity has ever built.
Yeah. I don't think
Probably,
more complicated than that, other than crazy edge physics.
Yeah, I mean,
engineering
2
stuff.
nanometer is like 8 silicon atoms wide. We're talking ridiculously small.
Yeah, I mean, the ultra, the UV stuff that they're doing now in Taiwan is like at the edge of light physics, So
it's even more ridiculous that these companies would just get into this and then bounce.
Yeah, that's what I don't get it. We were hopeful with Intel. We pushed Intel to do the chip and open it up to other people. And I really thought they were going to be it. That I've talked about this before. I was pushing them. It's like, listen, you guys opened up your computer chip back in the 80s, and that's what created this whole crazy PC era.
Yeah.
Because of Intel, they opened up their chip. Because in the early days, the CPU was the exact same as ASICs are now. They were all closed off proprietary chips, and very few people had access to them. And what Intel did is they opened up their chip to other hardware makers, and that's pretty much what created the PC revolution.
Yeah, that's a really interesting paradigm. I think that's going to happen with ASICs someday. But
I think
Intel doesn't make computers, right? They do not make computers.
Yeah. And I think we're at the edge of that. I think me, you, and a bunch of other people have convinced enough companies that there is a market here, and I think people are going to start, open it up. And that's what's really going to make things cool is when, there's not just 5 manufacturers. There's dozens doing dozens of different applications, and that's when it's going to get really cool. So
yeah. I mean, especially with the hash rate heating stuff. I mean, there's just limitless potential customers there. Like hash rate being deployed. Once we start getting these into hash rate heating type scenarios.
Yeah. I mean, the applications are endless, and that's kind of we'll probably talk about this a little bit tomorrow, but we're kind of soft launching FutureBit for builders. So we're going to open up our platform to other people that want to use the hardware we've engineered for the past 10 years. So anybody that wants to, have a USA ready-made board and integrate it into heat use applications or any other type of system that we don't do, then we don't have the bandwidth to, we're trying to launch 3 products this year, and I'm like maxed out. So there's so many products that we can build.
I mean, it's a brilliant idea, right? Just increase the number of customers for yourself, right?
Yeah.
This is what I think. It seems so short-sighted on the point of lots of these major manufacturers in Bitcoin mining. It's like you only make this one product, and there's the customers for those, but like we want to buy your stuff,
Right. Yeah.
Like sell us your chips.
And everybody's like so closed off about their tech. It's like it's not what it's about.
We're not gonna steal your IP just because we bought your chip. Like
Right.
the barrier to entry on making a chip is impossible, even if we did know how it was made. And you're not going to tell us exactly how it was made. We just want to buy them and make machines.
And you've seen how tech is, shaping up with AI. The barriers to entry in terms of software are pretty much gone now.
Yeah.
So it's like our moat is USA production at scale. I know that's going to be a hard thing to capture. So I'm not worried about, and first of all, the market's so big that, there's people shouldn't be worried about that kind of stuff. It's like we're just in an early point of Bitcoin's history, especially on the hardware side, that we need to be building as much stuff as possible with many applications as possible. So
yeah, we really do.
We got a long way to go, and it's just the early stages.
It's funny. They're like the ASIC manufacturers. They're like pivoting out of the space, and here we are. Like no. We want to create new markets for you. Not only do we want to buy your chips, but we want to create a whole new market for people to buy your chips.
Right.
Like,
and they're just short-sighted.
Like, no,
they can only see, for the next quarter and what their profit margins are. And they're not deep enough into Bitcoin like we are for them to understand that, this is a much longer game than just, what's your bottom line for the quarter.
Which is what do you see, right? The fact that now they're just all pivoting into AI.
Right, yeah.
And whatever the next thing is, they're just chasing
that's what's
the tail.
the most disappointing. It's like I've worked with a lot of people for so long, and, I thought they were going to be in for the long game, and this new shiny object, comes along, and they're like, bye.
But they're also are they a public traded company?
Who?
Auradine? Or whatever they're called now?
Yeah. I mean, it's dissolved as far as I know. I don't even know. They just pivoted completely to AI. So.
I don't know. I guess easy come, easy go. But yeah, I mean, these bear markets don't last forever. But hopefully we're set up a more solid foundation for when the next bull market comes. Like
we've been around this for a long time. We know how it goes. So as long as we build a foundation, like you said, and the tech is there, and what you guys are building, and where the industry going is, I think it's going to be a good future.
I have a theory that maybe some of these chip companies, they just don't, as you've said, they just don't need a small market. They don't care. If I can have one customer relationship with a big company, make all my money there, that keeps things simple for me. I mean, it's very simple to support the one company, whatever. But I feel like, if enough of us builders sort of can pool together somehow and convince at least one of these guys to break and sell into the catalog market, essentially.
I mean, that would be the holy grail, right? It's like I wish, we could get enough capital to, we've helped with ASICs, but we've never fully committed to building one ourselves. So, if the industry gets big enough, that would be cool. If we could pool our resources together to build an ASIC from the ground up, that's open source, that anybody can use, that would be insane.
That would be insane. I mean, I don't know about open source ASIC, but at least an ASIC that is like available and documented, right? And that you can buy it.
Well, I mean there's nothing that, so the thing with how, I don't know how deep you are into ASIC development and how it works. So there's